Thank you. Thank you. Thanks for having me here. Yeah, I want to tell you a little bit about recursion and recursive starks, and actually today is a very meaningful day to give this talk because today we're actually turning on what I'm describing here in our production systems for basically StarkNet and other systems that go on Sharp, and I'll explain all of this. So something I'm describing here is today going live. And in order to explain what recursion is and why we're excited about it, I need to tell you about three things before that, about Stark proofs, about Cairo, a programming language, and about shared proving, or Sharp. So usually the way things go in our system is that we have a program that is going to be executed for a number of steps, and there's an input and then an output. So most programs tend to look this way. And after that, what is happening is that instead of asking Ethereum to execute programs, as it would do with, let's say, if you write Solidity code, smart contracts, you would ask all nodes of Ethereum to run that program and basically naively replay the same computation that you've done. In our system, what you have is someone off-chain runs the computation and then does extra work to create a Stark proof. But what you save from that is that what is sent on-chain is just the proof, not a request to do the computation again. And this turns out to be much more efficient in terms of gas, because the verifier then checks the proof, and if the proof passes the checks, then you accept the new state of the system. And this turns out to be much more efficient. So to give an example, let T denote the number of steps of your computation. Think of T, usually I have in my head 1,000,000, so like 1,000,000 steps or 1,000,000 transactions. Then if you would send the program directly to layer 1, all nodes would need to do roughly 1,000,000 steps, or T steps. Instead, what we do is an off-chain prover spends more time, T times roughly log T, so the logarithm of 1,000,000 is 20, so instead of 1,000,000 steps, it spends something like 20,000,000 steps. But in return, what the verifiers need to do on-chain is not 1,000,000 steps, but logarithm of that, roughly, which in the case of 1,000,000, and taking logarithm, that would be 20. So instead of 1,000,000 steps requesting the blockchain to do, now you've gone down to 20. And it also scales very well, because if it was 1,000,000,000 steps, the logarithm of 1,000,000,000 is actually 30 to base 2. So things scale very nicely. And this is the way that Stark proofs work, and we apply them to the execution of any program written in Cairo. That's why over StarkNet, developers write in Cairo, and that's why all of our systems that are running in production for a year or two have been written in Cairo, because it turns out that the proofs are very efficient. So to give an example of how you create, or how this applies to a layer 2. Usually in a layer 2, what you have is the main thing that the L1 chain knows, so Ethereum knows, is just the hash of the state of the system. So the state is represented by some Merkle tree. At the leaves there are various accounts and objects, and basically when transactions come in, you operate on them and modify this state. So the input is usually the previous state and a number of transactions, and then you run a Cairo program that updates the state with integrity, according, doing the right thing that should be done, and you have a new state. And this new state, or its hash, is the output, Y. And the transactions could be a variety of transactions. You could have a request to transfer 10 Ether from Bob to Alice. Someone else wants to mint a Bored Ape NFT, or send an Oracle price update, and all of these things modify the state of the system, and then you get a new route. So far I explained the state of the system when you run one program. Now what is Sharp? So first of all, Sharp stands for shared proving. And today we have already in production several systems running, and all of them need to be proved, right? Because the way our system works is we don't send single individual transactions to the blockchain. We actually batch together many transactions and send them. And we have Starknet, Immutable X, Sorare, Diversify. These are all systems that are running either in alpha, Starknet, or in production for these other folks. And roughly a single proof cost, verifying it on-chain, is roughly 5 million gas. It changes a little bit with the type of the transactions, but it doesn't vary very much. So it's, think of it as some constant cost per proof of roughly 5 million gas. And then if we would just send a single batch, let's suppose that each one of these applications roughly has, once per period, they have, let's say, 3,000 transactions. So let's do some math here. If we send and create a proof for the Sorare system, then we have to pay this 5 million gas for verifying it, and it's divided by 3,000 transactions, which comes out to about 1,700 gas per transaction, which is already pretty good. However, if we can take together many of these systems and actually generate a proof that asserts to the correct update to each one of these things in a single proof, then you can get much better savings, because if you have 3,000 transactions in each one of them and you send a single proof and it's roughly 5 million gas, then you get around 400 gas per transaction. Now, the actual numbers of gas per transactions that we have in our production systems are pretty much of this nature, and often even less. For instance, when we mint NFTs for the Immutable X system in large batches of 600,000 per proof, we reach even a cost gas of roughly 10 gas per minting of a single NFT, which is way better than what you can do on-chain. So the more transactions we can batch, the lower the amortized cost per transaction that we get. And this system has been running in production for a very long time. So I just want to pause here and say that it's something that I also said in my talk at BITL, and I repeat it often, which is that so Starkware's strength is not necessarily in marketing and PR, but we're very strong when it comes to engineering and putting things in production after hard work, things that work very well and rely on a deep engineering and math stack. So the concept of Sharp, of taking a single, within a single proof, seamlessly proving several different statements, or rather more technically, the thing we're proving is actually some meta statement. Think of it as proving that some bootloader program has executed correctly, where the bootloader can boot several different programs and advance each of them. This is something that is not done in any other L2 or validity rollup system. We've been doing it for a very long time, and it's very powerful. And it's just one more innovation coming from Starkware that, again, you probably haven't heard about it before this talk, because our strength is actually in writing code and making systems work, less so in telling the story. So this is something that has been running for a while and is making our customers very happy and saving in gas cost. But now we actually want to increase the scale even more, because that's what scalability means in our eyes. It's a technology that you can 10x and 10x again and again, and it has it's not that it doesn't have any effect, but it has very limited effect on the L1 costs. In our case, basically, since the verification time is logarithmic with the size of the throughput, every time, roughly, I mean, I'm waving hands here, but every time you 10x the throughput, the verification cost should go up not by times 10, but rather by +1 or +10. So each time you increase by a multiplicative factor of 10, the work on-chain additively goes up by a small constant factor. That's a good way to think of it. So you multiply the throughput off-chain, you just add a little bit of work on-chain. However, when you reach things like 100K transactions for each one of these, then putting them on a single big prover machine starts to become cumbersome because this machine would need very, very large memory and a very large number of cores. And there's only so much today that you can get on the cloud with a single big machine. So we need to go beyond that. And that's where recursion comes in as being helpful. So recursion is a very beautiful and deep notion in computer science and mathematics. It's also a very, very powerful paradigm. It's tightly related to the concept of induction in mathematics, and it goes a very long way. So, but it's also a little bit, sometimes it's sort of hard to grasp because it gives you this feeling of, you know, like these infinite mirrors and something that goes on and or reverts to itself. So I'll have a little bit of feeling of that in what I describe now, but I hope you'll appreciate the power of it. So right now what we have is we start with, what I want to emphasize is that we start with programs and we end with programs, but that operate with a smaller number of time steps. So we start with some program A and input X. And actually what happens, we send it to this prover machine, and it generates some output, which is a proof. What do we do with this proof? Well, this proof is fed to another program, the verifier program. So also on the right-hand side, we generated a different kind of input, which is the proof, and that proof goes into a verifier. So this is the proof of program A. Well, you're probably already thinking, if you can prove the correct execution of any computation, you can also prove the correct execution of the computation on the right, not just on the left. And that's exactly what we do with recursion. We say, okay, let's take what came out on the right and let us generate a proof for it. So what would the proof say? The proof would assert that the following claim: I received a Stark proof of program A and I verified it and it passed the checks. That's what you would prove now. And now you have, on the right-hand side, you again have input to another program. I mean, it's actually the same program, just with a different claim. So part of the beauty of it is that just like, well, a very important thing in recursion and induction is that you start from a statement and you go back to exactly the same statement. So as long as our statements are about generic runs of computer programs, which is the case here, you can basically apply recursion or induction and do it again and again. So the statement above was, I ran a certain Cairo program and it executed correctly. That's what happened there. But the program was called A. A was maybe, I don't know, immutable X. But if you have it for the general case of general programs, basically, I received some hash of a program, and a hash of a basically bytecode of Cairo, and I ran Cairo for yay steps and received output. That's exactly what you also run on the right-hand side. But just on the left, you run it with a program A, and on the right, you run it with a program that happens to be a Stark verifier. And you can do this again and again. So we can generate a proof and then send this proof again to be Stark proof, so its verification can be Stark proof. Because maybe I should pause and say another thing and go a little bit deeper. So Cairo is a Turing-complete programming language, which means you can express any program in it. And the way actually the Cairo verifier works, and again, this has been going on for a very long time, is that what it receives as its input, as the reference to the program, is actually a hash of the bytecode. And all our systems work, the statements that we prove say, we ran a certain program whose bytecode's hash is this, this pattern, and we ran it for many steps, and we received a certain output. So once you prove these kinds of statements, the hash of the program can also be the hash of the program that is the Cairo Stark verifier, which is exactly what we do with this recursion. So if you feel a little bit sort of queasy with this sort of looping and, or this Escher kind of picture kind of thing, right? You're getting a grip of it. That's exactly what's happening, and that's what we're doing. And as I said earlier, this thing is turned on in production starting today. And then you can repeat this, of course, again and again, because these are all just cases of programs. So why would you want to do such a thing other than to confuse yourself and feel queasy? So I want to mention a few things that you can get with this. So first of all, you can basically break this barrier of a single machine and parse proofs in a different way using a larger number of smaller machines and thereby get greater capacity and lower cost, both L2 cost, meaning the cost of the computing devices that you're using to generate the proofs, but also the cost of L1, amortized cost per transaction. So right now we're taking a whole bunch of programs and generating proofs for them. Well, we could take one proof of a program that said, I ran verifier on input A, and I ran it on input B. So it's a new program that takes two proofs of programs, and generates one proof of a program. So it's a little bit like hashing, right? You take two inputs, and you just receive one. So you take here two proofs, and you generate one proof. And now you're probably thinking, oh, so you can do this again and again and generate a tree and compress things further and further, just like you do with Merkle hashes. And that's exactly what we do. So roughly, we take two programs. Each one of them runs for T steps. We have two proofs. Each one of them is much, much smaller than T steps. And then we feed this thing, which is roughly now two log T steps, and we get verification time that is much smaller. Now, you would think that this verification turns out to be the log of 2 log T, which turns out to be roughly log of T, but I'm not writing that because there are some absolute lower bounds that you can't go below. So you get lower, but it doesn't go down to like 0, or it doesn't really go down, you know. It goes down a lot and makes things much more efficient, but there are bounds, and I don't want to go into math explanations of where it stops and why. So much, much smaller. And you get larger proving capacity from this. And then you send this final proof on-chain, and it covers the amortized gas cost is now even lower than it would have been previously. It also helps with reducing latency. So first of all, it helps with just dealing with larger batches of proofs. It also helps with reducing latency. Why? Because what we can do is apply this recursion tree. And now what we can do is, we can basically, instead of the Sharp system, for instance, which took, let's say, 4 programs, but then generated one proof, which basically placed these transactions, then these, then these, then these, and operated on all of these 4 different batches of transactions and generated one proof, which took much more time and also required bigger machine. Now what you can do, you can send each one of these different systems in parallel to its own prover. So you save twice. One, you don't have to do things sequentially. You can do them in parallel. And the other one is that these are on smaller machines, on smaller input sizes, so the proofs come out faster. And then what we do, we have already these objects that are roughly log T size and not T size, and we can apply this thing of recursion where we prove recursively that we checked 2 proofs and then have one output and do this again and again, and basically our latency is drastically reduced, and that's another reason we're now deploying this thing in production. So you save twice. You don't have to wait for many transactions to accumulate. And and you have these different programs for which you compute each one in parallel. And now with this case, you just have to wait for T steps. And if one of them finishes earlier, you can start generating its proof, and then also log T in these further steps. Another really powerful thing, again, that I'll repeat this, that Starkware is not that good necessarily with telling and spreading its gospel, but it's very good in innovating and delivering on technological innovation, not just in presentations like this, but actually in like working code in production. So L3 is another very interesting concept that we're going to deploy. So everyone's talking today about layer 2 and how they are the scaling solution, right? The solution to scaling problems. Layer 2 says we can have the exact same security properties of layer 1, but sort of they are somehow inductively or recursively, magically applied to a next layer. And with Stark proofs, the math and cryptography of Starks assures you that indeed the security of your layer 2 is exactly the same as that of layer 1. Now, again, the beauty of it when you have these proofs that prove the integrity of a computation is that you can apply even this notion recursively. So you could have another layer that sends proofs to a verifier that is on layer 2, and that would be a layer 3 system. And now the layer 2 system would send a proof of transactions, including that it verified a proof on a layer 3, and send that to layer 1. And so now the same security that you get from layer 1 goes inductively to layer 2, but also to layer 3, and you can continue this process. But we'll stop it at layer 3. So, by the way, this is something that, for instance, you cannot have a layer 3 on an optimistic rollup. Or rather, it wouldn't save you anything because the witness data from a layer 3 and an optimistic rollup would be needed to be rolled up onto a layer 2 and from there to a layer 1. You don't really get much compression. So with optimistic rollups, it doesn't make, you could define layer 3, but also the whole arbitration process becomes extremely complicated, right? If there is a fraud proof initiated on a layer 3, you need the layer 2 to intervene in the layer 1, and also the witness data doesn't get compressed. But it does work beautifully with Stark systems. And in fact, one of the things we're going to do over the coming months for all of our existing StarkX systems, the ones serving Immutable and Sorare and these, we're going to move them to become layer 3s onto StarkNet. So instead of proving, we could take the sharp verifier and submit it. We could take a proof generated by the sharp system and send it to the StarkNet verifier. That would make these systems all a layer 3. And then, so you have Ethereum. On top of it, you have layer 2, which is public StarkNet. And then you can have a whole bunch of different flavors of layer 3s. You could have them for validiums, which means that the data availability is not relying on L1 or on L2 in this case. You could have roll-ups, which roll up to layer 2, and then from there to layer 1. And you can even have custom StarkNet systems. So if someone wants, let's say if, I don't know, City of Seoul wants to have a StarkNet that is dedicated only to, local residents here, works at higher speeds, then you could have such a system that feeds as a layer 3 into the StarkNet layer 2. And then you have all of these different proofs. They are sent. Now they're sent to a layer 2. There is a program already existing today. That's the program that's basically the recursive verifier. So to get recursion done, what we did is instead of writing the verifier in Solidity, which is how our layer 2s work, they report to a verifier on layer 1, we wrote the verifier in Cairo. So the verifier for a Stark proof of a Cairo run is now written in Cairo itself, and Cairo is the language of layer 2. So you can write this, you can run this as a smart contract on layer 2, and basically you're done. So this way you can actually fit many L3s into StarkNet, and then your L3 input footprint on layer 1 is even lower than what StarkNet will give you. It also gives you much cheaper L3 interoperability because the messages are now sent between different L3 systems, not through layer 1, but actually through layer 2. And so you can move very freely between different roll-up systems. And so I just want to say that, yeah, so, okay. There are like many advantages to running an L3, because you could say, why would I want an L3? I could just write smart contracts and put them on Starknet. But you still may want to run your own L3 in which you have full control of, for instance, the proving framework. So you could decide, maybe you want a dedicated system like StarkX that deals much better but with a very limited use case, let's say of payment processing or swap trading. You could deploy your own contracts. You could filter transactions if you want on a layer 3. Maybe this is something that won't be possible on a layer 2, but maybe for regulatory reasons, you actually need a system that doesn't allow all transactions to go through. So on a layer 3, it will be your layer 3. You can decide what you let there go. Your block creation time, you decide on it. You don't have to wait for the sequencing and proving process of layer 2 to happen. The fees are going to be much lower. You can decide if you want to run a centralized system or decentralized. You have better privacy. You can decide on the data availability mode that you want. Maybe you want to work with your own data availability providers. So there's a lot of advantages to having a custom layer 3. So when recursion, as I said, today is a very special day. Today recursion, so it's been already, we finished the development a very long time ago, and it's been running in parallel to the production systems for a while, and today we're turning it on in production for all of our Sharp systems, and so it's a very happy day. Summary. Recursion, like Sharp and Cairo and Starknet, are the results of the maturity and Turing completeness. The Turing completeness of Cairo, the ability to generate proofs for it, and all of this is production grade and humming, and we understand very well the whole stack. Recursion is really great for scaling, lower gas cost, higher proof capacity, lower latency. It enables even higher scale than what you get, things like layer 3, interoperability. It's in production today. Saying again, we're not that good with spreading the word. Maybe you can help us, but we're actually pretty damn good when it comes to making breakthroughs and things that seem impossible work in production. Thank you very much.
Hello, hello. Thank you. Thanks everyone who woke up early for these presentations. I know it's hard. It's a Saturday night in Seoul. All right, so I want to talk about building for usability. I want to talk about that for the most part, usually as blockchain, as systems, as crypto engineers and developers, we are so excited about building technology that we forget about that we're building for users. And so I do want to kind of dive into this, but first I'll give a quick overview of NEAR as well, and then we'll talk what are the things that we've seen developers and users really want in this ecosystem. So our vision as a whole is to build a world where people control their assets, data, and power of governance. And I think a lot of us in this ecosystem in Web3 share this vision because, Bitcoin started with this idea of controlling your own money. It extended to assets with DeFi. The data, I think, is, there's probably no single person who loves giving all of their data to Facebook or similar entities. And the governance is just your voice, your power to actually affect the outcomes of any decisions, right, which you are a member of. And this is especially true with recent world developments. And from our perspective, the way to achieve that is to deliver something that's simple to use, that's secure and scalable, and is sustainable. Now, the way we measure this, right, is how many people are actually actively engaged in this world, right? And so we have this audacious goal of getting 1 billion people to actually use this and through building the most usable blockchain. We're about 21 months post mainnet, and we're about 0.7% complete. So still a lot of work, but you know that the rate of adoption is accelerating. Now, the way we're doing this is not by building kind of a company, but actually by having an open source ecosystem. It starts kind of at the core with a protocol, but then it expands into various infrastructure players, into various go-to-market and approaches, and various vertical application that actually serving the end user. So just to mention some of the infrastructure, kind of the Near protocol itself, right, is just kind of a protocol with some open source implementations, and there's a lot of different companies already contributing to build it. At the same time, these companies have their own businesses. They have their own kind of products that they deliver to the user or developer. And so infrastructure ones are like Pagoda, deliver a Web3 developer stack that allows you to build kind of everything, have all the tools, manage your contract lifetime, have analytics, have triggers, and more. You have Calimera, which allows you to run private shards, which run inside your firewall of the company and allow to run contracts which kind of process private data with pretty much on the same namespace as all the public contracts, so they can actually interact. Beyond that, you have interoperability, right? None of these blockchains live in a vacuum. There's a lot of other things going on, and so from the start, we've kind of established to build the most trustless permissionless bridge, which is Rainbow Bridge. It connects Near with Ethereum through a light clients, very much similar to IBC approach, but it is kind of the only actually light client bridge to Ethereum at this point. You have something like Aurora, which allows to run all of the Ethereum smart contracts on Near through a pretty much EVM virtual machine just running as a smart contract. And so this kind of general idea is that as we push for interoperability, more and more of things can be just run in the VM on top. At the same time, there is cases when you do need a more custom chain, app chain, and this is what Octopus allows you to do, is to spin up a completely different chain, but then through linking your runtime and through linking your security into Near, you actually have both interoperability with Near and with all the other chains directly. Now, technology is good, but at the end, it's all about actually, getting applications to build, getting developers to adopt this, right? And so instead of trying to kind of fit everything through, for example, Near Foundation, which is, as well, very centralized approach, we have kind of spun out a number of ecosystem funds and verticals that are specifically focused on different types of developers, right? So one of the examples is Proximity, which is specifically focused on DeFi applications, and they are, working, helping, giving grants, sometimes helping writing code, kind of doing anything that's needed to grow the DeFi ecosystem. Similarly, you have Human Guild, which is doing that for gaming. They host, founder-to-founder sessions where founders help each other as they figure out kind of details of token economics and gaming. And more of such funds, for example, for sustainability that we're starting. The idea in general that, this ecosystem has so many different verticals, so many different approaches that you want different kind of teams that are solely focused on specific vertical to go in and help out projects. But also beyond that, the world is, vast, and although kind of being global, you still want to have local presence around the world. And so we started that actually in China originally because China has, very different language, very kind of disconnected information space. But since then, we launched already 4 other hubs, and we're launching kind of 3, 4 more in this quarter. The hubs are really kind of a local version of Near. It creates presence, it creates community, it has its own funding, it has its own product lab to build and help other people to build. And it allows to kind of really create presence that's local, that knows the language, that has kind of connections in the community in this place, and through that grow kind of this Web3 vision in that. And kind of really excited in starting one in Korea. Now, the way we see kind of the application growth is through three kind of specific verticals, right? I think finance is at this point pretty clear that I think everybody knows that finance has to go to market with blockchain. There's still obviously a lot of things to figure out, but there's a clear need, there's a clear want, and I think like traditional finance is going to be merging into with DeFi and kind of creating a single space over time. And so through that, you have DeFi, you have a lot of like on-ramp, off-ramp, connecting to real world, allowing to pay, allowing to stream, kind of all of this toolkit that you need. The kind of less product market fit, but something that people get is creator economy, right? I think like a lot of artists understood the power of blockchain through NFTs because it allows them to kind of capture future resale price and kind of participate with their community very actively, which they could not do through Instagram or through YouTube. They don't really care about censorship resistance as much at this point, but they already understand kind of these connections that crypto can create. But beyond that, you have games, you have kind of music, art, all of these various things that are coming through the creator. They actually are the source of economic value in kind of our Web3 ecosystem, and they are what pulls in more and more people. And the third final part, I think that's extremely important, is social, right? We are, at the end, social kind of creatures, and social, has been going through a lot of turmoil, and, there's no single kind of current social platform that wants to do censorship, that wants to do kind of the moderation that they are must do. And so they all are trying to figure out how to become more community kind of focused, while you have now new social platforms starting up that are started with specific vision of community owned, censorship resistant, etc. And so like this is something that does not have yet a very clear product market fit, but it is, from my perspective, coming. Now the three main verticals actually create a flywheel. The more you have people coming for creators, the more they will want social, because that's how they connect to their creators and their fans. The more you have of this economy created, the more financial tooling you will need that will actually bring more people into the creator economy. So you have a flywheel that actually accelerates the more you have on any of the sites. Now, this picture, like we've presented this for, I don't know, a year and a half. This picture always had this something missing. And the something missing is like, how do people get into the system? Because if you think of like a random creator in Philippines, they don't have an initial, fee to pay to sign up or to mint first things, right? And the answer has been throughout past like 6 months is a way to onboard users through a various kind of tools like Move to Earn, like Work to Earn, like Something to Earn, where you don't need to actually buy in to start participating in the economy. You are able to pretty much trade your attention or your time for crypto directly and kind of efficiently. And so Sweatcoin being one that has like 100 million downloads already and 10 million users. Tracer is launching here in Korea. You have NearCrowd, which has been around for a year and has like 2,000 people working every day actually collecting data for machine learning problems. And you have Brave, which is just direct attention to earn. And so you have all those ways to that actually onboard users directly into the system and get them assets and something to have. Now, kind of behind all this is the idea that usability matters, right? At the end, like if we want to get to 1 billion people, this means most of the people will not know what blockchain is, what blocks are, hash function, any of those things. Probably a lot of those people think like Facebook is internet, right? That's kind of a pretty prevalent understanding right now. And so most protocols don't actually mention how they're going to be building for usability. How's it going to make it available, right? Like you cannot, if you're talking about, how we create a new cryptography, it's really hard to think how do you actually get it to users in a way that understandable. And the things like scalability, the things like security should be going hand in hand with usability. Because at the end, like scalability we're doing because we want to deliver a better experience to the users, which does not kind of change when you have some application becoming successful. Security at the end is something that is like should be straightforward to the user and should not scare them. So I'll dive in a little bit for the developers first, and then we'll talk about the users. So the reason for developers first is, first of all, here we're all developers, and we think kind of first. And myself being developer, like I wanna make sure my experience is good, right? Because if my experience is good, like I can spend more time making sure my user's experience is good too. And so kind of the idea that starts is like, well, my experience is good when the tooling is good, but also the platform itself, the thing I'm building on does not give me complexity, and at the same time gives me the kind of capabilities and scalability they want. And so the only way to scale is to parallelize. I think at this point everybody's agreed on that. And there's just different ways of parallelization, one of which is modularity, right? There's L2s, L3s, L4s. And it allows to have a kind of more experimentation across the stack, which I think being beneficial for everyone. But it does lead to kind of a overall drop in performance, right? If we're talking about latency, if we're talking about the complexity of UX, of like how exactly you're thinking, and again, like obviously, some of these things are very subjective because you can think of like, well, L2 is a new L1, and then if this L2 is L1, then it doesn't really matter. But that's not true. You have lots of L2s right now that you kind of work in parallel, and like the comparison I can draw is back when PCs were coming out, they allowed for a lot of experimentation. There was a lot of different different GPUs were produced, different mother cards, different CPUs. Like they all tried to fit in with each other in the same sockets, but you had something like Apple, which kind of did not allow for this flexibility, and it took them more time actually to catch up, but when the innovation curve stabilized, they end up building a more integrated experience. And through this integration, they actually end up building a more better experience, and that outperformed kind of this modularity. And so like kind of the belief is that a more integrated experience will deliver better UX, and at the end will outperform as well in kind of raw performance the modular experience. And to do that, you need obviously parallelization. Parallelization means sharding, and so you need a sharding that actually delivers this experience, but then hides it from developers and users, right? As a developer user, you should not need to think, where is your application? Is it on this shard, on this layer 2, on that layer 2? Like you should not need to think of it. This should be completely hidden, and the underlying infrastructure should be able to kind of rearrange things as it needed to deliver you better performance. And that's what we've been kind of building from the start. Now, it's a long journey. It takes a bunch of time to actually get there. We've launched with actually 1 shard, even though like most of the stuff been built. We actually resharded to 4 shards late last year, and with the point that there's been 0 impact to the developers or users. Like nothing changes, even though there's kind of more capacity of the network came in. We're launching a chunk-only producers this September. And this is the idea to actually expand more validators on the network, bring in kind of validator nodes that will be validating only specific shard. I mean like rotating, but validating only single shard and a few shards. And through that, pretty much enable us to get to kind of final nightshade, where you have no nodes at validating all shards. And the final stage is where we get this kind of fully dynamic resharding, is this idea that at the end, it actually doesn't matter where exactly your contract is if the network is smart enough to actually allocate you the resources you need, right? And so think of on near, each contract can get up to a full chain of capacity, right? So, and we actually have this right now. Aurora runs actually on a dedicated shard and has a full chain of capacity as if they run their own separate L2 or a separate Cosmos chain, but they don't need to handle any of the validator stuff. They don't need to handle any of the RPC stuff. They just deal with their own kind of application space. And so the idea here is actually get to the state where it's dynamically reallocated based on the load of your contracts. So think of Amazon where you pay as you go for what you take, not for all the capacity pre-allocated. On the other side, as developers, right, we want tools. We want experience, and so kind of from the start, we've been trying to build something that is very pleasant, very nice. We have everything from command line interface that allows you to interact with blockchain. We have I'll show in a second a tool to create near app in 5 seconds. We have all the stack of tools in JavaScript and Rust and some bunch of stuff in Python, Swift. We have things like wallet selector that allows you to kind of embed directly into your app. Multiple major RPC providers, including Pagoda and Infura. You have data reads, which, if you're a developer, you know that data reading is actually bigger problems than sending transactions right now. And you need to, if you want to actually scale, to actually have 1 million users, you need to cache a lot of data. How do you do that? We have a framework for that. You have analytics triggers and a lot of stuff on Pagoda. You have Rust, and I'll talk about JavaScript, education, and a bunch of other stuff. There's more developers building cool stuff every day. Now, I'll mention JavaScript because, first of all, we kind of have a full launch. Now I'm lost in time zones, but on August 8th, tomorrow. And the kind of high level is, JavaScript is probably the most, well, it's not probably, it is the most kind of used and known language in the developer space, and the idea is that now you can actually ship Web3 code directly to blockchain without learning any new languages, without kind of needing to figure out anything. It is getting on a feature parity with Rust. It's as simple as write some pretty much create near app, select JavaScript, select what front end you want, and just run, like you have a JavaScript smart contract, you can edit it and just yarn deploy, and it's on testnet, and yarn start to get the front end running, and you have a pretty much full app live with JavaScript smart contract, and you can go and edit the smart contract and upgrade it actually directly with yarn deploy. So you have pretty much, in about 15 seconds, you can get a full Web3 app running, and it's in JavaScript, end-to-end, front-end and back-end smart contract, and you can kind of continue iterating on it as you please. And it's all links through the Explorer and everything. And so the reason why this is possible is because the team that's working on contract runtime in Near Protocol has optimized the WebAssembly about 7x since launch. And so we end up getting able to run a QuickJS, one of the JavaScript machines, a full JavaScript virtual machine as a smart contract on Near. So this is the same idea as Aurora in a way, because Aurora is an EVM. Like we took a piece of EVM code and just run it as a smart contract. And so this just showcases you how powerful you can be on Near is just taking existing applications, existing platforms, and just running them and customizing and building things on top of them. So check it out. It's, there's a QR code or pagoda.co/JS-SDK if you are interested and want to launch something today. All right. So going forward, we talked about developers, right? And I mean, developers are close to my heart, but at the end, it's about users, right? If we want to get to 1 billion users, we need, probably, ideally 1 million developers, but we need that 1 billion users. So we started this from the day one, is that we did not want to replicate the account model that pretty much all of the blockchains use, because that account model is confusing and it doesn't, like if you think of, your like friends who are not in technology, right? If you tell them like, hey, can you send me some money to my X5Y lowercase z address, you probably lost them somewhere there. And so we started with like, how do we get human readable IDs and how do we solve this key management problem, right? People are afraid of kind of this keys, right, in general, seed phrases, like, and so the idea here, near accounts have a username, like ilya.near, and a number of keys with different permissions, right? And so think of them as devices or as, applications. So when you are adding a new device, let's say you're adding your phone, it actually can add a new key, a different access key for your specific device, which means you can always disable it, you can always kind of program it for specific reasons. You are allowed, it's possible to give a key specific permissions and allowance, right? So this is very useful when you want to have for example, your game front end to have a special key that only can interact with this game up to some amount of money. And so you can only authorize this key once through login process, and then your front end of your game can now interact with the blockchain on the user's behalf without going to the wallet every time. Right, so that kind of flow where if you want to breed a new animal and you need to go to a wallet to approve that transaction, you don't need to do that. You can just approve kind of breeding as a permission and then just do it as the user interacts. Obviously, you can build customizable multisigs, right? Like you can think of your phone and your desktop. Maybe on the phone you limit yourself to only spend $1,000 per day. And so you're not tempted, but also if in case phone is stolen. The more interesting, you can actually delegate to another party some specific permissions. And so the suggestion that I have, given most people are scared about the seed phrases, losing them, instead of just having your seed phrase somewhere stored securely, which never happens, you actually give a permission to a semi-trusted party, like a bank, or maybe a group of friends, to be able to recover a seed phrase for you with a delay, right? So imagine, you lost your seed phrase, you need to recover, you call up your bank, they do your, normal authorization procedure, and they initiate a key rotation process. It will take, for example, 7 days to actually get there, and so, in 7 days you're good. Now, if banks tries to do it without your consent, first of all, you'll see it, you get a notification about it, and you can stop it because you have the key at that point and you can actually kick them out. But then on top of it, you can actually sue them because you have a legal document with a bank. Right? Now you can have similar with a group of friends who can together recover, etc. if you don't have a bank access. And there's multiple other semi-trusted parties you can enlist in this process. And then the other really cool thing is single-use private key. You can actually generate a private key and then give it to someone to send one single transaction, right? Because after that transaction, that key will be removed from the account, so it's not actually able to use it. And so that allows you to do really interesting things, including creating an account for someone and then giving it to them to actually claim and rotate the keys, right? And so this idea of rotating keys means you can have maybe less secure wallets initially, less secure setup initially, and then as you get more assets, as your accounts become more valuable, you can actually just rotate keys. And so this goes into security, right? Security I mentioned, people are scared of seed phrases, things are getting stolen all the time, there's constant issues with contracts, with wallets, with everything. And so that's why going beyond just hey, your seed phrase is your account, how do we get to a state where it is way more active security, right? If you think of Web 2, in Web 2, we've learned a lot on how to prevent malicious activity, right? Google runs a very comprehensive outlier analysis on your actions, detecting if something is off, right? And so we're not doing this at anything, right? If you have a transaction that literally moves all your assets to a known, known stolen account, nobody will stop that transaction, right? Which seems bizarre if you think about it, right? So the idea here, you can actually have a more active custody, right? Where instead of just your account, your key signing every single transaction and that goes right away, you can have kind of a multi-sig, right, or split key with threshold signatures to enable that. You can also have on-chain audit registries for contracts, ensuring that when you're interacting in the wallet with a contract that's actually been audited, it does not have existing vulnerabilities, and it, has a bug bounty and all of the security kind of measures, right? So you can have all of this information be more actively provided to the user, instead of just kind of passively hoping that users will check that the contract indeed is deployed on this address, that the audits are done and somewhere linked in front end. And so like all of this, we kind of need to get way better at protecting users on how they're interacting with applications. Now, just to show a few things, this is creating a DAO on Near, and just kind of the interesting thing is because Near accounts are contracts, you can actually turn even your account potentially into a DAO. So for example, let's say you started by creating a bunch of art and selling as NFTs, you created kind of a royalties pointed at your account. Later, you can actually turn your account into a DAO and start, offer that as a way to manage these royalties and receive that revenue stream. So think of it as like your account becomes a business in a way that you can then kind of turn into community-owned business. But the idea is like what AstroDAO allows you to do is actually configure a number of parameters. And so AstroDAO really has flexibility to go from things like, equal community of people to a full-on like a board with, executive branch with, treasury managers with, et cetera, right? So like there's a number of like different groups with different permissions with different limits. And here another example is this like one-time link, one-time private key actually used to onboard users, right? So you can actually generate a one-time key that allows you to send a single transaction that claims NFT, like creates an account and claims an NFT, right? And so, so this example, that Satori does, that you can receive just the email link or, through SMS, through Telegram, and if you don't have an account, you'll just set up an account. And as soon as you do it, you actually have an NFT in your wallet. So that's kind of as simple as this. Like people don't need to think about, install MetaMask, or figure out like how to get crypto to claim an NFT, to mint it, et cetera. You just like send them a link, boom, they're in blockchain, they have an NFT. And you can send anything, right? You can send money to people who don't have accounts yet, because you don't need to know their account before sending this. Now, I'll just quickly go over what's next. There's a bunch of stuff that, already here, but we're still kind of only on, only starting for real. And so the kind of a bunch of infrastructure is still missing. I think like privacy is probably one of the bigger things that like we all love to talk about, but it's still like blockchain right now is still a transparency engine, not a privacy engine. Obviously, we can do a lot with zero knowledge for compression, as Starknet folks were talking about. Governance is a big thing. If we want people to govern, like we need to have tools to give people to govern, right? Because right now, one token, one vote kind of thing doesn't fully work. You need community-governed AI. My background is in AI. We're kind of getting to a lot of interesting spaces in AI, but they're still controlled by a few corporations. Like we need to unlock this and kind of hook it in with all the other ecosystem. We are working on actually some research in synchronous sharding to actually scale up some of the things like Aurora. And then I think, and I mentioned this, like traditional finance and DeFi kind of merging together, bringing together is kind of bringing real world assets, bringing crypto and banking together. And so projects like NearPay, for example, getting a banking license is an example of something that is very powerful. The other thing is that in reality, users, for the most part, don't really care which application their stuff, like which chain the application they're using is on, if it's smooth enough for them to use, right? And so the idea is to add so-called remote accounts, which allows you to kind of hide from the user kind of the specifics of the blockchain that application is on. So you log in with your wallet, MetaMask, Phantom, etc., to the application, and then it figures out how to bridge your things and how to kind of show you data from the right chain. And so there's a lot of kind of pieces to make this happen, but what this will allow to do is to actually kind of abstract out like users and applications kind of from the chain specifically. And obviously beyond that, right, is we kind of we talked about, like I talked about social, but so there's a whole graph I have of components that needed to bring social to Web3. And so we really need to start doing this right now because I think like a lot of the social is going to be like, and it's already crumbling like for various reasons, right? And social graph is probably one of the biggest pieces, but also reputation, certification, and kind of communication messaging that's needed. So just to mention, as I finish up, we have a NearCon in September in Lisbon, so everybody's welcome. And if you have questions, let me know.
So, hi everyone, I'm Janmajay and Hello? Am I audible? Yeah. Okay. I'm Janmajay and I work at Privacy and Scaling Exploration Group at EF. And today I'll be talking about Scale, which is a way to offchain microtransactions. But throughout the presentation, I'll be going through what are the different ways of performing microtransactions today, and then how we can improve it further. So, what are microtransactions? You can think of microtransactions as small transactions which are not feasible to put on chain directly. You can sort of aggregate them off chain and then put them on chain because they're not feasible to compete for the block space. So for example, you would want to pay a person, let's say $1 every 10 seconds. So it isn't feasible to actually put that on chain because even in a very optimistic case, it might be like the transaction fee on a roll-up would be like, let's say 5 cents. And if you pay them over time, it wouldn't be good for you. It would be really expensive for you. So, and in most cases, microtransactions are paid in higher frequency. So you can sort of imagine that you pay per second or per minute or per 5 minute. So you wouldn't want to actually do that on-chain directly, which is why you need off-chain transactions. So I'm here talking about microtransactions, but why do you need them? So one of the very futuristic applications that at least I have in mind and people at PSC have in mind is the mesh network. So you can sort of imagine a mesh network as a network of hotspots that actually extend your current network. So for example, it extends the internet to remote places where you got hotspots, and then those hotspots are paid for every byte that they route. So you can sort of imagine paying them a cent for a byte or less than that as well. So without microtransaction, this wouldn't be possible. You can sort of imagine turning IPFS, which is a product which is an open source product by Filecoin, into a CDN, so where you actually get paid for per byte of per byte of data that they transfer. You already have existing applications like LivePeer, the Graph, and in Graph you can sort of imagine that. I'm not sure whether they're doing it right now, but in the decentralized indexer network, you can imagine that you pay per query, right? So you could have things like that with microtransactions. You've got Orchard Network, which is a P2P VPN, where you can right now you can check it out that it's per byte. So they actually pay per byte of data that is routed through the nodes. And then you can also sort of transform the way you actually pay online. You can sort of pay per second for live shows or podcasts. So what are the ideal properties that a particular microtransaction system should have? And I believe that these are the ones. So it should be off-chain. As I said before, your microtransactions shouldn't be competing for block space because that will be very expensive for you. It should be secure. So what do I mean by secure? let's say you're doing off-chain transactions, but what if you're not able to redeem it for value on-chain? So there should be a guarantee that the off-chain transactions, the value underneath every receipt or whatever you're exchanging off-chain, should be redeemable on-chain. You should not require setup for every new interaction that you do. So for example, you've got A and B, and A is paying B in microtransactions. You don't want that when A wants to pay C in microtransactions, they will have to interact on-chain. Because, okay, fine, you can do it for 5 people, but you cannot do it for 100 people. You cannot do it like every other hour, every other hour or every day. Fourth point is that it should, and I think it's one of the most important points for microtransactions, as I said that it's one-to-one, it should be low in latency. So what do I mean by low in latency? Let's say A and B want to perform microtransactions off-chain. A should be able to send microtransaction off-chain directly to B, rather than routing through other things or using some complex routing mechanism. And I'll sort of discuss that, one of them in upcoming slides. So, yeah, so what are the systems that already exist for performing microtransactions? The first one is state channels. So, who all are aware about state channels? I guess, yeah, most of them. So, I'll briefly explain what state channels are. So, let's imagine A and B wanted to perform microtransactions. So, what A and B can do is that they can deposit certain money on chain, that is, create a state channel on chain, and then they can sort of send each other receipt off chain, which would be a replica of the state on chain, and then A and B can agree upon and then settle the state on chain. So like 3 steps. So you first open the state channel, exchange receipts, and then agree upon and settle the state on chain. So you can easily see that it's great for one-to-one exchange. So A and B can directly exchange the receipts off chain. It is low in latency. And one ideal property that state channels have is that it is secure. That means A and B have a guarantee, since they've already made a deposit on chain, they have a guarantee that they can actually redeem it for the underneath value on chain. But the problem with state channels is that you would require an on-chain setup for every new person that you want to do microtransactions with. So A and B have a state channel, but now A wants to pay A wants to pay C in microtransaction. So A will have to create a new state channel with C on chain. So that's per user that you're doing microtransaction with. Plus, we are thinking of applications that are small in value. So for example, I would be paying $5 over an hour or something like that. And locking up $5 in a state channel for an hour isn't capital efficient. And if you want to scale that linearly, it wouldn't be capital efficient at all. Because, I mean, once you're done paying the person, you wouldn't want to redeem it because the transaction fee would exceed the amount that you receive back. So it is not capital efficient. So there's an improvement on state channels, and we call them virtual state channels. Anyone familiar with virtual state channels? Okay, so virtual state channels are, so they follow the properties of state channels, but the special property that they have is that they eliminate the need of interacting on-chain for every new person that you want to set up state channel with. So the way it works is that you've got A, B, and C, and let's imagine B as the intermediary. So A has a state channel on-chain with B, and C has a state channel on-chain with B, and through B, A and C can set up a virtual state channel. That means they do not have to interact on-chain to actually have a state channel. And that's good, right? So you don't have to actually set up state channel for every new person that you want to pay in microtransactions. And it follows the properties of state channels. That means it is low in latency, it is secure. So A and C have a guarantee that once they settle the virtual state channel with B, they would be able to redeem it for some value that is underneath the receipt that they share. But the bad part about virtual state channel is the intermediary, that is B. So there's a huge amount of reliance upon the intermediary. So if tomorrow B turns out dishonest and stops cooperating, then it would be really expensive for A and C to settle all their amounts on chain. So for example, let's say A and A, B, and C. Now they've got many, many virtual state channels. There are many people connected to B as the intermediary. It would be very expensive for each and every person to actually settle their virtual state channel on-chain without the cooperation of the intermediary, that is B in this case. So it's very expensive. And this could easily turn into a situation where B might ask for transfer of certain amount of money to their account if others want to actually settle with it. So it could easily turn into extortion case. The second point is that intermediary needs a huge amount of capital. So what do I mean by this? So when A and C set up a virtual state channel, B is representing C B is representing C in this case, and B is also representing A in this case. So the amount of capital that B needs is the amount of capital A and C put in. And you can imagine that if there are several people connected to B as the intermediary, which would be the case because B is it's sort of a hub network where B is the center, B would need the capital that is required by each and every user. And that's a huge amount of capital upfront, which is why intermediary needs huge capital. So we have another thing that is Lightning Network. So how many people are aware about Lightning Networks? One of the oldest ways of performing microtransactions off-chain, right? So what a Lightning Network? What is a Lightning Network? So basically, in Lightning Network, you upgrade yourself from L1 to L2. And L2 is the network on which you perform transactions. So the way you do is that you set up a state channel or a multi-sig contract with one of the L2 nodes, and then you upgrade yourself to the L2 node, L2 layer 2 network, and then you perform transactions. So it follows the properties of state channels, that it is off-chain. It doesn't require per interaction setup. So for example, I want to send transaction to someone else on the network. So I can route through the network and send them a transaction rather than have a direct channel with them. So it doesn't require per interaction setup. And falling from state channels, it is secure. But the problem with Lightning Network is the time complexity for the routing protocol. So what do I mean by that? Let's say the Lightning Network has n nodes on the network, and A needs to send a transaction to B, and they do not have a direct channel set up between them. So what would happen is that in the worst case, it would take log n hops from different nodes for the transaction to actually go from A to B. And that is really bad for situations where you want one-to-one interaction, like it was in state channels. And I said that it is very bad for low latency because log n is not good for low latency transfers. Plus, I believe that routing protocol adds unnecessary complexity to the problem that we are trying to solve over here, that is microtransactions. And the third thing is that given the nodes on the Lightning Network are not altruistic, they would charge fee for every hop that you do. So the more the hop that you have, the greater the amount that you will pay in fee for the transaction to be routed. And that's bad for microtransactions, right? You're routing 1 cent or, let's say 1 USD or something like that. And if there are many hops, then you would exhaust some amount of the money that you're routing in fee. So, yeah, these are the problems with Lightning Network. And there's something called probabilistic payments. Anyone heard about probabilistic payments? Right, so the way it works is that, let's say we have A and B. B would set up a rate. Let's say in this case, B would set up a rate that they want to receive 1 ETH every 5 minutes. So what would happen is that A would send receipts constantly during 5 minutes. A would constantly stream receipts to B, but only one of those receipts would be valid. So that means only one of those receipts can be redeemed for value on chain. So the way it works is that A would constantly send the receipt to B, and all the receipts are invalid except one of them. So, and which is why we call them probabilistic payments. And the key over is that neither B nor A can actually game the system. So the way it works is that neither of them can actually change the probability by which B would receive a valid receipt. The point is that it is low latency because A is paying B off-chain directly, and it is off-chain. But as you can imagine, as I said before that, A continuously streams the receipt to B for this to work out. It only works for long continuous streams of payments. So you cannot do one-off microtransaction payments. The second point is that probabilistic payments are either secure or they do not require on-chain setup per user. So what happens is that in order for A to pay B, A needs to first deposit balance on-chain, and then only they can pay in microtransactions off-chain. So now if A wants to pay C as well, they would use the same balance pool to pay C. But what would happen in this case is that A can keep paying different people without guaranteeing that they can redeem it for value on-chain. And that would mean that it is not secure. You can make it secure by having A commit certain amount of balance for every user that they are paying off-chain. And that would require per-user interaction. So that means it is either secure or it does not require any on-chain setup per user. So we've got these four systems that they already exist, and I would be introducing to Scaled. So what is Scaled? So Scaled is a project that I've been working on for past 2 months, and it's an off-chain microtransaction system. And the good thing about Scaled is that it is built on top of L2s. That means it actually leverages the fact that the execution cost on L2s is very cheap and trades it off and uses that fact to actually reduce the amount of data that needs to be posted in transaction call data on chain. And that is how it minimizes the amount of fee that you need to pay for microtransaction settlement. Before I move on further, I would mention that Scale does not fit into all the ideal properties of microtransactions, and I will be talking about how to improve that in future right after this. So how does it work? Let's say B wants to pay in microtransaction to A. So what would happen is that B would first make a deposit on chain, and B would also make a security deposit on chain. And then A and B would share a receipt off chain, and the receipt is time logged as well as unidirectional. What do I mean by unidirectional? That means that using the receipt, only B can pay A in microtransaction. It cannot go the other way around. And then the receipt also records how much B owes A. And then after some time, after A thinks that they've received enough amount from B in microtransactions, A can redeem the receipt on chain for the value that it contains. That is how much B owes A. So the receipt somewhat looks like this. So you've got A's address, B's address. So A is the one who's receiving the payment off chain, B is the one who's paying. In this case, since the receipt is unidirectional, you only need B's signature. You do not need A's signature, right? Because they're the one who are receiving the payment. And B is the one who's paying, which is why we only need B's signature. Amount is how much B owes A. Expires by is the time after which the receipt is no more valid. And the sequence number records the number of the receipt. So for example, A and B share a receipt, after which A settle it on chain. But like if A and B want to share another receipt, they would have to increment the sequence number by 1, and that would be the latest receipt. So that sequence number is actually used for tracking the latest receipt that is shared between A and B. So when you actually add all these bytes, you get 201 bytes, and that's a huge amount of call data to be posted on chain. And you would notice that, and in subsequent slides, we'll be actually improving upon how much amount of data. We'll be actually optimizing the amount of data that is needed per receipt that should be posted on chain for microtransactions. So you can imagine a scenario where you've got A that is receiving unidirectional micropayments from B, B1, B2, and the same thing goes for A1. So you can sort of imagine that you've got A who's receiving microtransactions from several people, and then they take all these receipts, which are from a microtransaction, and then post them on-chain together. And together is a key over here, because that's where we actually optimize data that is needed per receipt. So why do we make it together? Why does A needs to aggregate all the receipts that they have received from B, B1, B2, and then post them together under one transaction on-chain? Because in that case, we can actually benefit from BLS signature aggregation. So what happens is that in BLS signature aggregation, you can aggregate different signatures into one aggregated signature and then post that on-chain. So we actually go from every receipt having to every receipt having the field of B signature, only one signature, and there is no need of including signature for every receipt. So we've already removed 32 bytes per receipt that needs to be posted on chain. But turns out that the moment we actually take many receipts and post them on chain, we can perform a lot more optimizations in terms of data. So the first one is that first one is very simple. So we can actually replace every user's index, every user's address with an index. So an index could be in 8 bytes, that would be 2 to the power 64 minus 1 users, and that there are many, and that is a lot of users. So we actually replace A address with A index and B address with B index. So now we refer to users using their index rather than referring to them using their address. The second thing is also simple, that we reduce the data. We reduce the data by reducing the amount of bytes needed for amount. So we go from 32 bytes for the amount field to 16 bytes. And the point in this case is that you actually don't need 32 bytes for the amount, and you can actually, if you want to match ERC20 transfer, something like that, you can directly multiply it on chain, so you don't need that. The third point is that you can remove expires by field and replace it on chain by an epoch. So you can sort of set up an epoch field that is like every week or every 2 weeks, and every receipt needs to expire within an epoch. So rather than having expires by which determines the exact time when the receipt would expire, you replace it by an epoch. So you don't need the expire by field, you only post the receipts that would expire within that epoch. And then we can adjust the epoch depending on the usage from 1 week to 1 day or within an hour, doesn't matter. We can also remove the sequence number and reproduce it on chain. Since I said that sequence number tracks the latest receipt that A and B share, and every new receipt would increment the number by 1. What we can do that we can actually track the number on chain, and every receipt that you receive from A, B, you can sort of increment the number and check whether it is valid or not, and you don't need to include it per receipt. And another optimization that you can do, if you restrict that only A can post their receipts on chain, you can actually you can remove A's index and include it just once. So you don't need to include A's index in every receipt. So finally, after all these optimizations, we come down to something like this. So every receipt only needs B's index and the amount, and we need one aggregated signature and A index. So we went down from 201 bytes per receipt over here to 24 bytes per receipt. And that's a huge amount of saving. And we were only able to do it by having few assumptions about that only A can post the data, and A will have to aggregate many receipts into one particular transaction. And these are the results. So if A is aggregating 10 receipts, they would have to pay 0.5 USD if you actually take conversion rate 3,000 USD per ETH. So for 10 receipts, the total cost is 0.85 USD. And for 100 receipts, the total cost is 3.7 USD, which is a good amount of optimization. And if you want to dive deeper into scaled contracts and documentation and stuff, you can scan the QR code and have a look at it. So, as I said before, scale is not ideal because it is not secure. As I said that B deposits certain amount on chain, and then they can actually send payments to A, A1, A2, A3 off chain. The point is that B doesn't guarantee that all the receipts can be redeemed on chain for the specific value, because they haven't committed to every specific user, because every specific user is sharing the same pool of balance. It's similar to probabilistic payments in terms of security. The second point is gas cost. So since we are verifying aggregated signature, that requires pairing. And since every receipt is a different message, that would require n+1 pairings operations on chain. And if there is a limit of, if there's a limit on gas units that can be used per transaction, that would limit the number of receipts that you can post on chain at once. So that's a limit in case of gas cost. Okay, so where are we headed in terms of microtransactions? So this is sort of a speculative thing, and I still have to research a bit more on this. But I can sort of say that I think we're headed to state channels, because state channels are one-to-one. They are secure, which others don't, which is a property that other systems don't have. Plus, state channels are easy, and they can represent arbitrary state. And these are the good things about state channels. And if we are able to make it very cheap in terms of opening and settling many state channels at once, then we would overcome the problem of locking up capital per channel, because you can settle one very easily and very cheaply. And we would also overcome the problem of having to require on-chain interaction per user, because you can open a state channel and settle a state channel very easily and cheaply on-chain. So how can we do that? So the first way we can achieve that is by having BLS signature aggregation. So what you can do is that you can actually aggregate several state channels, settlement or opening into one, aggregate their signatures and post them on chain, and by that you would actually save a huge amount of call data. And this is what we did in Scaled. And hopefully in future the data cost reduces, so that would make it much cheaper as well. Plus, the good thing about BLS signature aggregation is that it is easier to implement. You can implement it right now. The second part is that we can use ZK proofs plus accumulation scheme to actually achieve this. So what you can do is that you can create a proof of opening or settling a state channel, and then aggregate all the proofs into one aggregated proof and then post them on chain. I'm not sure how much how beneficial it would be as compared to BLS signature in terms of call data, but I think that if you actually take only the balance delta, that is the balance change of every user as the public input, then you can actually optimize it further and reduce the amount of call data that needs to be posted on chain. But I'm still sort of fuzzy on how to achieve that. So we can reduce I believe that we can reduce the call data that needs to be posted using ZK proofs much more than using BLS signature. But the hard part about ZK proofs and accumulation scheme is that it is very hard to implement. The prover time is a lot, and there are a lot of things that can go wrong in ZK proof. It's very hard to audit. The circuits are really hard to audit, and that in accumulation means that it is really hard to get it right. So thank you. So if you're interested in learning more about us, that is PSC, that is Privacy and Scaling Exploration Group, or joining us, you can scan the QR code or visit our site is at appliedckp.org. And if you want to get in touch with me, my Twitter handle is janmaj_mull, or if you want to get in touch on GitHub, I'm not sure you can chat on GitHub, but yeah, you can visit my GitHub and check it out. Thank you. That's the question?
Thank you, Erica. This one, yeah? Okay. Yeah, cool. Okay, thank you everybody for coming. Today I'm going to talk about some things that we can do with CKPs. And like some of the background for why I think that this is important is that like at the moment there's a lot of applications on Ethereum, but those applications appeal to like a relatively small set of the like global population. A lot of people are not really interested in NFTs and DeFi. And like, I think with good reason. I mean, it's compelling for a bunch of people, but for a bunch of other people, it's not. And like, I see these arguments happening sometimes, and I think that like, instead of trying to argue with people about like why crypto is better, we should try and find use cases that are compelling to them. So today I'm going to talk about like some of those potential use cases and show you some examples of some things that are kind of out there and we can use right now. Cool. So before I do that, I'm going to need to talk about a couple of different primitives. And like my idea here is that I want to keep this talk high level. So I want to apologize to the cryptography experts who are here today. We're not going to get into like deep cryptography. Instead, we're going to black box out these components and try to use them to build interesting things. So yeah. Yeah, so we're going to box them out, and like when I started building things with Ethereum, I didn't learn how ECDSA signature scheme worked. I didn't learn about Merkle-Patricia tree. I sort of black boxed those things out, and I said, oh, here's a cryptocurrency. I know a signature, only I can make a signature, and other people can verify it. I know that data that I store in a smart contract is going to be available, and that's all that I needed to know. I knew what it did, but I didn't know like all the inputs, and I didn't know exactly how it did it. And this was a very like good way for me to be able to learn and build things without having to spend like a year just studying and learning about all these different things. That said, like it seems like there's two paths here. Like one path is to like go really, really deep and learn like lots of crypto. And the other path is to sort of black box things out and make things with them, with crypto. And like both are definitely valid paths, but I'm going to focus on the path of like black boxing things out and trying to build things and use things. Because I think that that's like a fun way to get started, especially if you're like more of a beginner in the cryptography side. Okay, so yeah, the first thing I need to talk about is a hash function. So basically what a hash function is, it takes this like ordered data here on the left-hand side, it performs some algorithm, and it mixes up the data so much that on the other side, you're not able to find out what the original data was. So like, it has like 3 guarantees. The first guarantee is that you can't find like 2 sets of data that leads to different data on the other side, or that leads to the same information on the other side. So this is called collision resistance. The second is that like you can't go backwards. That means that like with the data on the outside, on the right-hand side, you're not able to go back to the left-hand side. And the third thing is, what was the third thing? Yes, the third thing is that the data on the right-hand side is smaller than the data on the left-hand side. Okay, so this is what a hash function is, and I'm going to talk about hash function today, but like the best way to think about it, it's just like a blender. It's like you put the data into the blender, you run the blender, it gets all messed up and mixed up so that you're never able to go back to the original data that was put inside. And it also takes up less space because you blend it up, it gets smaller. Okay, so the next thing that we need to talk about is a Merkle tree. And a Merkle tree is a way of using these hash functions to sort of create a commitment to a large amount of data. In our use cases, we're going to have this big set of users. And we're going to want to compress that set into like the smallest possible representation. So to do this, we use what's called a Merkle tree. And the advantage of using a Merkle tree, rather than just putting everything into our Blender and running our Blender, is that it's easy to go back. It's not easy to go back, but it's easy to show, oh, this piece of data was in the original set. It's easy, okay, so here's a Merkle tree and here's how it works. So at the bottom layer, we have our data. And then our data is 512 bits, for example. Let's take that, and then the first thing we do is we hash our 512 bits so that we get an output that's 256 bits. And that's our first layer. And then we take our 512 bits from the second layer, because we have 256 bits on the left-hand side and 256 bits on the right-hand side, and we hash that together again, and we get another 256 bits. Then we take 256 bits and 256 bits, hash it together, and we get our final, what we call our Merkle root. This is called a Merkle tree, and the top node is called the Merkle root, which is like a succinct representation of all the data that we have on the bottom layer. And the advantage of this is that like a user who knows the value of like the bottom layer is able to provide a proof, not a zero knowledge proof, but like a just regular proof that they know that data. So we're going to use that a little bit later. The third thing that we need to introduce is a zero knowledge proof. So a zero knowledge proof is basically a way for someone to make a proof about public and private information. That normally when I want to prove something to someone, I show them all of the data. And they say, oh, they run some algorithm and verify that it's correct, and then we're done. But like this is limited because I need to show them all the data. So zero knowledge proofs allow us to hide some of the data. And that's the advantage here. So you can see this example I have here. So this is basically a zero knowledge proof that proves that I know the product of A and B. Oh no, sorry. This is a zero knowledge proof that proves that I know an A, a public A, that multiplied by a private B equals C. Okay? So we have our public input A, our private input B, our check, which is A multiplied by B equals C, and our output is C. So this is what the prover sees. Now, an important thing to remember about ZKPs is that the prover knows all of the data. Everything that goes in, they know it. And this is like one limitation that we need to consider. Anyway, this is what our prover sees. Let's look at what the verifier sees. So the zero knowledge proof kind of blacks out some of the inputs to the circuit. So let's notice a couple of things. First of all, they know the public input and output. This is important because we need to be able to reveal some information to them. And this is how we do it, by having public inputs and outputs. The second thing to notice is that they know the algorithm that's being checked, that they're aware of what's happening, what checks we're performing. And this is also important, because if they didn't know what checks we were performing, we wouldn't be able to, if they didn't know what checks we were performing, we wouldn't be able to, they wouldn't be able to trust the actual proof that we're giving them. Okay, so this is what a zero knowledge proof is. We abstracted away all the complexity of the math, and this is a tool that we have. So let's use that tool to see how some things that exist in the world work. So the first thing is Zcash. So Zcash is a cryptocurrency that uses zero knowledge proofs to allow users to send private transactions. And the way that it works is that, let's look at the ZKP that they use. So this is like our original example. This is what the prover sees. This is what the verifier sees. Let's talk about what the prover sees. So the prover sees everything. The prover says that for some Merkle root, this green block in the input, I know a Merkle proof, a public key, a private key, and a nullifier such that the public key and a Merkle proof results in the Merkle root. This Merkle proof is not a ZKP, it's just a certain set of hashes that they perform. So first of all, we check that the membership is correct, and then we need to check that the public key, that they own this leaf. So this is basically, we convert their private key to a public key. And the final thing that we do is reveal a nullifier. And the nullifier is important because it prevents double spends. So let's look at what the verifier sees. So the verifier sees the Merkle root, it sees that the checks that are performed, and it sees a nullifier. So the Merkle root is basically the list of all of the users who were able to send a transaction. The checks are the membership check. They see that, but they don't see any details about the membership check. Because if they did, they would be able to see, oh, which user it was. They'd be able to see their public key, they'd be able to see their Merkle root and the Merkle proof. They'd be able to identify exactly which user it is. So we have to hide this information. The second thing we need to hide is a private key. Because if they saw the private key and the nullifier, they would be able to make a proof for that same leaf. And number one, we would lose privacy because they would be able to calculate the public key and they would be able to find the public key in the Merkle tree. The second thing that would happen is that they would be able to steal this money. They would be able to make a transaction to spend it somewhere else. So we have to hide both of those things. And then we reveal the nullifier. And the nullifier is super important because it prevents double spends. So let's talk a little bit about the verifier algorithm. So the verifier algorithm, when the verifier gets its proof, first of all, it checks that the ZKP is correct. Then it checks that the Merkle root is a correct Merkle root, that it's a correct list of users that are able to send transactions. Once it confirms that check, the second thing that it does is it checks the nullifier has not already been used. Because we have a 1 nullifier per user limitation here. That's enforced by this hash. Once you spend a nullifier, you're not able to spend another coin. And the verifier enforces this by storing a list of all the nullifiers. And if it sees the same nullifier twice, it will reject that proof. If there's a second proof with the same nullifier, it'll say, no, this is not valid, reject. Okay. Okay, so nullifiers here are important to prevent double spends. Cool. So let's talk about some generalizations of this idea. So the first thing is semaphore. And semaphore kind of generalizes this protocol because in the previous example, you could only make 1 ZKP. As soon as you made 1 ZKP, your nullifier was revealed and you couldn't make another valid ZKP. If you did, the nullifier would be the same. So semaphore generalizes this and it allows us to reuse public keys. So this primitive allows us to make a bunch of interesting things. We can do private voting, we can do anonymous social media, we can do a whole bunch of interesting stuff with this, which I'll talk about a little bit more soon. So the next example I want to talk about is another generalization and improvement on the idea of ZK. Maybe it's not an improvement, it's more like a specialization. And this is called rate limit nullifier. So this is a special kind of nullifier that we use to limit the rate that messages can be sent. So semaphore lets you prove that you're part of a group, and ORLN enforces a rate limit on that group. So the idea is that we have an epoch. During this, an epoch can be 1 hour, or 1 minute, 1 second. During this epoch, you're able to send 1 message. If you send more than 1 message, your public key gets revealed and you get slashed. So how can we do this? The way that we do this is we use Shamir secret shares. And basically the idea of Shamir secret shares is that we have a private key, and we encode that as 1 point on our line. Then every time we make a proof, we reveal 1 point on this line. And the idea here is if you have 2 proofs on the line, if you have 2 points on the line, you're able to interpolate the rest of the line. You're able to find the whole line. Once you find the whole line, you're easily able to find the private key. Okay, so let's use this in our ZKP. So here's another ZKP. This is our prover's view. Our prover sees everything. So it's very similar to the Zcash ZKP that we talked about a minute ago. We have our Merkle root, we have our Merkle proof, our leaf, and our private key. We prove that the leaf is in the private key, and then we reveal a Shamir secret share of the private key. And the way that we do this is just A multiplied by the message plus the private key equals the output. Okay, so here's what the verifier sees. So the verifier will see the Merkle root, the membership. It won't see the details about which leaf it is, but it will see the message that was signed, and it'll also the share will also be revealed. And so the share is kind of stored every time the peer-to-peer, every time the verifier receives ORLN proof. They will basically say, every time they receive a proof, they'll basically get the share, and then they'll check to try and recover the private key of that leaf with all the other shares that they've received. And if they can do that, they'll generate the user's private key, and they'll reject the proof. they'll also share that private key with everybody, all the other verifiers in the system, and they'll say, this user sent me an invalid proof, or this user sent me more than the allowed number of messages, they're no longer allowed to send messages. And all the other verifiers will accept this and continue with their day. Okay, so let's talk about some applications of this. So this is Skitter. Skitter is a social media experiment built by this anonymous person called Tsukino. And basically the idea is that it uses a semaphore to make proofs that you're part of a group. And every time you make a post on this social media application, your posts are not connected to your identity. Your posts are connected to like a set of one of a bunch of groups. Yeah, so they have this really fun social media experiment. It's very fun to think about like what are the implications of this and like how will this be used in like social media in general. So let's have a look at some stuff. So here's a post. This is a post on Skitter. So this is from, there's a couple of groups on Skitter right now. They're mostly about Twitter followers. We have like a centralized bridge to export this credential. And the idea is that it's like a way for us to experiment. It's a nice way for us to build these like groups. But like some of the negatives are that like it's centralized and like the reputation is not really very meaningful. But it's nice to use an experiment, and it can lead to some fun kind of interactions. So yeah, so this is a post from someone with more than 500 Twitter followers who was talking about, oh, they really like the new feature on the site, the dark mode. And this is another member of that group who's saying that, oh, the feature is a little bit tricky to use sometimes. So like, what do we know here? Well, we know that like this came from like more people with more than 500 Twitter followers. Okay, so let's talk about the anonymity set. So the anonymity set is a set of people who could have made a proof. So when we talk about ZKPs, we also always need to be careful about the anonymity set. We want to maximize the anonymity set, but we also want to maintain some signal. We want users to be able to, if we have like a completely anonymous thing where posts are not connected to anyone in any way, it can be like a very low quality experience for people. That like it's just possible for people to send thousands and millions of messages, and it's hard to like use that to, yeah, it's hard to use that as a way. That can lead to some difficult social media experiences. So let's talk about the anonymity set. So we have like 3 groups. The gold group, which is I think more than 2,000 Twitter followers. The silver group, which is like between 500 and 2,000. And the bronze group, which is more than 500. So these are different groups, but at the moment they're very small. There's like 5, 3, and 6. So the anonymity set is currently starting to grow, but it's still so small that it's like not. It's more like growing than it's ready for people to use and be confident about their privacy when they're making posts. So it would also be nice to add some decentralized groups here, like POAP or BrightID. Like the more groups that we add can lead to more interesting discussions. And like we can also have like custom groups and interesting things like that. That might also be fun. Cool. There's also user accounts. So you can make a post here as like a user and there's no ZKP involved. So you're able to have conversations with like these anonymous groups, and you're able to like discuss with them and kind of see what they're, yeah, you're able to talk with them and have discussions and interactions. Another feature that it has is instant messages. So we use ORLN to make ZKP. We use ORLN to limit the number of messages any user can send, and this allows us to have like private direct messages. So you're able to chat, users are able to chat to users, groups are able to chat to users, and groups to groups is coming soon, it's not here yet. So this is a conversation I had with with a member of the 7,000 Twitter followers group, but they haven't got back to me yet, so I don't have any advice to share about getting more followers on Twitter. So hopefully soon. Yeah, so you can DM me on Skitter if you like. I'm there. We can start to have some chats. Yeah. We have, yeah, there's a couple of other like interesting social media applications that I want to mention here as well. There's Hey Anon from 0x Park, which I'll talk about a little bit more in a second. There's people working on interesting groups like Seismo and Hey Anon. They also have some groups. And like one thing that we need to have is like a browser plugin so that we're able to use the same public keys, private keys with different applications. Just like MetaMask, you don't want to make signatures on Uniswap and SushiSwap and share your private key with the actual application. Because if they steal your private key, they can just take all your money or take all your reputation and just go and do whatever they want with it. So that's not good. So we need to be able to hide the private keys of the users. And that's why a browser plugin is really important. Cool. Okay, so there's one more application I wanted to mention for the hackathon purposes, because it seems like there's some fun things that we can do here. Yeah, so here's a link, and basically what this is it's a starter project that allows you to verify ECDSA signatures inside a ZKP. And why is this interesting? Well, you noticed earlier that our anonymity set was very small for the Twitter bridges. And this is because we have to have a public way for people to sign up. And like when we have a public way for people to sign up, you're able to see who signed up and who didn't. You don't know who performs what messages, but you do know the set of people who are inside the group who could have done it. So if we use ECDSA signature verification inside a ZKP, it becomes easier. Because then the anonymity set can be everyone who is in the participating set. So let me give you an example to try and make this a little bit more clear. So let's say that we want to make a group of every Ethereum user ever. What we do is we need to go to Ethereum, we download the list of accounts in the state, and we basically say that this is every valid Ethereum user ever. And what we do is we put them into a Merkle tree, and then we create our circuit. And our circuit is basically checking that the ECDSA signature is correct, and that they're part of the Merkle tree. So this can lead to a whole bunch of interesting applications, and one of them is Hey Anon, which I mentioned a minute ago. So Hey Anon is this it's a series of Twitter bots that will kind of copy and paste the ZKPs that they receive. And this is interesting, but one of the limitations is there's no nullifier. And when you have no nullifier, you're not able to have. When you have no nullifier, you're not able to. We could have a lot of problems with sock puppets, with people with the same account just pretending to be from different accounts, and this could lead to some problems. But we're working on ways to make the ECDSA nullifier generation better, and yeah, we're working on ways to generate a nullifier from ECDSA, and we're hoping that we'll be able to use that feature soon, because yeah. Like, I'm really excited to have a whole bunch of different groups of like different kind of subsections of the Ethereum community able to like discuss and talk from that group. I think that would be really nice. We're able to do that already, but it involves us kind of like verifying on-chain the signature, and that limits the anonymity set. The benefit here is the anonymity set is bigger, and as soon as we have nullifiers, it's going to be really, really nice. Okay, another thing that we can do with this is we can use the ECDSA signature verification to compress the amount of signatures that you need to put on chain for optimistic rollups. Like y'all may have heard of the BLS wallet project, which is a project to compress BLS signatures into the smallest possible call data footprint. And like the reasoning for this is that call data is the only thing that matters anymore. Execution is basically free, so we want to minimize the call data as much as possible. So BLS wallet tries to do that, but we could also do that for ECDSA with a zero-knowledge proof. So this is a nice kind of scaling project that you could also work on. Okay, here's a couple of cool ideas. Do something cool with Semaphore. Reach out to the mentors. Jake is here in the blue t-shirt, and OneSub is here also in the blue t-shirt at the back. Okay, so you can reach out to them, they'll be happy to help. OneSub also wrote this library, so he's pretty knowledgeable about the ECDSA signature verification. Yeah, so other things that would be fun. It would be nice to add more groups to Skitter. At the moment, it's just like 3 Twitter follower groups and 1 like global user group. So it would be nice to add more users there or more groups there, just so different people are able to talk and like interact. It would be nice to make a version of Hey Anon that's like a message board or more like a message board. And it would also be nice to have like direct messages there too, just so you can have some private conversations as well. You can have a private conversation with someone who's part of that group without knowing like which person it is, and that might also be fun. Or another one is just go with your imagination, make another application that uses zero-knowledge proofs. I think there's a whole bunch of interesting things that we can do. And I also think that it's super important that we do it because we need to make applications that like are interesting for like a broader set of the global community. I think at the moment where our kind of focus is very narrow, and we need to broaden that focus in order to show people like why what we're doing is interesting. And that's really up to us, I think. If people don't get it, it's hard for me to blame them. I always think that, okay, well, let me try and show them something different, something that is maybe more compelling to them. So that's my talk. Thank you very much. If you're interested in joining to work with us, you can check out our website here or join our Discord. And yeah, thank you so much. Any questions? Yeah. Maybe afterwards. Okay. Okay, thanks everybody.
Thank you so much. Thank you, Erica. Hey, my name is Michael Blank. I am COO at Polygon, and super excited to be here at ETH Seoul, talking to you in Korea, where there's just a tremendous amount of energy and innovation. It's remarkable. The excitement is actually palpable here in Korea. The amount of innovation that's occurring is absolutely incredible. And I couldn't be more excited to help talk about what I'm going to talk about today, which is how do we bring Web3 to the masses? How do we bring Web3 to the masses? Now, Polygon is the world's leading Ethereum scaling solution. And it's our objective, it's our mission to help developers, to enable developers to build on Ethereum, to bring their experiences to the world, and through a commitment to security, to sustainability, and to constant innovation. And we've been working hard. We've been working really hard to enable both Web 2 and Web 3 developers alike, and working with some of the biggest platforms in the world. And let me share some of those highlights. You would have seen many of these announcements recently, but I'll just recap them. Reddit. We're powering Reddit's digital collectible service through Polygon technology. Or Meta, where Polygon technology is supporting Meta's foray into supporting NFTs on Instagram and on Facebook. Or Stripe, where we're powering payments through Twitter. Or Adobe, where Polygon technology is supporting the Behance platform, which is their creative platform for development. And I could go on and on and on. And I think one might assume, as a result of all of those announcements, and what people are doing here in this room, and what people are doing across the world in Web3, and some of our partners across blockchains across the world, that we have reached a level of mainstream adoption, right? We've reached a level of mainstream adoption. But maybe not, not so fast. The reality is, it takes about 10 years to move from that which we might describe as a trend to something that becomes a normal part of our everyday experience. 10 years. And I attribute that insight to an individual named Bob Johansen. Bob Johansen is a fellow at the IFTF, the Institute for the Future, which is a think tank based out of Palo Alto, California, in the States. And they help companies realize the future. They help them think about the future. And I said to Bob, it feels like when a transformative technology emerges today, that everyone across the world seems to get it all at the same time. Unlike what used to happen in the past where it took a long time. And he stopped me and he said, actually, that's not exactly right, Mike. It takes about 10 years. And there's a pattern. And the pattern of adoption looks sort of like what you see on the screen behind me. This is what we call the adoption curve, right? And on that adoption curve, we're right about there. Can you see that white dot? We're right about there on the adoption curve in the Web3 world. But I just said we're partnering with all these big companies, and there's so much happening and so much vibrancy in the space, and I think those who follow what's going on in the world of crypto would say, well, crypto has some level of mainstream adoption, doesn't it? And the answer is it does. It does, but we're still very early on in this adoption curve. And the reality is that transformative technologies, such as what we have with blockchain, undergo some level of market frenzy, right? There's some level of market frenzy, and that's not unique to the world of Web3. That happens across virtually all innovation in the technology space. And so if we look at some innovations that have occurred in technology and think about what's happened there, one might assume, and if somebody asked me a couple of years ago, how long would it take until everyone in this room and everyone in their houses and every industry had VR, had a VR in their house. I think I would have said it would have already happened. Because a couple of years ago, it seemed like everyone was talking about VR, and VR existed everywhere. It might also be surprising to know, maybe not for all of you, but people out there, that the revenue generated from streaming music services has only been surpassed by traditional forms of revenue in the music space in about 2018 or 2019. And again, I think if you would have asked me this, how long ago did streaming music surpass traditional music, like on discs or back in the day on cassettes? I think I would have said a long time ago. I'm surprised that it is only 2018 or 2019. And that's the thing with transformative technologies. It takes a while to gain mainstream adoption. Acknowledging that, building something new is hard. Building something transformative, whether it be a service, a product, some kind of tech, is difficult. It's fraught with uncertainty. There are unknowable risks. It's a hard thing to do. And so, what I'm putting forward today is that there are three critical considerations for developers, for innovators, and most importantly, for how we think about supporting end users, whether those be developers or whether those be actual consumers, human consumers. Three critical considerations in driving towards mass adoption of any innovation, but Web3 in particular. And those three considerations are the following. One, value. Most important. When you're trying to build something for a lot of people, you have to ensure that what you're building provides more value than the thing that existed before it. The second, complexity. Is the thing that you're building easy to use? Easy to adopt? Is the barrier to entry low? And third, stickiness. What I mean by stickiness is there a community, a robust community, a thriving ecosystem of developers, apps, and users who come back and utilize whatever the thing is on a repeated basis? Right? Do they come back and use it over and over and over? Not do they come back and use it only once? Those are the three factors. And actually the test for what determines whether something has reached mainstream adoption is whether it becomes a normal part of our everyday lives. Has it become a normal part of our everyday lives? Have we demystified it? Because new things are scary to people, they're complicated, they're difficult to use. How do we make it normal? That's the test. So I'm going to give you a couple of examples of innovations that have occurred and apply that framework, and we'll see why some have made it to mainstream adoption and why some are still on the path. We'll start with the iPhone. The iPhone actually took a shorter period of time than 10 years, because 10 years is sort of like a general maxim, but let's apply the three principles. The first is value. I think we can all assume that the iPhone is better than any previous device that tried to purport to do what the iPhone did. I'd say it's one of the best devices ever invented. And it's certainly better than any product in its category, right? It provides tremendous value, better than others before. From a complexity standpoint, even a 2-year-old can swipe. My 2-year-old kid could play video games before she could walk and talk. And from a stickiness perspective, there's a robust community, there's a thriving community of developers, apps, and users who engage repeatedly around the experience that exists on the phone. And there is an underlying technology that enables the iPhone to be delivered and experienced by the masses. Not just the form factor, not just the chip, but let's call it 3G. So the iPhone has reached mass adoption. The internet. It's taken a long time. The internet, I think we'd all assume and agree, it's reached mass adoption. Why? Value. It's better than any information sharing system that existed prior. Certainly better than the homing pigeon way better than the encyclopedia, right? It's just an amazing information sharing system. From a complexity standpoint, if you have a computer and a connection, whether it be through the air or through a cable, you can connect to the internet, right? Simple. And from a stickiness perspective, there's a thriving ecosystem of developers, websites, apps, and end users who connect and engage around those experiences that exist on the internet. Of course, there's a technology underlying it all that has enabled it to reach to the masses. That underlying technology, amongst a whole bunch of things, maybe we'll call it AWS. Back to the example of VR. I said earlier that VR has not yet reached mass adoption. Let's again apply the three principles or the three considerations. One is value. I think we'd all agree that VR has not yet reached the requisite level of value because it's often better to do things in the real world than you prefer to do in the real world than you would on VR. The experience is better. Secondly, from a complexity standpoint, you have to wear it on your face. It's a janky experience, and it costs a lot, right? So it's not really accessible to a lot of people. And from a stickiness perspective, there is not that thriving community yet, although it's growing, of apps developers and users. And there's an underlying technology, VR, which is enabling the delivery of VR experiences to the masses. But because of value and because of complexity, it has not yet reached that requisite level of adoption where we will all have a VR headset in our houses. I'm going to give you a fourth example. You should only do threes, but I'll do a fourth. And the fourth is maybe a permutation on the first three. And the fourth is this. There's another device out there that is really expensive to purchase, and you also wear it on your face, but nobody's asking for a new version of it. Anybody want to hazard a guess what that new device is? There's probably a bunch of those. It's expensive, and you wear it on your face. Anybody? Glasses? It's a good example. Pretty accessible now, though, right? I mean, but a good example. It's not the one I picked, but okay, I'll give you the example that I chose. It's the violin. Now, the violin is an example of a device that you wear it on your face, and it's expensive, but nobody's asking for a new version of it. And why is that? And here's the variation on a theme on the definition of value. So what I said earlier was something that does something better than the thing before it is what defines value. In the case of a violin, it has intrinsic value. It, in and of itself, is value to an end user. It doesn't have to be better than something else. It does what it does. And as a developer, as a builder, we need to think about distinguishing between, are we building something that is better than the thing before it? Because if that's the case, then it has to be faster, it has to be less expensive, it has to be more accessible, it has to be easier to use. But if the thing itself has intrinsic value, like the violin, you don't need a better thing. And then to double click into that, when you're building something for people, you have to decide who your audience is. So I'm going to reiterate, value, complexity, and stickiness. From a value perspective, the thing either has to be better than the thing before it, or it has to offer intrinsic value. It has to be easy to use. In other words, the barrier to entry has to be low. And then there has to be a thriving community of developers and users, and in the case of Web3, applications that they want to engage with. Applications that they want to engage with. And the reality is, we're on that curve. We're getting there. But there's a thing that we do in the world of, let's say, blockchain, and that is that we often talk about how the technology works versus what the technology does and why it's good for an end user. Again, we talk about how the technology works. We need to talk more about what the technology offers and why it's good for an end user. So I'm going to give you an example. Let's talk about a car. If somebody came to me and said, Mike, what is a car? And I said, here was my response. Imagine this. I say, Well, the principle of an internal combustion engine is that if you inject some high-density fuel into a small chamber and you ignite that high-density fuel in the chamber, it expands as a gas. The expansion of that gas creates an event. That event causes motion. That's a car. Nobody would understand what I was saying. What if somebody asked you, what is Uber? And you said it's a cloud computing platform. Or if they said, what's Airbnb? And I said, it's an indexing directory. Nobody would know what that was. And that's the challenge of those of us who work in transformative technologies. We tend to describe how the technology works. And so what I often hear is, what are you building? And what I hear back is, oh, I'm building a EVM-compatible experience application. It's using ZK EVM. It's custodial. There's NFTs. It's self-sovereignty. And all these words are used. And because we're creating something new, we've created a new nomenclature, right? We've created a new vernacular. And that's okay. We need a vernacular. We need a nomenclature to talk about what we do, or how we do it, I guess. But when you're talking to end users who want to adopt your experience and use it, talk about what the technology does and why it's of value to you, not how the technology works. Not how the technology works. Okay, so let's apply now this same set of considerations, these three considerations, to the world of Web3. To the world of Web3. And so I'll start with value. I can say that there is and we all see it, there is an incredible amount of innovation occurring in this space from developers globally. They're building unique applications that are changing the way in which we experience the internet. And it's a remarkable thing that's happening. And in some cases, these things provide intrinsic value, and in other cases, they're better than the things before it. But overall, tremendous amount of value being created. But we're using a lot of technical jargon when we talk about it, and therefore it makes it really inaccessible to end users. From a complexity standpoint, we're making tremendous strides in making applications that live on the blockchain, the world of Web3, easier to use, right? Easier to use, we're lowering the barrier to entry. We're starting to think more about how an actual human might use these experiences, not just the very deep core community. But I will say also that we are pretty far away still from what I think we would all describe as great user experiences. In the world of Web 2, the threshold for how long it takes before somebody leaves your web page upon loading is 2 seconds or less. So within 2 seconds, you keep them. After 2 seconds, they leave the page. There are experiences that people in our world have, right, where it could take minutes, if not hours, for a transaction to occur. Imagine if you went to Amazon.com and you tried to buy your favorite thing, whatever that thing is, and it took 6 hours to buy it on Amazon. You'd think Amazon was busted, and you wouldn't buy a thing again from Amazon. So we have a little bit of forgiveness, right, in our world today, because it's new, it's emerging. We're creating transformative technology. It's hard. But again, the premise of this discussion is how do we do what we're doing and demonstrating the tremendous innovation and these experiences that are really revolutionizing how the internet is experienced to more people. The user has to be put at the center. And from a stickiness perspective, there are more developers, there are more applications, there are more users entering in to the services built on blockchains, into the world of Web3 every single day. But that number is still relatively small. And the number is still relatively small because Why? Because the value isn't described effectively and it isn't always there. And the complexity is generally pretty high. That's sort of like VR, right? We're getting there. We're getting there. And the underlying technology that enables these experiences to be delivered to the masses hasn't scaled sufficiently so that millions of users can complete millions of transactions simultaneously without risk or fear or failure. We're not there yet, but we're getting there every single day, every single day. And that's why I'm really excited about what Polygon is doing. How is Polygon hastening or accelerating the adoption of Web3? I'll go back to the three considerations. From a value perspective, we are supporting developers, large and small, globally. We're helping them figure out how to find their value. And we're doing that through hackathons, like Polygon Connect. We're doing it through investment, where we're helping provide them with a longer runway so they can hone the value of their services. And a whole myriad of other ways in which we're supporting developers to help them find the value that is intrinsically being developed within their applications. From a complexity standpoint, we're offering support to developers through user experience design expertise, through game design expertise. We're helping developers position their products so they can communicate them effectively to the end user. So it's not technical jargon, but actual human language that they can understand and appreciate and adopt and act and get into and feel, right? It has to be emotional. And from a stickiness perspective, we're bringing together more developers, more users, and more applications every single day by helping developers big and small build on Polygon technology. And we have an aspiration to create more endpoints that help developers get their experiences out to the masses, to help improve discovery. And of course, Polygon, as an underlying technology, is innovating all the time. At the very beginning of this discussion, I said one of the commitments that we make at Polygon is constant innovation. We recently announced our ZK EVM. There I'm using some technical jargon. We're developing services. We're developing technology that helps bring blockchain to the masses by enabling millions of people to complete millions of transactions simultaneously, which will allow developers, large and small, get their experiences to the people that they want to get to around the world, which is super exciting. So Polygon is making great strides across all three of these principles to help hasten and bring forward the world of Web3. And so I want to leave you with maybe a question as a developer. And that question is, who is your community and how do they exchange value in ways that aren't just about money? Minus DeFi, because that's about money. But everything else. And when you think about what the best applications are in the world, the best companies building the best stuff, they focus on product market fit. They focus on product market fit. They focus on providing value to their end user first. They put their end user at the center. They build something that people care about. They talk about it in emotional ways that makes them want to resonate and utilize the experience, the application, the service, the technology that you're building. That's what great companies do. And then they focus on generating revenue after. So again, as a builder, as an innovator, who are you building your thing for? And how are you focusing on how that provides value to an end user? First, great things attract users, most importantly. And I'd love to hear from you about how you're doing all of those things that I just described. Connect with us on Twitter. Link in with me on LinkedIn. You can find us anywhere on the internet. And I look forward to speaking with you again. Thanks a lot.
Hi everyone, my name is Nick. I'm a software developer from 1inch, and right now I want to talk about our APIs, about our limit order API and about our aggregation API. But firstly I want to talk about our project a bit. 1inch network is actually consists of multiple protocols. The main protocol of 1inch network is aggregation protocol, and currently we have more than 2.7 million users in across multiple EVM compatible chains. We have billions of volume on our exchange, on our aggregation protocol. We also do support most of the EVM chains, and we also support most of the DEXs across all the EVM chains. Aggregation protocol is basically the idea how we can aggregate all the liquidity across all the DEXs and allow users to swap with the best rate on the market with the same experience, with the same user experience as on the Uniswap, for example. So basically, this is like short overview of all our protocols. We do have our 1inch wallet, we do have DAO, we do have token. Currently, we also have limit order protocol and liquidity protocol. And we're also working on 1inch Pro that is basically regulated solution for the institutionals. That allows you to swap with KYC, with all the support, with all the regulations. Let's talk a bit about aggregation protocol. So basically, aggregation protocol, as I said before, allows to get the best rate on the market across any chain. Let's just think that you need to swap, for example, like 100 Ethereum to DAI, and basically firstly we'll go to Uniswap and try to swap there. And what if I can tell you that you will always have the better rate on 1inch exchange, because we aggregate multiple providers, also Uniswap, Curve, almost all the DEXs that you have on any chain, and allows you to get the best rate. We also have very optimized gas router. So basically, it's always the best way to swap is always to aggregate multiple DEXs. And we do all of the stuff on the same transaction. So you have the same user experience as swapping just on Uniswap. So like the main idea of aggregation protocol that you have multiple parties here. Basically, we allow you to use our API to get the rate as a developer. You just need to ask for the quote. You need to pass to build some data for the quote. You ask for the quote on our API. If you are agreed with the amount of the return amount of the quote, you need to ask for the call data for the transaction. After you build the transaction using our swap method, you basically just need to pass this transaction to the smart contract. So you just, after swap, you need to go to the smart contract 1inch route of 1inch. It's called 1inch router, and just pass the data that we gave you on the previously. Our 1inch router supports actually multiple swaps, and we do it on actually. I mean that it can be executed parallelly. We can execute swaps between any token to any token, and even if some of the part of the swap will fail, we still allows user to continue to swap it. So some percent of the swap can go back to the user, to the executor, and the main part will be swapped with this rate. We also support min return amount. So basically, 1inch router allows you to actually to execute any type of the transaction for user, whatever user wants. And the most interesting stuff about 1inch router that is much more optimized than a Uniswap router. Even if you do just simple swap via Uniswap, it will be much more cheaper using just 1inch router for that. So you will always save on gas more than on Uniswap with us. Basically, if you want to integrate 1inch aggregation protocol API, you just need these two methods. These two methods are available on our 1inch docs site. So basically, the first one is 1inch quote, as I said before. The second one is a swap. I just want to talk about all the params that we have on the quote and on the swap, all the query params. Basically, you just need 3 query params to make a swap, to get a quote on 1inch. It's just from token to token address and also amount. That is basically, amount of the from token address. So this is example of these examples are of the examples of swapping Ethereum to 1 inch, of 1 Ethereum to 1 inch. Basically, all these params allows you to get the quote. You don't need to think a lot about which params you need to pass, just the tokens and amount. But we do also support multiple other additional parameters that allows you to do more custom logic for your client. So I want to talk about that. Firstly, we support protocols param. This param allows you to specify specific dexes that you need for exchange for the swap. Sometimes you want to swap only on specific dexes for a specific pair, and it can be useful for low liquidity pair tokens. Usually we do support all the protocols, but you can turn off some of them and also have a bit more faster response. We also support fee. We allows any protocol, any integration to have some reward fee for each positive slippage from the user side. This fee can be up to 3% per swap. It depends on the execution of the transaction. If there is no positive slippage, you will not get the fee from this transaction. But if it will be, you can earn up to 3% from the user. So by default, the fee is 0%, but if you want to specify something not differ from 0, you just need to pass a number from 0 to 3. We also have a parameter called connector tokens. This parameter is pretty important because that's one of the most base how we build path for the swap. Sometimes if you have no low liquidity token and you know specific pool, for example, on Uniswap exchange, where there is a lot of liquidity for this token, if you will pass this connector token to our API, we will give you much more better return rate than if it will be just default connector tokens. So it's pretty important parameter for the very low liquidity tokens when you need to get the best return. We also have basic parameters just gas price. If you will have pretty high gas price, it will be much more easier to get good return. So you can it depends on how much gas price you will pay. You will get different return amount. If we can adjust to the client, sometimes users needs to pay a lot for the good swap because users can swap hundreds of Ethereum. Sometimes you need just to pay a couple of dollars, so it's almost like nothing. And we can optimize to each user. We can adjust to each of them. This is basically example of connector tokens here. On this path, it's USDC and Ethereum. I just want to visualize the idea of connector tokens. So for example, and the main swap is actually between DAI to ETH, and we have USDC and Ethereum as connector tokens. So if you will specify something else, for example, like 1 inch token, 1 inch connector token, we will try to find the path to swap from DAI to 1 inch, and after that, from 1 inch to ETH, for example. And there is another parameter called complexity level. This parameter is pretty important because we can specify how much parts, how much we can go to the roads. Sometimes we can make just one connector token. Here, the complexity level is here because we use 2 connector tokens between swap of DAI to ETH. You can have up to 3 complexity levels on the swap. Usually, it's not very important to have 3, the complexity level of 3. Usually, 2 is pretty optimal solution. Sometimes you need a complexity level of 0 or 1 if it's very low gas optimized swap. Another very important parameter is main node parts. Basically, this is max amount of splits that you can make for each subpath from the from amount. It can be up to 50. Usually it's 10, but in the current example it's just 5. Basically, that means that we can split your DAI amount on each path to 5 parts to swap the multiple dexes to the USDC, for example. We also have another parameter called parts. So we can split your subparts to another subparts during each swap. And you can also specify this parameter. You also can, by default, it's like 50, but sometimes you can specify it lower, so the response time will be much more lower and faster. Basically, after you can specify all the parameters for the quote, you need to do the same for the swap. And if we are talking about the swap method is pretty the same as quote, actually. You have all the same parameters, except some news. One more new parameter is slippage. And it's a very important parameter because sometimes when you do a swap, during transaction execution, the rates can be differ, and you can get much more lower amount of Ethereum, for example, in this example, than you expected. So you can specify how much percents of Ethereum, how much of the return amount you can lose, and you are okay with that. For example, in this example, I just specify 39%. That means that I can lose up to 49% of the Ethereum on the return rate, and the transaction will be still executed. It's very important to understand that if you will have very low slippage, you will also you will also have fail of your transaction because the price is going up and down too fast sometimes, and if the slippage is too low, it will be always reverted. So it's like always balance between very high slippage and very low slippage. It depends on the token pair and depends on the market conditions. Sometimes, it's usually if it's very hard to swap with the low slippage, you need to adjust it, to raise it a bit, and try again and again. It's pretty okay if you are using, for example, flash swaps, like flash bots for that. In this case, you just don't pay for gas, and it will be easier for you just to adjust slippage of your swap. Another important parameters is destination receiver and referrer address. Basically, we do allow to specify return address that will be used to receive the funds from the swap. For example, you want to swap from one wallet and get funds to another wallet. It's possible via our router. It's also possible to specify the referrer address. You need to specify this address if you want to get some fee commission for your integration. So, if, for example, if you are a wallet and you want to integrate OneInch API, and you want to get some commissions, you always need to specify address that will get some rewards, and also specify the fee amount % as well. Our router also supports permit. So basically, if your token supports permit, you can swap transaction. You can just swap without any approve, and you don't need to spend gas on the approve. You can do it in the same transaction as a swap. And also, we do specify gas limit. You can specify gas limit. Depends on the gas limit amount. We can adjust the road of the path. So if gas limit is very low, it will be pretty simple swap. And it's also pretty useful for low liquidity swaps and and for small amount swaps. There is also one important parameter called allow partial fill that allows you to, for example, to fill specific parts of the road of the swap, not the whole swap, just, for example, 70% of the swap. So basically, sometimes it's very important for you to swap at least something, and you are okay to swap at least 70% of the whole amount that you are going to swap, and all the other parts will go back to your account in the source currency. For example, in this example, if I will swap DAI to wrapped Ethereum, for example, like up to 90% of the swap goes to wrapped Ethereum, and the other 10% of DAI goes back to my address. But I will swap at least 90% of my amount to the wrapped Ethereum with the pretty good rate. It's very hard to swap big amounts of tokens with low slippage, but you can always try at least to fill small % of it. So it's also possible with our API. It's also a very important parameter called disable estimate. It allows you to specify. Sometimes you need to estimate transaction on the wallet, and sometimes it's impossible to do this because the wallet is not ready for that. For example, you need to estimate. You need to build call data for the swap, but this wallet doesn't have allowance for this token. In this case, you need to use disable estimate flag. So we will not estimate the transaction execution from this wallet, and you can just use this call data later for the swap. It's also important for the smart contracts. If you can always use another smart contract as a from token address, as a from address for the swap. So basically that's it about aggregation protocol, and I want to talk a bit about limit order protocol as well. Aggregation protocol is more about a user-side experience when you need to instantly swap some tokens. A limit order protocol allows you to specify the destination, or the rate, the rate of the swap, and the swap will be executed only with this rate. We do also support multiple additional features of a limit orders. It's pretty the same user experience as on any centralized exchange, but it's absolutely decentralized. What does it mean? For example, if you will create a limit order, you will not pay for the gas from the user side. You just need to create this limit order and sign it with your wallet with the specified rate. And any user can get your order and fill it. So basically, it's just agreement between someone and you that you are okay to swap some specific amount of the tokens with this rate, and anyone else can just fill this execution, this agreement, and just provide you these tokens with this rate, with this expected rate. And there is just smart contract that allows you to check all these conditions. It can be multiple conditions for each swap. So basically, with our limit order protocol, it's possible to implement multiple features like stop losses, like RFQ. Also, we can have dynamic prices. We can use arbitrary price discovery for each swap. The best example of it is that for each amount of tokens that you swap, the price can be varies, depends on the amount of the swap. It can varies, depends on the market condition. For example, I can create a limit order that is, and the rate of the limit order will be different, depends on the price of Chainlink, for example. So I want to swap, for example, wrapped Ethereum to 1 inch with the rate like 1 inch for like 0.0 Ethereum, 0.1 Ethereum. But if the price of the Chainlink will be higher than $10, I want to have different rate. It's also possible with limit order. So basically, it's almost possible to implement any execution, any condition using our limit order protocol. There are two parties swap during limit order protocol. It's market maker and market taker. So market maker is the person who basically creates an order. You just create with some condition, and you need to sign it via your wallet. After that, you just need to share this order, this information with via 1 inch API with the whole network. And also, you don't pay for gas during this moment. If you don't have a allowance for the token, you don't need to pay for gas. You just create any order with any amount that is available on your wallet, and anyone else actually can fill your order after that. Another party that is responsible for actually filling these orders is market taker. It's anyone who can search for any available orders on our API. And basically, if this person is okay to fill this order, this person can just execute the swap and fill the order. Why it's important, why market taker exists, and why do they need this? Basically, sometimes there is some limit orders with the market rate that is pretty profitable for the market taker. So market takers usually just earn some profits based on the limit orders. For example, the current market price of the Ethereum, for example, will be 2,000, but there will be limit order for 2,050. So it will be profitable for market taker just to execute such limit order and earn some profits on it. So basically, market taker also needs to calculate amount of gas that market taker needs to pay to execute this limit order. Basically, it's always market taker who pays for the gas of the limit order. Market maker don't need to pay for that. It looks pretty like this. Firstly, market maker just need to sign and send order to our storage of limit orders, to our API. It also can be absolutely decentralized. You can not use any API for that. You can just use P2P exchange for the limit orders. After that, a market taker search for suitable limit orders on our storage. After that, market taker can fill this limit order via our smart contract on chain, paying some gas for it. And after that, basically, market maker receives these tokens, like needed tokens, based on this order. So it works pretty simple, actually. Let's talk a bit about limit order structure if you want to integrate limit orders. We have SDK, we have JavaScript SDK for limit orders, so it's pretty simple actually to integrate and to use them on your site. But if you want to have additional conditions and if you want to go deep, you need to understand this information. Basically, the structure is like that. And I want to say about maker asset data and taker asset data parameters here. Basically, with our limit orders, we support not only ERC20 tokens, you can specify any other asset that can be implemented via maker asset data and taker asset data parameters. This data allows you to actually support any asset that will have their own method of transfer. So basically, you can, for example, specify NFT tokens, like ERC721 tokens for limit order, and implement, for example, NFT marketplace based on the limit order protocol. You just need to redefine maker asset data and taker asset data fields. Also, get maker amount and get taker amount fields allows you to specify the rate, the exchange rate of the assets. So it can be pretty dynamic rates, depends on the additional parameters that you can also specify. We do also support predicate and permit. So permit is pretty basic, it's pretty the same. It's also the same permit as we have on aggregation protocol. So you can swap without any fees if your token supports permit. And interaction field is pretty important field that allows you to make some callbacks. Actually, we use this callbacks before transfer from of the maker's tokens to the taker address. So basically, interaction allows you, for example, to implement such logic as, for example, to store all your tokens on the compound, and when the limit order will be executed, these tokens will be removed from the compound stake. They will be unstaked and will be going to the taker amount, to the taker. So basically, for example, with limit order, you can create an order and use your funds to earn some profits on the compound, for example, on the same time. And when it will be executed, they will just withdraw these tokens from the compound in the same transaction. So let's talk a bit about order execution. If you need to fill this order, you need to use a function called field order on the smart contract. And for that, you need to implement, you need to pass such parameters as the order structure, as I described before. And also you need to pass signature. We do support sign type data before signature for that. And if you have a case when you have smart contract as a maker address, signature must be not a sign type data signature, but specific data that this signature will be sent to your smart contract, and your smart contract need to verify this data on its site, on its site, basically. So we actually support any address that can be executed, that can be market maker for the limit order. And basically making amount and taking amount are just amounts that you need for the swap. Based on them, you actually have a rate. And threshold amount is mean return that you can get for the taking amount. So if you are not okay to get at least if you are okay only to get at least 50% of the limit order, you can specify that using threshold amount. Let's talk about predicate. Actually, it's conditional execution, what I said before. We are using predicates, for example, to allow users to cancel the orders. If you will use predicates, you can allow users to cancel limit order during runtime, during some time. You can also specify timestamp for the limit order, so it will be alive for only, for example, for 5 minutes or for 30 minutes. We do use predicate for that. We have basic implementations of some functions for limit orders, and you can use all of them. And actually, you can build your own predicate based on our basic functions. So it's pretty customizable. For example, if you want some additional condition, you just need to deploy smart contract to the Ethereum and implement specific functions there. And after that, you can just build limit order that just goes to your smart contract on Ethereum and checks some conditions there. So you can also, as I said before, you can redefine get maker and get taker amount. So basically, this is default implementations of getMaker and getTaker amount. But if you are not okay with that, you can always specify your own. Actually, that allows you to may implement your own price auction. So the price can go up and down, depends on your rules for each token and for each additional condition on the market. So that's actually how we implement execution of the limit order. So basically, that's how actually we do calculate your return amount. And it's pretty important to understand that to build your custom implementation of the getMaker and getTaker amount. If you have a case when your maker address is smart contract, it's just not a simple wallet, for example, user, but it's some other smart contract. In this case, we will call this function. It's called isValidSignature on the address of the smart contract. So you need to implement this function on your site. Basically, we pass hash of the order of the limit order, and also we pass the signature, which is basically any data that you can specify. So you need to verify this data on the smart contract side all the time that you create any new order. So if you will not have this signature, it will be not working. Or actually, all the functions will be working by default. It's also, as I said before, there is an interaction parameter that allows you to somehow to interact with the user funds, with the maker funds before transfer from to the taker address. So basically, using this function called notify fill order, you can implement any custom callback to any other protocol and somehow manage the maker funds. So it's pretty useful, as I said before, for example, for the case of the compound. So basically, that's all what I want to say. If you have any questions, we'll be happy to answer about that. There are just two important links that I put. The first one is actually quick start for the limit orders. If you use a JavaScript SDK or if you use JavaScript on the client side, and if you want to go deeper and you need, for example, to modify smart contracts for your and specify specific conditions for the limit order, you need to go to the limit order protocol v2 GitHub and actually to try to use it on the Solidity side. We have all the tests there, all the information that you need to somehow use additional callbacks or something like that. So we'll be pretty happy to answer any of your questions, and thank you.
Hi, hello everyone. Hello. Hi, my name is Taeyeon. Thank you for having me today. I supposed to present it in Korean, providing English pre-recorded presentation, but I switched my language in the very last minute because majority of the audience are English speakers. So today, I'd like to speak about the importance of intention and its powerful impact on the future we are aiming to build through the power of Web3. To do so, I'm going to share a piece of who I am and my own intention. This is all to aspire for a more diverse and inclusive future for Web3. It's not working. All right. Okay, I'm probably the one of the few speakers talking about social impact and public goods during the entire Korean Blockchain Week. It is such a great honor for me to speak about this topic on behalf of many builders and warriors in the social impact sector. Thanks to Erica and ETH Seoul organizers to provide me the opportunity and accommodate diversity, which is also the main topic of my presentation today. Let's start it. I believe everyone here has a different intention. It drives one to think and act in their own unique way. Everyone here has an idea of what blockchain's future can look like and what we want to achieve through blockchain. Because it is open source, the future can be anything we dream it to be. Some people may want to build their own kingdom. Others may want to realize their utopian society. Some just want to realize their unique technological innovations and win recognition through their work. And I don't blame you if your intention is just make a lot of money. But let us pause to further reflect this vastly important question. What is your intention? If you can answer this question right away, you are free to leave. But if you can't, then let's go over a few relevant questions that might give you some clues. First, what brought you into the blockchain space in the first place? Second, which attributes of blockchain attract you? Lastly, it is very important question. What are you trying to achieve through blockchain? I hope this conversation will inspire you all and give you some insight to figure out your intention by the end of this presentation. Before coming to this stage, I also spent quite a long time thinking about my own intention. Honestly, it was not an easy process for me. Over the past 10 years, my relationship with blockchain is similar to the one with an ex-boyfriend. It's a combination of love and hatred, and mostly frustration. After going through the many ups and downs for the past decade, I tend to forget how I fell in love with blockchain and why am I still sticking with it. But the footprint of my past year gave me some clues. These are the two these are the two keywords that have been guiding my life with blockchain. The first one is breaking down language barriers. And the second is empowering underserved communities. These two keywords are the main topics of two following chapters. Let's begin with how I started breaking down language barriers. I remember the exact day when I fell down the rabbit hole. It's been such a long ago. It was almost like 10 years ago for me. So on my 23rd birthday in November 2012, one of my revolutionary friends from Berlin sent me 1 Bitcoin as a birthday gift. He said, "Taeyeon, this is the future. You should really dig into it. Otherwise, you will miss out." His passion was so convincing that I couldn't help but jump down the rabbit hole without hesitation. Probably many of you here sitting remember a time when Ethereum didn't exist, and even when the term blockchain was not commonly used. Back in the early 2010s, only Bitcoin and some coins like color coin that fade into the history were silently experimented by some people, such as cyberpunk, revolutionaries, anarchists, and technophiles. So the day after my birthday, I started to looking into Bitcoin, but back then there were very few results found in Korean search engines. Bitcoin was just going through its beginning phase, and there were not many resources written in Korean. Back then, my English was not sufficiently good to understand the English content. It took me quite a long time to grasp what Bitcoin is and why this is the future. Moreover, there were no YouTube videos or educational content like there is today, so I started at square one, translating English news article into Korean to educate myself. And soon after, I started falling in love with this magical technology and needed to share this secret with everyone. Now to the question. Which attribute of blockchain was I attracted to? Individual empowerment. It doesn't matter where you're from, which language you're speaking, or your gender, race, and educational background. I believe blockchain will lead everyone to stand up and shout out for their individual rights, which has been oppressed by the centralized system for as long as we can remember. I was very excited to talk about blockchain with other people and discuss about how the future could change. However, there were also other Korean people who were interested to learn about blockchain, but the language barrier discouraged them to go deeper down the rabbit hole with me. So I started sharing the translated content with early crypto communities like Tango, and also created my own blog, CoinClip. I spent the next 4 years translating daily blockchain updates in Korean language to share with a wider audience in Korean. It was one of the first blockchain media resources in Korea at the time. Well, even today, I'm struggling with my language barrier, especially when I read technical paper, I just copy and paste in Google Translator. Even after many years of living abroad and working with the organizations, like international one, but I'm still nervous to give a talk in English. I'm sure many of us here have similar challenges if you're not from English-speaking countries or English is not your native language. Language barriers are one of the main causes of the information divide, and it is the major constraint of regional diversity and their limited involvement. So I made a mission for myself to break down language barriers around the world. Four years ago, I joined the Ethereum Foundation, and the first thing I did was initiating the Ethereum.org translation program. Maybe some of you have joined or have heard of it, but for those who haven't, I'm going to briefly introduce this program. The Ethereum.org translation program is a community-driven effort with over 3,700 volunteers from all around the world. It began as a pilot project supporting only 7 major languages. However, soon after we started, people around the world began asking to join the program and volunteer to translate in their mother tongue. After launch 3 years ago, we are officially supporting 46 languages on the website, including minority ones and regional dialects. As you can see in the graph, over the 3 years, there is a growing amount of traffic occurring from the regional subdomains of Ethereum.org. Thanks to all the contributors, now anyone can learn about Ethereum in their mother tongue without the hassle of language barriers. Not only that, we are proud to see how this program represents diverse local communities within the ecosystem. Supporting minority languages such as Ukrainian and Catalan can uplift their unique cultural identities and help claim their autonomy in their international society. Personally, this program means a lot to me. Over 3,700 people have volunteered their time and energy pro bono to help others with similar struggles. The intention of their action was not for any expectation to get return, but instead to use their collective goodwill to lower the entry level into Ethereum for people from all around the world. To be honest, this program has restored my confidence in people's inner goodwill and has shown me the mountains can be moved when we work together to benefit one another. Okay, we're gonna close chapter 1. We've learned why language barrier matters, because it constrains regional diversity and their involvement. And most importantly, we learn how collective impact can break down barriers. In chapter 2, I'm going to talk about empowering underserved communities. I have another question for the crowd. Raise your hand if you went to NFT NIC. Oh, hi. Only one, really? Great. I was there a couple of weeks ago myself. Honestly, yeah, it's like with filter and all that. So, honestly, I've been skeptical about NFT for many years, so I almost skipped it. However, thanks to dear friend, just the only one sitting there, who brainwashed me for a long time. Well, yeah, like she actually encouraged me to get out of my comfort zone, to explore out the NFT's potential and the value of it. So I finally get my first NFT ever to attend one of the events. It cost me thousands of dollars for a cute JPEG, but I wanted to attach it here somewhere, but no shilling today. Although it was a very expensive learning course, it converted my skepticism into optimism. I was convinced of its potential by the positive vibe and freedom expressed by the enthusiastic NFT holders. However, separate from it, I also saw misery in the New York City. The economic situation there seems to be worse than ever before. A local friend of mine told me that due to the pandemic, a lot of people lost their job, shops are closed, and there has been an increased amount of homeless people on the street who may beg for change to survive every single day. I saw a clear economic distinction. Although we were spending thousands of dollars enjoying our crypto transaction at the NFT parties, unfortunately, not a single penny goes to help people in need. Another aspect of this is we're now living in a cashless society, so less and less people bring cash in their wallet anymore. This led to fewer donations being made for people in poverty. There are some talks in the community that we should begin donating or gifting Ether by QR code. But again, not everyone in the lower classes can afford mobile phone or have basic internet infrastructure, which has become a foundation for ordinary people like us. After witnessing the huge gap between NFT millionaires and homeless people on the street, I felt dismayed. Even though I work hard to change the world into a better place for Web3, the benefit of it may not reach far enough to aid underserved communities. I began worrying about the future we are building today. I wonder if we will ever narrow the gap, or if our work will only widen the inequality gap ingrained in our society. We'll say blockchain is open source. It is supposed to mean anyone can build and realize their dream no matter what it is. But still, many people feel blockchain is not for them because they perceive it as a privileged technology for the haves, and they may consider themselves the have-nots. So how can we onboard more diverse individuals to feel comfortable being part of this new technological era? Recently, I was helping the DevCon team to review the speaker applications. There are many experiments ongoing to narrow the gap in emerging countries. Most frequently mentioned words are refi, climate change, emission trading, and financial inclusion. Personally, I'm very thrilled to see more diverse projects making changes with Ethereum in the world. Especially, I truly believe that financial inclusion is one of the areas where blockchain could make a fundamental impact in the world. The unbanked are approximately 24 to 29% of the world population, which is nearly 2 billion individuals, according to the World Bank report. Our work can help diversify the economic power for these underserved communities, but if only that is our intention with our work. I'm going to close this chapter by introducing one of my favorite projects, which is Grassroots Economy. This Kenya-based non-profit organization has been experimenting with community currency since 2012. It started with a voucher system that allows local communities to trade and purchase goods and foods in their local markets. Now they are building a community inclusion currency on Ethereum. I'm going to show you the short video clip of introducing what the community inclusion currency is. So you can forget all the presentation that I made, but I wish you could understand and remember this project, please. 링크에 가셔서 유튜브 하시면 네, 소리 있어요. 그 웹사이트 밑에 보시면 유튜브 비디오 바로 하셔서 The sound is not working, virtually. Sorry for that. So basically, this Kenya project is supporting. It started with Will Roderick,
food,
which is
medicine, or
the
school fees.
economist in
Why
my
do
dear
economic
friend
downturns and
that,
crises have such a
he
devastating
has been
effect on local
helping a lot of,
markets?
Kenya people with
Each one
the
of Songa's
unbanked
members has something
Kenya
important to offer that
local
other members
people.
of the community
Usually
won't
the
have to
Kenya
offer.
currency is devaluated when the
visitors,
economic
farmers,
crisis comes.
nurses,
So they have
cooks,
no currency
teachers,
or the
tailors,
voucher to
shopkeepers,
trade their goods.
carpenters, and
Although
so
they
on.
have,
During a
like
crisis,
things to
each
share
of
with
these
neighbors,
still
but
has goods and
it's almost
services to
impossible
offer
with
each other.
their current
Yet they
currency.
don't have the money
So
to purchase
they
from each
have
other.
been
There is a
experimenting
new
with
solution
like
called
paper
community
voucher, like
inclusion
printing out
currencies.
their
Songa
voucher
joined a
to
network of
be
farmers,
used in
teachers,
their
and
local
small businesses
markets. so everyone
trying to
can
create a
use
stable
it and
marketplace by
trade
trading
goods
their
and
goods
foods and
services
everything.
amongst
And
themselves.
then,
The network pools
yeah,
their
they've
resources,
been
as well as donor
discovering
assistance from cash
the
and voucher
potential of
assistance
Ethereum,
programs
and
into
they
a
are trying to
community
implement
fund.
Ethereum technology
This fund
into
is
their voucher
leveraged to
system
create
so
and
that
back digital
everyone
community
can see
inclusion
like
currency
which
credits.
transaction is made and how much they paid and everything. And also the international organizations like Red Cross and
Sangha receives
United Nations,
community
they
inclusion
can track
currency
down
credits
all the
as shares
records
of the
like
community
which
fund.
is like most used
Now,
and
she can
which
meet
is
her
needed.
basic needs by
Yeah.
trading them with other community
Yeah,
members
gladly,
using
like
her
Kenya
simple
people
phone.
have like
Community
very simple
inclusion
picture
currency
phone
are
so that they
securely and
can like
transparently
text it
created on the
out
blockchain
and
backed
receive
by
the
community
message
goods
like
and
when the
services,
transaction
as well
is
as national
made.
currency to increase the amount of locally available credit. Trisha's food for her family from a local farmer. The farmer can now pay a
28쪽이요? Let's close chapter 2. I'm sorry for the technical issue, but I hope my explanation is like enough to understand how valuable this project is. Now we have discussed the importance of financial inclusion with blockchain can make a global impact. I have shown you, well, technically not shown, but explain you, a real use case of blockchain that is changing thousands of people's lives in Kenya. For me, 10 years have passed since I joined this industry. The entire scene has changed quite radically compared to the past. Now we can learn blockchain through YouTube, and like there is enormous resources like Blockchain 101 and all the educational contents. I'm sure everyone can agree that blockchain has been adopted by the mainstream. However, are we close to mass adoption? Is the future that blockchain was founded upon getting any closer? The future of Web3 is dependent on making this space accessible to the masses. The language barrier and the exclusion of underserved communities are a few examples of numerous restrictions. There are also UX UI issues, lack of educations and job opportunities, and as well as the absence of basic infrastructure such as mobile phone or even internet accessibility. There are still many more challenges we need to overcome in order to embrace more diversity and inclusion in Web3. Why does it matter? Because lack of diversity is not only constricting our ecosystem, but also narrowing the abundance of future possibilities that could change the world into a better place. Before finishing my presentation, I'd like to ask you the same question one more time. What is your intention? What are you trying to achieve through blockchain? I wish every one of us here would take this question seriously. And I hope that my intention of this presentation has convinced others to care more about diversity and inclusion in the future we are building together. Remember, with collective goodwill, we can make any future that we desire. Thank you for your time.
I also want to say thank you to Ms. Kim, because back to the time I started to learn what Ethereum is and what's programming language, I go to this translation program and I literally introduce this to all my friends and relatives in mainland China about what they should do. And for example, recently the merge. So that's, I really appreciate. My name's Laura. I'm from Consensus. I'm in charge of Asian strategy. And also I want to link this back to the previous presentation saying the reason I choose this position is I want to connect Asian market to blockchain and to bring more figures about what's happening in Asia. It's like, for example, in certain countries of Asia, the unbanked populations actually can be as low as below 50%. And for most of the population in emerging countries in Asia, people actually learn blockchain before they have, for example, a bank account or a securities account. And that's literally changed the next generations, their vision about, and also their visibility about what the global market looks like. So here is actually a snapshot of our products, infrastructures today Consensus offered to the Web3 builders. You may or may not heard about Consensus, so the question will be, who is Consensus? I've been asked about this question a lot in Asia, and I was also happy to hear this question because that means we got more people join Ethereum ecosystem, and we got all this great talent learn about Ethereum. So you may or may not heard about Consensus, but I'm pretty sure you're at least users of one of these products. Say, you may use MetaMask and MetaMask institutions for your transaction processing. After this project turning 6 years old, today we have around 13 million MAU on it. You may start to use Truffle to start code your first smart contract. You may use Ganache when you try to test your smart contract in a local environment. And then early this year, we have Truffle together with Ganache being integrated into VS Code so that we can offer better development experience. And then you may heard us a week ago as Consensus Diligence. So Consensus Diligence is a top-tier audit service provider. And we're trying to bring this offering on-chain by introducing Turn token. And then you, I believe as a developer, you're more familiar with Infura. Say Infura, which is one of the largest JSON RPC endpoint API service provider for blockchain, and with over 400,000 developers today using it as an infrastructure for their own blockchain projects. And last but not least, we have ETH1 clients, Hyperledger Bisu, we have ETH2 client, Teku, and all of them, I mean, the entire protocol team in Consensus has been well prepared for the merge. Get back to the topic today, saying building infrastructure for Web3. So why I choose this topic is because based on my experience, building Web3 is always a very complicated project. It's not only because the technology itself very complex, saying the logic or the architecture for you to start a blockchain project is actually totally different compared with the logic when you start a Web2 business or Web2 application. It's also because we always lack of tools and infrastructures. It's not because the ecosystem is not growing. It's just because it's growing too fast, meaning that we're always short of tools when there's a new use case coming on board. So that's why we see us together with our products contributing to the development as well as broad application of blockchain technology, and which will be the key feature of Web3. Say, when the ecosystem is expecting more and more financial and non-financial related use case coming on board, we see blockchain technology will ultimately be a compulsory part of future complex software, and that's actually a mission we have for Web3. And in that case, whatever things we're building today will all be considered as a blockchain infrastructure for a Web3 era. And that's why we see, that's how we see the future of internet, and that's why we are targeting to offer the best product suite to Web3 builders. So today I will bring two products. The first one is Infura, and the second one is named MetaMask Snaps. So first, I am not going to ask what's on top of your mind is the most popular use case today in blockchain. Here's my list. It's always start from developer tools and service, and I need to highlight saying self-custodial wallet, like MetaMask, should always be in this category. And then we have custodian wallet, we have centralized exchange, decentralized protocols, analytical tools, and more recently, game development with blockchain features. And if you try to simplify the architecture of your project, it can always be summarized in this standardized way. Say, you start with your smart contract coding, you do the deployment at mainnet or alternative layer 1s, layer 2 side chains, and then you introduce a front end in Web 2 way and make sure that people can go through this front end, connect to Web 3 and send transactions, have an interaction with blockchain through JSON RPC endpoint API, connect to all the networks that you want your users to. And this is not only about the apps. It could be a higher API for your blockchain game. It could be an NFT marketplace. And for those kinds of projects, you need to build the off-chain part as another portion of your software. So that's how you can understand what Infura is. Say today, Infura as the world's most used blockchain infrastructure supports tens of billions on-chain API requests per day. And we have you can experience the best experience on scalability and flexibility. The product's launched in 2016, and in 6 years, we grew our developer unity from zero, and actually zero means MetaMask, to over 400,000 and still counting. You all know these names in the screen, but there are thousands more building Infura now, and I believe you will all know their names in the future. So what people use Infura for example, MetaMask together with MetaMask Institutional, they will use Infura to send transaction and doing the transaction processing. Developers, they use Infura to start their new Web3 projects for free. Well, for emerging networks and protocols, we work with them and support their ecosystem expansion by introducing, deploying the full node and offering scalable endpoints to developer union. And we see enterprise, centralized exchange, neobanks, they can choose Infura for their gas management optimization work, or say for backup options if they finally decide to run their own full node. So we see Infura is famous also for its reliability and scalability. See, especially when we have a lot of airdrops or mint events on chain since last year. The API suite provides instant HTTPS and WebSocket access to major EVM and distributed storage network, and is powered by our fast customer support. So here is a screenshot of how the dashboard will look like. It's not only for you see like how the usage of your API looks, but also you can get the idea about what's your user's behavior for your application. It's actually a starting point for your analytical work. In NFT AYC, even though I didn't join it, in the events, we introduced our NFT API together with our SDK. So the beauty part of this one is that we offer multiple choices available for developers, whether you're on the journey to introduce your own NFT projects, you're just a consumer of NFT data, or whether you want to incorporate for personal, or you want to build a business use case around the infrastructure or the ecosystem. And here is another way you can understand the positioning of NFT API of Infura. Say, it's actually the foundation of Consensus other products, including Consensus NFT Platform, which is a SaaS product we offer to global IPs and brands since 2021, as well as MetaMask. So every time when you want to show your own collectibles to your friends, it's actually calling our NFT API at the back end. Therefore, we build our products in a family style. Say, since we have internal dependency on the API itself, we will ensure that it's a best in class in terms of performance and scalability, and our users can assure that we will continue to put efforts and CapEx on it and try to include the expansion in our roadmap. This is a simplified architecture of how the API and SDK works. It starts with Node.js, followed by Python, Java, and TypeScript. I include a sample flow about how you can use the SDK to introduce your own collectibles. And before I jump to MetaMask Snap, I want to reiterate about the resources that Infura is powered with. Say, consensus represent the depths of protocol level expertise. Say, in the block native field, our product line starts from Ethereum clients, endpoint API, higher API, use case product service SDK, and then end user connections through MetaMask. But on the other hand, we also have professional service team, customer support team who offer enterprise level scalability capabilities and also advise Fortune 500 companies globally try to have their ecosystem connect to Web3. So that's all because Consensus is always trying our best to promote the application of Ethereum technology. We build up a big community around Consensus, both in the end user community and also developer union. And that's why that we're trying to package all the capability, resources, and expertise we have as a one-stop solution to the builders. And that's by the time when you want to use a Consensus product, what you can looking for. Here is the list of the resources we have for Infura. Please visit our website, infura.io, to start to set up an endpoint connection and join our Discord community to meet the Infura team. And here comes to the second part, MetaMask Snaps. So Snap is a trustless and secure environment that's going to be running inside MetaMask. So you can consider it as things or any features you want to introduce to MetaMask, now you can achieve it through Snaps. We believe, MetaMask team believe it's a further decentralization of the decentralized web because you only need permissions from your own users rather than Consensus or MetaMask team. So Snaps can have their own API, and using the existing method we provided for by MetaMask. There is a link, and there is a great guide in the link to get started with the Snaps. So we list out the use case. Today we see the most popular one for Snaps, including first connect to non-EVM compatible chains or distributed storage networks. We have Falcon Snaps, BTC Snaps. You can have better experience as a protocol team. You want to bring L2 connection to MetaMask. And also you can have a better on-chain securities or keyword manager you want to introduce to MetaMask, for example, MPC solution on MetaMask. You can always, as a DApp on EVM chains, improve the UI UX for your application. So why Snap is so important to the builders? Say, Snap can empower developers to implement features that's currently not available in MetaMask. And rather than MetaMask team doing this optimization work for different use cases, we believe the best way to continue the journey will be introduce this framework. And therefore, it could increase the visibility of your own application. And the most importantly, it's a gateway to over 30 million active users on MetaMask. Snap, technically Snap is, as minimum, is just an NPM package. It can be built with JavaScript, TypeScript, WebAssembly. It contains a set of metadata, and everything gets bundled into a single JS file, and we have also provided a bundle for. You can easily get started and learn about all of this by visiting our Snap development guide, and it's included at the end of the presentation. Here is the demo of Falcon Snap. We also have another BTC Snap demo. And also in the list of the guide, you can find a list of awesome snaps, include like password management, MPC solution, P2P chat, DID experience on MetaMask. It will be all achievable through the Snap development. In order to develop a Snap and also improve the developer's experience on this journey, we also introduced Flask. So Flask is actually a canary distribution of MetaMask extension. You can find it I think you can find in the Chrome Marketplace. And that's why I have to introduce a special purple mask on top of the MetaMask logo in order to distinguish them. So all development on Flask currently happens behind a build flag on your development branch. And meaning MetaMask Flask is the experimental proving ground for world's most cutting edge and innovative features. Giving this its ability to one day incorporate those lessons into the main MetaMask distribution. If you go to metamask.io/Flask, you can see that's where the developers can learn more about Flask, and then there's a link to the download page. This is the end of this presentation, so I believe there's a lot of things to wrap your head about. And here's the links I mentioned before, you can see all the resources you need to get started with snaps using Flask, and it includes like guides, tutorials, articles. And we really think snaps are going to be something very important. And that's why we are putting a lot of efforts on it. We are recommending all the developers who want to introducing their own features or their own apps optimization work to MetaMask today start to building their own snaps. And the link is tinyurl.com/mm-snaps. Thanks very much for your time.
네, 알겠습니다. All right, thank you so much. I'm not gonna keep you between after this and wonderful talks and after party and probably party at Itaewon. So I'm gonna make it quick. Don't worry about it. All right, so we have 10 minutes. Okay. All right, so once again, my name is Tu. I'm a CEO and co-founder at StableNode, but I'm also a delegate at MakerDAO as well. So using those experience, we're gonna talk about more about governance, DAO, and all the fun stuff. People like to think governance is boring, but I must tell you that it's actually pretty interesting. There's a reason why we don't need to watch Netflix. There's drama every week. Now, let's go. All right. So when we talk about governance, right, a lot of different founders and teams, when they think about governance and DAO, they like to think that all of their problems will just magically disappear. And then they say, like, for example, their token price is going down. They have an issue with lack of decentralization. I think that they will even talk about like world hunger and wars and stuff. And they just think that if we have a DAO, we can solve all of this at once, right? But if you look at the reality, is that when they talk about how we can become a DAO, they like to put basically name DAO or be like, okay, maybe we should write some pieces on how we think about like this decentralization. But in reality, not many actually want to become DAO. And then a lot of times they'll come to us and ask about like, okay, we really want to be a DAO. And we're like, great. and they'll be like, but what is DAO, right? So a lot of them like don't really understand like what is DAO, and that's fine, you know. But at the same time, like if you tell them like some of the steps to become a DAO, then they realize that, you know what, actually, never mind. We'll just put the name DAO and just kind of pretend that it works, right? So what we realize is that the field of DAO is growing, right? So if you think about like many years ago, like maybe MakerDAO and some of the other like, you know, DAOs were there, but it wasn't as diverse as now. Like now we have even like social DAOs, right? Like there are DAOs that focus on person or celebrity. There are also like NFT focused DAO. Few years ago, NFT was not so big, and then we even have like some of the you know, some of the DAOs that focus on a specific issue. You guys probably heard about like constitutional DAO as well as like some of the other DAOs to help with some of the conflicts going on as well. So we're seeing that this field of DAO is becoming more diverse, and then the number of projects is also increasing as well. And then there's also a lot of like increase in some of the tools as well as projects that are there to try to help this kind of DAO and DAO management, you know, DAO education and things like that. However, at the same time, despite the fact that number of these different companies and protocols in this field have been growing, there's still a lot of like experience and also a lot of knowledge that's kind of missing from this industry. And that's kind of where we come in. Because we see that there's a lot of different challenges when it comes to managing DAO and operating on DAO. And then a lot of times when we talk to some of the partners, they say they're like, okay, so what would be the right way to do it? And then we kind of tell them that, to be honest, there's no really right way to operate a DAO. There are just like many wrong answers, right? Because if you think about it, you know, just like how we live, like, you know, a lot of those issues don't really have a clear answer. Like, for example, you know, you might have heard of a recent incident where, okay, so DAO decided that some of the, you know, venture capital they invested was not putting enough effort. So despite the fact that there was a legal contract, DAO decided to overturn it. You know, and then is this something that's allowable? Well, you know, that's, I think, a lot of like gray area that we have to see. And then we also see more clear examples of, you know, this kind of governance attacks, right? So some of those malicious actors might go into governance and then have some proposal and they even pass it, and then nobody will notice it until it happened. And then there's also some of the questions about, like, okay, what happens if, let's say, token holders, they decide to get together and decide to do things that some might seem as hostile or some might seem as you know, destructive to the protocol. Actually, for, you know, Venus protocol on Binance chain had a similar incident where, you know, the majority wanted to basically start a new project. So technically the majority won, but they say that it was hostile takeover and decide to not follow it. Like, is it something that's allowed? And then, you know, there are many different incidents that happen. And then once again, like, I don't think there's a right answer, but we want to explore how to make sure that at least it's more fair and at least more understandable, right? Yeah, so that's where like stable node comes in, and then we have been helping with, you know, different protocols. So Maker, you know, personally have been involved in, as well as like InstaDev, Clayton, Finance, Balancer, as well as like Jet Protocol, and many others that are not, you know, mentioned here. So we might be helping as a delegate, or we might be helping as like a consulting, or we might be just there to, you know, hear their opinions and then just have discussions. So how we kind of approach this governance is that we believe that there's a theory and practice. Now, you probably remember back in college, and then looking at your professor and thinking like, wow, this professor might be really smart, but everything he knows is theory and he has no work-life experience. And when you talk about like, how does it work in reality, he or she will be like, well, actually, in theory, this might be this, but I'm not really sure, right? And then we've probably been frustrated once or twice. Kind of similar approach applies to in governance. We believe that it's not just about theory and having this research. You also need a lot of like real experience, as well as somebody on the trench to be, for example, a delegate or do this kind of governance consulting to understand like what the projects feel and then how they work. So how we have this kind of feedback is that, so we develop these theories, right? Like we have our experience others, and then we develop this how to approach those governance theories. And then we have you know, members working on practice, so we apply those theories to the practice and then see whether it works. So for example, we have let's say like new ideas, and then we encourage those who are in the practice to do it, and then they come back and say, you know what, it didn't work at all, I want my refund, this is a scam. Then we are like, okay, then we have to think again, you know, and then we see that some of those are working, then we continue to do, right? So it is a working process where you need both theory and also practice. And then, this also applies to many of the different initiatives as well as projects that we're helping as well. So for example, for MakerDAO, a lot of people kind of come to me and say like, oh, isn't MakerDAO like a boomer DeFi? I guess that's kind of fair to some people who point that out. But I must say that Maker also has a lot of interesting initiatives as well as updates that are happening, right? And then, so when it comes to some of, let's say, big, new collateral that's happening that involves, for example, traditional banks and others, well, on the surface, it sounds good, but you have to also remember that in details, it's something that can take a long time, and that's also something that the governments need to coordinate between different players. So that's also something that we have been helping a lot as well. And then how we kind of look at how to have this kind of best practice, right? Because once again, for governance, there's no real right answer. It's just about how to minimize wrong answers, right? And then by doing that, what we do is that first, we want to examine. So for example, we look at what's happening in the governance. And then two is that we want to, abstract, like for example, what's working, and then look at what's not working, right? And then we want to experiment more to see how it works. Each protocol is different. Now, some of them do share a lot of similarities, but to be honest, like for example, NFT, DAO and like DeFi DAO and like Layer 1 DAO, they're very, very different. So what we want to do is we want to experiment to make sure that at least there's more understanding of it, right? And then like a lot of times, just like experiment, sometimes it might fail and we feel bad and might drink soju, but still we'll try to go over and then experiment once more than others, and then we'll learn from our mistakes as well. So there are many elements of governance, and I'm not going to go too deep because I don't want you to, make it kind of boring. But basically, we kind of separate into 6, and then we are probably changing in the future as well. But first part is the voting, right? So when we talk about it, it's not just about like on-chain voting, but also a lot of off-chain voting as well as like how to signal voting, right? Because we have to remember that if it happens that everybody is like, okay, I think this is a good idea, and every time they put into voting, then that's a lot of resource that's kind of, wasted, as well as we want to make it more efficient. So it's a question about, okay, how can you make sure that we have efficient, but at the same time have a voting that reflects those voices, right? And the second part is the communication. The idea is that, for example, if there's a voting coming up and everybody is asleep, then they're not gonna, for example, they don't know about it, then it's very hard for them to participate, right? So how do you communicate this kind of governance updates, for example, votings, as well as like what's happening to those community, as well as it can also apply to delegate side as well. So for example, if you have delegates or big token holders and they vote, you also want to make sure that they communicate that with the community as much as possible to at least understand what they're thinking. Like, who knows, maybe they just vote something because somebody ran over their cat. It's possible, but at the same time, you want to know that happened, right? The third part is treasury management. This is very important because we especially saw a lot of different DAOs and projects. They kind of misuse this kind of fund, and then while they're like Yak and both might be nice, we want to understand that this is a very precious resource and make sure that they're, like for example, whether it's a multi-sig or different process to make sure the treasury is managed well. Now, the next one is the decentralized workforce. This one might sound odd because a lot of times, even when we talk about DAO, a lot of them like to think it is more like a foundation or a company. But as you become truly DAO, you have to realize that a lot of this workforce becomes like truly decentralized, and that the management becomes like very different. Like even from the maker side, I can talk more about it later. It's like, because for Maker, we don't really have a central foundation that members work in. It's like each team basically has their own company, and then that makes it more decentralized. But that also means the coordination is much more difficult, right? Because it's not like one company and there's the HR to say that you offended somebody. It's basically all the different companies and the different like countries they're from and different regulation and laws. So how can we make sure that we coordinate on this? And then 5 is standards and framework. This is more for especially mature DAO. Because once you become more mature, and then once you have more proposals, you want to make sure that it's standardized, so it's easier for the community to, kind of review and they compare, right? Because you can imagine that if somebody has too many ideas, and then they put into voting or others, like you want to make sure that it's efficient, and then also community can review it well by looking at, for example, key points, and then trying to make it more similar, at least in terms of application. Now, the 6th is not something that I think that a lot of projects know, but it's very important, is documentation. Basically, like, if something happened, you want to document like why it happened and what happened. Like, for example, if there's a voting, and then did the voting pass, okay, and pass by how many margin, what happened, and you want to keep as many records as possible, as well as how to participate in DAO. The reason is that once you have a newcomers to a DAO, let's say, then it will be easier for them to get onboarded, as well as that you don't need to then spend resources to have somebody to basically explain what happened and things like that. It's also much easier for third party to look at it and gather data to give you more insightful feedback. So we believe that this is also very important. Now, in terms of voting parts, so the example we give, for example, it can be off-chain or on-chain, and a lot of these, like these days, because of the gas costs on Ethereum, a lot of them use Snapshot. But there are actually many others that besides Snapshot that people can use. For example, for Maker, we use our own, and then I would say that it has pros and cons. I would say that one of the pros is that if a protocol, like for example Maker, decides to create its own voting tool, then it also gives more flexibility, right? Because you can add things and the data, and then parse to make it more clear, or add the clarification. But at the same time, compared to Snapshot, you don't get as, like, for example, for Snapshot, because you get to see a lot of different protocols. So I would say that there's some data that's kind of shared as a third party they're doing it. I would say for Maker, it might be a little bit harder because it's like separate, right? But at the same time, it does give more flexibility. Or this is Aragon. To be honest, if there's anybody from Aragon here, like, I respect you, but I must say that it also sometimes malfunctions. And then first of all, I realized a lot of virus things, like the antivirus things that each virus. So I think maybe there's a mistake, but I have realized that it also causes some malfunction. So anyway, so we have some projects that also use Aragon DAO one. And then they've also been improving as well. So the point is that it doesn't have to be just Snapshot. Like, I heard that a lot of protocols, they know Snapshot, but it's just like there are many different options to do it. And sometimes you don't actually even need this kind of on-chain voting. Like, a lot of different protocols might just have an off-chain side as well. And especially in the beginning, that's also like might be okay as well. There's no really like right answer, like you have to use this tool. So now the communication is very important. So this, especially if you've been in like a DeFi a little bit OG, you probably know this story about basically a guy who found the sushi swap, and he's like, okay guys, don't worry, I'm not gonna rug, I'm a good guy, like look at my profile, I'm like a panda, right? And then later he's like, actually, you know what, I rugged, but I cannot comment because I'm like really high on drugs right now. And I would say that's a very not good communication. I mean, but appreciate it, right? So I mean, that's, I think the important part is like you want to communicate about like what happened, right? So I would say that for this one, like, yes, I'm biased toward MakerDAO. Like, I've been with Maker for like more, like, yeah, around 4 years. But I'll say that like a lot of this communication has been done pretty well, right? For example, if you go to Maker Forum, you see that there are like different calls happening. So it's gonna write about like not just like time, but also like some of the contents that will be discussed. And then it also encouraged delegates like me to basically write down like my reasoning for vote. Like, for example, if I vote yes, then okay, so what's some of the, for example, core value that I say that's related, and then I have to write down like what's my reasoning for it, right? Like, technically, yes, I can write down like I voted no because he ran over my cat. I don't have a cat, so it's okay. But you can imagine that like I want to write it down so that people can see that like, okay, I didn't just vote it because of like unfair reason, right? Like, I have my reasoning on like, because of this and this, it's fair, right? So, that is very important. And this is something that we also encourage other protocols that we help to do it, because a lot of times voting happens, but then the reasoning is not really there. So this lack of communication makes basic community unsure about like why the voting happened and then what's the thinking behind it. And you want to make sure that that's in place to basically have it more transparent as well as more interactive as well. And then, once again, treasury management has become a very, very, very big issue. And then, it can happen in many different ways, right? Like, because we saw that some of the DAOs that are more immature or even like hostile toward investors, they might just engage in rug pull. But we saw that even if, let's say that you're not intentionally engaging in, there are like many issues that can, for example, harm your treasury, right? Like, we saw that some of the treasury getting, for example, hacked. We also saw that some of the governance attacks to access it. So it's very important to make sure that like how treasury works and then how treasury is transferred. And then I must say that like there are also some cases that even if it's not like exploit like this kind of treasury attack, you might also have some proposals. And this is a common complaint / concern I heard from other protocols, and maybe you share the same. It's like everybody comes to your protocol, especially for like layer 2 or mainnet, and they want grant, right? Like because they know that you raise this amount, they know that you have this influence, and they also know that you want to have those DApps or other like programs on your like mainnet and layer 2. But at the same time, how do you know the fund is actually spent well? And if you think about it, if you give, let's say, a project or like a company, let's say like 1 million, but then if there's no really good way to make it accountable, then that's the same thing. It's not too different from getting attacked, right? Like yes, it's different in a way, like you know who did it, but at the same time, if there's no accountability, you're basically giving 1 million that you could have used for your team to a team that basically, they have used for, you don't know what happened, right? So it's also important that like for protocols, even if it's not like a split attack per se, you want to make sure this kind of accountability as well as this transparency is there, because the community will ask about it, and if the community doesn't ask, that itself is a problem, right? Like you want to make sure that people question it, similar to how like in many governments, they'll be like, okay, where's our taxpayer money going, right? Like you want to ask that. And then in terms of the decentralized workforce is interesting. So the example that I point here are actually not like DAO, right? Like those are centralized company. But the reason why I put those centralized company, for example, like Coinbase, is basically saying that like even for centralized companies, which in theory should be more efficient when it comes to managing people, like they also face a lot of hardships, right? Like they have to fire people sometimes. They have to basically go over some of those policies, HR and others. So you can imagine that for, let's say, DAO, it's even more difficult, right? Like, for example, like not just Maker, but for others, it's like, so when you try to lay off people in transparent way, it usually doesn't work well, right? Like, even for like Maker recently, we had the incident where team leader basically fired his other team members, and then they gathered together and basically posted about like how they want to fire their own leader, right? Like, so like this style, because everything is transparent, it also means that like in traditional companies, they might be like, okay, like because of this and this, you're fired, and then like here's your severance package, like, and then here's like NDA. Well, for DAOs, like you don't even have a legal entity to sign an NDA, and then nobody's gonna really like respect it a lot of times, right? So that kind of challenges come out, and then we must say that it's like really different from project to project, but like increasingly as you become more DAO, it's becoming a more issue, because at the end of the day, like DAO is still run by humans, right? Like, so a lot of human nature parts, as well as like incentive to, for example, sometimes engage in malicious act, and then, for example, get punished for it, as well as like for those people to kind of expose something that might be harmful to the protocol, whether it's the transparency or whether it's like for the good. Like that kind of question has been come up a lot. So I must say that like for a lot of DAOs, it's not a big issue yet, but it's becoming a bigger issue as they become more decentralized. Because even for, once again, centralized company, it's not a issue that can be easily solved. So another point that I mentioned was about the standards, right? So for example, for Maker, we have a MIP, basically like improvement proposals. For others, they have different standards. But it's important to have this kind of standards to make sure that when you have a proposal, that it's kind of consistent, right? So we saw that a lot of different protocols might have something like, okay, when you make a proposal, you have to write like pros and cons. I think that those are kind of fair, right? Because by writing pros and cons, at least people can see, okay, like here are the kind of clear ones, as well as like if treasury is involved, you have to write down like how much is involved, like things like that. So those kind of like different standards can make the process much easier and smoother. All right, so this is another example of it, like for the Maker, like for example, this was about like, okay, now the delegate, so before delegates were not paid, but they want to make delegates to be paid. So here was like a different summary, and then they wrote about what would be the budget and then what would be the process, right? You want to be like standardized and also make it transparent so the committee can review it. And then, yeah, this is about like, so this is also related to kind of documentation part. Is like, for example, many different protocols might be like, okay, we want people to participate in governance. Great, that's like the third step, kind of. First step is recognizing that you're not a DAO yet, but it's okay, right? So what happens is that a lot of times people might want to engage in voting, but there's no real documentation on it even, like, right? So like, how can people go and vote? How can people go and make proposals? Like how can people go and even challenge these kind of proposals, right? Like a lot of times there's now a document on it, and then in the long term especially this is important because as your DAO grows, you're going to have more people engaging your governance as well as your community, and they're going to have questions, and if you have to have somebody once again just to help them every time, like that's much less efficient than having like this kind of documents so they can review it, and if they still have questions, reach out to you, right? And then a lot of those documentation, because there are a lot of DAOs that also kind of wrote this, you can kind of have a standard version that will be easy for your DAO as well. As well as like, for example, keeping track of your voting and what happened as well. Now, so I like to say that decentralization is a step, and then I think even for MakerDAO was kind of clear case, because so some of the people realized that MakerDAO has dissolved last year, right? So, but the interesting part is that MakerDAO started as a DAO, right? So it started as a DAO like with Rune and then Nikolai and others, and then it became foundation later. So I also asked, and then many team members asked the team like why it became a foundation. And the problem was that when they initially started as a DAO, it was like very early, they didn't really have a process to make sure that people get paid even, or like this kind of process where like if you want to get investment, how do you make sure that you can get investment? Like this kind of legal document as well as like structure was not there. So they decided the foundation is at least like temporary measure to make that happen, right? So they became foundation, and then last year the team thought as well as the community believed through voting that it's sufficient to be decentralized. So that's how it became happen. So now instead of, let's say, so traditionally, like even for foundation, you would have a team, right? Let's say you have a C-level, CEO or others. Maker still doesn't have a CEO level. Everybody kind of pretends they're CEO, but they're not. That's why they're fighting all the time, right? But then, so instead of like CEO, you basically don't have a leadership, but it's more of like composed of core units. So core unit would be each team, right? So for example, if you have a business team, then you're a business in a core unit. If you have, let's say, the core unit that works on smart contract, then you have a smart contract in the core unit. And then for each core unit, you also have a facilitator. Facilitator is basically like a lead or like a leader in the team. So they will basically kind of represent the interest of the core unit as well as communicate and then be transparent. Another way of saying that they are also the people that, especially for delegates like us, you can imagine that delegates are like politicians, and then if you know anything about politicians, is that they like to criticize every time whatever you do well or not. So it's kind of our job to just criticize facilitators, whether they do good or bad, right? It's nothing against them. It's just like our nature, I think. And then it's also their job, just like how we view politicians, to kind of hate us. But it's a good relationship, I'll say. And then we also have, for example, this kind of, creation of delegates. And then initially, this is also interesting point, is that when we first started delegates were not paid, right? So people thought that just you participating in like big DeFi itself is a worthy cause. I know we're kind of naive, but because what we realized is that this being delegate for billion-dollar protocol requires a lot of time, right? Like they need to not only attend calls, but they also need to vote, and they also need to review vote. They also need to think about like why they voted. So this kind of thing, we realize that they take many hours, and then in order to have this kind of healthy and also expert delegates, they need to be paid. So that's why we decide to have compensation for delegates, and we have realized that a lot of different protocols also start to move that toward that way, right? Because unless you have this, then you're gonna have delegates that are probably not so active, or even if they're active, they might be funded more by like venture capital, right? Or like so it's you want to have like very diverse background from delegates. And then we decide to have more standards. That's why we have the MIP, which is the standard for Maker that we talk about. And then another thing that was interesting was that the question about the missions, right? Because now you became decentralized. You can imagine that in traditional companies, what do you have? You have CEO, right? So you have like, for example, people like Elon Musk or like Jeff Bezos, and they'll be like, you know what, I know I'm a little bit crazy, but this is my vision. We're gonna do it. If you don't like it, you can leave and stuff. Now in DAO, like we are basically, like everybody's kind of equal, right? So nobody can be like, okay, we wanna do this. Everyone needs to follow, right? Like, we don't have that. So what we have to do is basically the community members need to come up with some kind of proposal to how to like have this kind of mission, right? So right now, one of the big mission that has been proposed has been Rune, right? Like who's the former CEO of Maker. And then he has this idea for endgame plan, which in detail is very, very complicated. I think he can probably write a whole Bible on it as well. But the idea is basically like he wants to make sure that this is more structured in a way that there's some meta DAO, and then all the core units become part of it, and then they have their tokens and others. So it's pretty complex, but that's kind of his mission, vision and the mission. Then we also have, for example, others that have different ideas. So for example, like Hasu, some of you guys might know, he had this idea for like simpler DAO, and then his idea is basically should have a constitution, which Rune also thinks it. But his idea is a little bit like, okay, we should just kind of maintain the current status quo, change the political landscape a little bit, and not changing too much about tokenomics. So we have like different ideas, and that's kind of the beauty of DAO. Is like you don't want to say that this idea is bad and just like silence it. Like that's not the point of DAO, right? The point of DAO is that anybody can come and participate, and it's not about whether like you think that you know the best. It's more about like you want to learn from others, right? So that's what's more important. And let's see. Yeah, so I'm gonna have like quick section for questions if you have time. But yeah, if there's anything, like you can always feel free to reach out to me. And then this is true in a way. Like there's no really a true DAO per se. That's like in the end, like you can improve, right? It's an ongoing process. And then I know that it's more sounds like a Trotsky or Lenin, but I'm just saying like this is something that you have to continue to struggle to become more decentralized and improve. So thank you so much. And then if there's any questions, I will accept it. All right. Any questions? Like you can ask about like personal question too. You can even ask about favorite restaurant in Seoul. Like I can help.
Okay. So how did you facilitate MakerDAO from moving to a DAO-based model to a foundation back to a DAO-based model? And do you recommend other companies to do that in a certain way? And can you give examples on why should somebody do it like that?
All right, so that's an excellent question. So the question about like DAO to foundation to DAO. So I must admit that when I joined, there was Maker Foundation. So I was not at the Maker DAO like before that one. But I must say that for a lot of protocols, it's an interesting choice. And I do think that you have to kind of start with foundation to DAO. So the reason is that, so for a lot of founders, they say that like, okay, so we're just gonna have a DAO, we're gonna just have a forum, and then the governance is gonna run itself. Like, and I asked like, okay, I like your confidence, but like it's not gonna work like that, right? Because what we have to realize is that in order for governance to be run, you need to have basically interested parties come and also learn about your protocol. Also, the protocol itself needs to be very like strong, right? Like if you're in a place where it's not even developed, and then like a lot of participants don't really know like how to engage with the governance, that itself is it's not just chicken and egg problem. Like some of them kind of mentioned it's like chicken and egg. For me, it's more like common sense in a way. Like you can't just have nothing and then expect the community to form very easily, right? So yes, it's a balance between being organic as well as like led by the team, but what I kind of recommend is that in the beginning, you want to make sure, for example, a lot of these like standards, as well as documentation, as well as like forum and this kind of place is there, so they can come and grow, and then they can come and like improve the system. And then once you believe that it's sufficiently decentralized, or even if it's centralized, you feel like that you can slowly decentralize by giving away some of the power, right? So even for Maker, it didn't just start by becoming like, okay, this day we're going to dissolve, everybody go home and then do what you do. It was becoming like, okay, what can we decentralize first? So it became like, okay, so we can, for example, transfer some of the intellectual property, right? And then became like, okay, we can, for example, break away our business team. Because you can imagine like core like smart contract is like kind of tougher to decentralize. So eventually decentralized, and then the end was like, okay, now we're gonna also transfer the treasury to the DAO, right? So this kind of process is needed. And then I like to say that this kind of like, okay, we're gonna just do it at once, especially at the start. We're gonna do it when we do ICO. I would say that like that's a recipe for probably maybe getting you some money for your new apartment, but it's not really good for the community. It's kind of how I think about it. All right, anybody else has a question or want to challenge about the new apartment? All right, I guess everybody wants to go to after party. All right, well, thank you so much.
Yeah, some whistles. 안녕하세요. Hope I didn't butcher that too bad. Okay. I'm Ben from Starkware, and today I'm going to be talking about StarkNet account abstraction. Okay, so account abstraction on StarkNet. There's some caveats here, but for the most part, accounts on StarkNet are just smart contracts. So the more we dig in today, and like Erica said, we're going to get a little technical, and it is going to be a little bit of a workshop. But for the most part, accounts on StarkNet are simply smart contracts. So that's the model I want you to have in your head as we go through this talk. One of the caveats, and there are just a few, is that the entry point selector on the smart contract needs to have a function denoted with an execute function, with the underscores in front and the underscores in back. I'll show you a little bit why, but by and large, to keep a simple framework in your mind, accounts on StarkNet are simply smart contracts. So let's briefly look at some Cairo code. Just out of curiosity, raise your hand if you're a developer. How many developers do we have in here? Okay, cool. And how many people have written a line of Cairo? Nice, okay. So for a lot of you, this will be the first time looking at Cairo, and it might be a little difficult to parse, but I'll just point you to line 11. That's an external function that's called by other smart contracts. And like I said, it has the canonical entry point of execute. So double underscores in front, double underscores in back, and that notifies the StarkNet OS that this is, in fact, an account. The other line I want to point you to is line 14. So what is the purpose of an abstracted account contract? It's really so that we can call arbitrary functions on other smart contracts on the composable network, but know it's from a known party, and that includes a signature. So we'll go over signatures in a little bit. But on line 14, we're basically calling another contract from this contract and passing along the call data, which is an array. So don't worry if you can't read that, but the most important parts are the execute function name and the call contract, syscall. So besides the StarkNet OS, there's one other piece of tooling that needs to be aware that this is an account, and that's the compiler. So when we compile this account contract, we need to pass the flag for account contract. So a normal StarkNet smart contract will not be compiled with this account contract flag. Okay, so you've seen basically the simplest account contract you can possibly have, but why do we want account abstraction? What's the purpose of it? One of the benefits of not being the first mover in a smart contract platform is that we get to kind of see the way the developer tides ebb and flow, and it turns out Ethereum actually has a strong push to implement account abstraction. So if you want to know a little bit more about that, go to EIP 2938 or EIP 4337. You can see some of the history about account abstraction and attempts to implement account abstraction on Ethereum. But it definitely seems like devs are clamoring for account abstraction. So this is from Vitalik. The fact that Ethereum protocol itself requires everything to be packaged in a transaction originating from an ECDSA secured externally owned account, EOA, makes account abstraction very difficult. So one thing you get if you're a developer coming to Cairo, coming to StarkNet, is you get account abstraction right out of the gates. But again, why do we want it? Why is this a good thing? One thing is better wallet UX. So crucial piece of infrastructure, wallets. On the right side are a couple of the wallets on StarkNet. So Argent X is probably the most used right now. Bravos is kind of a new player. They're awesome UX. I recommend checking them out. Magnity is one. And then Laura from Consensus spoke about snaps. So there's actually a beta snap that is a POC right now, I believe. I don't know if Laura's here, if she left. It's in beta, and basically MetaMask will be able to support StarkNet signatures and accounts. So why do we want account abstraction for better wallets? So better wallets, what does that mean? You can have alternative signature algorithms. So being an EOA, controlled by a public-private key pair, you are regimented into the, I think it's SCP 256 K1, yeah, K1 signature algorithm. So if you have account abstraction, you can start playing around with other signature schemes, really any signature scheme. You also can get upgradability. This is something that ArgentX has already integrated. So since it's just an account, you can upgrade it like any other account. It can have a proxy in the back end, and you can implement new logic. Social recovery, key management. A lot of the Ethereum communities, I know Vitalik talks highly about social recovery. ArgentX specifically has a guardian setup. So if you have maybe a couple close friends, you can add as guardians, and they can vouch for your social recovery. That's just not possible with an EOA right now. Session keys for gaming. We'll get into session keys for gaming a bit, but the concept is basically, what is the UX for gameplay? If you have to sign each and every transaction and each and every state transition in your game, think about that through MetaMask. You're literally having to open MetaMask and click sign for every single transaction as they propagate through your game. So there's a concept of session keys, which basically is one authorized key that will give you a certain amount of authorized access for signing transactions over a certain amount of time. Multisigs, we all basically know what multisigs are, but multisigs become really easy in an account abstraction model. We'll look at that. And paymasters. So on StarkNet, anytime an invocation transaction is called, there needs to be a fee paid. And what is that fee? That fee is the L1 footprint of that transaction. So how much, and then also how much compute it was to execute the transaction. So paymasters, you can think about architectures in which a third-party account or a third-party contract pays the fee for the invocation transaction. There's lots of different use cases where that might be helpful. So payment abstraction. Not only can we go with different models for transaction payments, in the Encode Club hackathon in Paris, there's actually an NFT team who wanted to basically have an NFT with all of the NFT functions being paid for by a larger account abstraction account. Transaction payment made by the third party, so we talked about that, and then wallet to abstract the fee token. So at the base layer of the protocol, the token that will be paid in fees will be the Stark token. But if that is not the most user-friendly for certain DeFi applications, you can probably imagine, the account abstraction can basically abstract away which fee is being paid at that call level. So really what it is flexibility for the developers. We're not boxing in any of the developers. With all of that flexibility, though, we require some sort of standardization. So because you can have an account contract that implements arbitrary smart contract logic, how do we, as the community, know which account contract to kind of band around, to use? So we need standardization. So OpenZeppelin has created a slew of Cairo code for us, and it's really helpful for things like reference code. I recommend you to go look at Cairo contract source OpenZeppelin account. That's the subdirectory tree there. You can see how they implement it. But why do we need standardization? Because all of this flexibility, basically, there needs to be some set of accounts that we all know that we're using. Some set of call data layout that we know that we're passing. Some sort of base signature implementation that we know we're signing with. And then the last reason why we're implementing account abstraction is to empower the devs. And this is really the most important thing. We're dealing with a design space at this layer 2 level and eventually layer 3 level. I hope you guys got to hear Ellie's talk this morning, but some pretty incredible stuff happening in layer 3, empowered by Recursion, which went live today. You guys got the alpha. So it's just a completely new design space. So why would we limit the subset of designs for wallets, for all these things, to just a single public-private key pair? And a lot of the things we do at Starkware is to empower the devs. So one of the things that got me into the Starkware ecosystem is the optionality that it gives. You know, you can start playing around with volitions, validiums, and now you have you can play with account abstraction, you can play with StarkX, StarkNet. Really, if you have something in mind, you can basically implement it in whatever way you want on StarkNet or StarkX. So how to implement account abstraction? Quite a few of you are devs, so if you want to follow along, you should be able to. But we're going to look into some code here. Signing. So how do we sign and where do we send the signature? So the basics of signing are, and again, I'll preface this by saying this can be implemented in however the developer wants it to be implemented. But what I'm going to walk through is the basic implementation and probably what you're going to see as the default implementation in a lot of smart contracts, especially those Open Zeppelin reference code smart contracts. So off-chain, you're going to hash the transaction data probably with the Peterson hash. The Peterson hash is a Stark-friendly hash, which we use all over the protocol. You're going to sign with a private key. This is going to be a private key derived from the Stark curve, and that Stark curve is the basis of, again, a lot of the protocol. Submit the transaction with the signature in the signature field array, which is an array of felts. We don't need to dig too far into felts, but felts are the base scalar type for Cairo. And then verify with the stored public key of that ECDSA signing pair that you generated for the account. And then on the right side, you'll see a pretty stock implementation of a signature verification. So when we pass the array of felts into the smart contract, we basically just say, is this hash that we generated in the first bullet point there valid? And then at the code block below, this is how you declare a storage variable in Cairo and StarkNet. And if you see on line 12, this is completely an implementation detail up to the developer to call this variable public key and store the public key in the smart contract storage of the smart contract. And then again with the nonce, so you are pretty much always going to see a nonce with an account contract, so you don't get any duplicate signing. But again, this is an implementation detail that's up to the developer. Multi-call. So we've seen signatures. You can basically apply that concept of signatures to everything I'm about to talk about. Even though it's an account contract and a lot of the stuff is abstracted away, you're always going to want to have some signature of some off-chain party with a private key signifying that they did indeed agree to whatever the terms of that transaction is. So multi-call. Multi-call, you can batch contract calls in one invocation. You can reduce the number of separate RPC calls and create atomic invocations. One of the cool things about Argent X specifically, and a lot of the account abstraction models on Ethereum, is that they actually by default implement a multi-call. And then if you only have one transaction that you'd like to put on the network, it's still just a multi-call of one transaction. So think back to the original Hello account abstraction, the simplest account abstraction we had. What was passing in was a call data, and we were calling a single address on StarkNet. So if you look at this one on line 107, we're passing in an array of arrays of call data. So now we can pass in multiple calls for multiple contracts. Multi-sig, we talked about multi-sig briefly. Super important to the DeFi ecosystem. You don't want to be trusting a contract with one person managing one private key. So we have a share of security across signing entities, and a lot of the different configs in the construction of multi-sig, so 2 of 3, X of X, a lot of this implementation is easier with account abstraction. On the right is, some of these functions are collapsed, but it's kind of the base of what a multi-call looks like. And again, this is just a few developers have this stubbed out. If you have a different idea for a multi-call, a different idea for a multi-sig architecture, go build it. So constructor. Constructor is a call once function in Cairo and StarkNet. It's basically how we init smart contract storage and smart contract configs. So this is an example of a 2 of 3 multi-sig, and you can see that with the assertion of 3 owners and 3 public keys. So if you have 3 owners and 3 public keys and 3 signers, one of the signers will submit a transaction, at least 2 of the others will confirm it, and then we can execute it. And again, you see the execute canonical entry point there at the bottom, which is what you need to be an account contract. So example of account abstraction. This was done at our Dev Connect hackathon in Amsterdam by some community builders, Brick and Realms. And if you think back to session keys, this is what they've implemented. And again, like Ellie was saying, you know, the ethos that we put out as a company is really, you know, not super heavy on marketing, but super heavy on shipping code. That the community has basically inherited that. So we you know, this is a feasibility and something that you can be done with account abstraction. And guess what? In I think 2 days, this team went out and did it. So the problem statement: how can you play a high frequency game on chain? And the solution they came up with was ephemeral session keys. They created a one-time key stored in browser. And then for playing Stardew Valley, this is the transaction makeup that they decided to outline. They needed transaction data for the timestamp and for the X and Y coordinate of the plant that they planted in-game. So you can imagine how cumbersome that looks like if you need to sign every single plant that you plant. Well, they have the one-time key stored in browser, and that key has been authorized for a certain amount of time. And now the user signs only one transaction for the game session. They did it in, I think it was 24 hours. It might have been 48 hours. So they have some potential upgrades that they can make to it. A spend limit. So one key might have a certain amount that it's capped to spend. Function call restrictions. So you can imagine a smart contract wallet that only allows certain keys to call certain functions. You basically get into all the slew of different configs for what can be whitelisted, what can be permissioned, or you could go with the base level multi-call and more. And so that's kind of the point I want to drive home, is that, you know, these smart contract account abstractions enable you to do anything. So here's the workshop. We're not able to live code, but I've taken some screenshots. So hopefully, if you do want to follow along, feel free to. Check out Starknet EDU on GitHub, and then this is the repo for Starknet accounts. You should be able to code with, but if not, no worries. If you're trying to catch up with this after this workshop or after this talk, there's a README in Starknet accounts that you can go through. Has all of the same information, so you'll be able to hopefully go line by line and see how to run this workshop. So the environment for developing Cairo looks like this. In setup env, you need a Python virtual environment, and you need to activate it. We're going to install the requirements. So the requirements for this tutorial are the Open Zeppelin Cairo contracts, which we talked about a bit. It is the Cairo language itself, including Starknet and the Starknet DevNet. So for devs, I recommend this cadence, and you've probably seen this cadence in other places, like if you're a Solidity developer. But if you look at the bottom, unit tests first, then deploy to DevNet, then deploy to testnet, then deploy to mainnet. So things like testnet and things like mainnet, even though they are fast, and even though they are getting faster, especially with certain implementations in Rust and certain other scalability techniques we're employing, they are still slower than running on your local machine. So let's say you're Solidity dev and you use Ganache, that is going to be comparable to the DevNet. So check out the DevNet. Again, it's in the README. But the typical development cadence I would suggest is unit test, DevNet, testnet, mainnet. So after we installed the requirements, we initialized the DevNet, and the line for that is there, Starknet DevNet on port 5000 with seed 0. Because we initialized the DevNet with a 0 seed, we get a deterministic pre-deployed accounts, which means that we know the public-private keys and addresses for all of the DevNet accounts, which means we can start playing around with it. The DevNet pre-deployed accounts come with a certain amount of Ethereum, so we can start to pay gas fees with them. Like I mentioned, any invocation transaction, any transaction that alters state is going to cost money, and it's going to be the L1 footprint of that invocation transaction. So we do need, that's why we need the seed 0, is because we need some gas money, basically. Okay, so now we deploy the evaluator. So the way that this workshop and actually all of our workshops in StarkNet EDU are set up is there's an evaluator. So you go out and deploy these incremental steps in this learning. So multi-call, multi-sig, account abstraction with a SECP 256K1 signature. So that's the Ethereum signature. And we have an evaluator smart contract that goes through and says, yes, you did indeed sign a transaction how we specified you to sign it. So on DevNet, this is how it looks. You just do Python 3 evaluator.py on DevNet. And if you did the previous step of initting the DevNet, you should be good to go. And you should see some smart contract addresses start populating for the registry, ERC20, and evaluator. If you've done everything correct, if you've implemented all of the smart contract logic as we've stated, then you will get paid in the ERC20 that you see there, which is not worth anything, but it's fun. Okay, so next step is to deploy the contracts. So we've deployed the evaluator, so we know if you've done the exercise correct or incorrect. Now we'll deploy the actual exercises. So Python 3, hello, hello Pi. At the very top, you'll see the mission statement for what we're looking for you guys to do. We're looking for you to deploy an account with a contract with an execute entry point, like we've talked about. Fetch a random storage variable from the validator contract, and then pass that random storage variable in call data to your account contract. So now we start working through basically all the steps that we talked about. Why does the smart contract need to be funded? To have gas to cover your invocation fee. How do we call another contract on StarkNet? Yeah, and if everything went right, you'll see an emitted event for payday, and you should get paid in absolutely worthless ERC20s. Again, just a reminder at the bottom, unit test, devnet, testnet, mainnet. This should come as no surprise to developers. You need to step through some sort of cadence before you feel comfortable deploying to either testnet or mainnet, really. Yeah, one more thing I'll say is that there is if you get confused about this repo, if you are going to go through this accounts contract tutorial, there's a branch of this repo called hints all. So, some of the requirements that we're looking for are a little esoteric. Some of them require you to implement 2 lines of smart contract Cairo. Some of them require you to do about 30 or 40. If you're confused, if you want to look at some hints, go to hints all, and it'll show you what a passable contract looks like. So here are some useful links. There was only a small subset of hands for Cairo, so if you want to get started with Cairo, check out StarkNet EDU. There's a couple other repositories in there for ERC20s, ERC721s, bridging, so we're a layer 2. StarkNet is the layer 2. If you need to know how to bridge to and from ETH-L1. And then Starklings. I highly recommend Starklings if you're getting started with Cairo. Some of you might be familiar with Rustlings, but it's a dynamic, test-driven way to start learning the language. Resources, so I recommend Awesome StarkNet. This is where you're going to find libraries, SDKs, documentation, tests. I go there for when I'm basically looking for anything. Docs, so cairolang.org/docs is where the docs are for Cairo, and then docs.starknet.io for StarkNet specific. So when you're writing a smart contract on StarkNet, you are writing a subset of Cairo. So you can actually do a lot more things with raw Cairo, and that's why those 2 documentation sites are split out from each other. Community, we'd love to have you guys involved. We have kind of a budding, booming community, so community.starknet.io. Come chat with us. And yeah, thanks. Appreciate your time.
Thank you, thank you. All right, let's do it. Let's decentralize the world. Let's show them how it's done. All right, so basically, I'll be doing some jokes in between so that you're interested. But in general, we are going to talk about Web3 and how do we decentralize something which is very as important as querying blockchains, all right? I think the graph is one of such protocols which is not just decentralizing the query markets, but also is making a standard to making indexing happen on a blockchain. I can say right now there are a few standards to write information inside a blockchain. One of them is EVM. And I guess the graph is one such which has created a standard to query the information from a blockchain via subgraphs. So let's just get in. Basically, the graph wants to be as decentralized as possible, and we have taken the first step in which the Graph Foundation is the governing body, and there are a few core devs working on it. I work for EdgeNode, which is one of the core devs, and there are other core devs also working on different structures. For example, Streaming Fast, which works on streaming the information in a parallelized manner and getting the queries in a very decentralized manner. Similarly, we have the Guild, which are the champions of GraphQL, so on and so forth for others as well. So that's about it. But the first question, which my friend Cami yesterday also explained, but I'd like to explain it in a different manner, is why the graph? So basically, I see, like, in coming to Korea, I see a lot of people stuck on their phone all the time. In fact, so much stuck that half of them have to, not even see the signals on the board. They see it down the side, right? So much stuck. And I'm sure most of them, given how good looking they are, must be on Instagram, right? And basically on Instagram, how many times you post a picture? If somebody is as good looking as me, might be once in 10 years or something. But most of them are posting photos once, but getting the information from that post, like Instagram, maybe 1,000 times a day, right? So you write inside a particular data structure once, but read from it 10,000 times, right? As of now, I would say the industry or the ecosystem is very much focused on writing inside the blockchain, and that's where Ben from Starkware is working on, and such other L2 protocols are working on. But I think if we want to make Web3 a standard, blockchain a reality, in getting the push forward to decentralization in internet, we will need to at some point in time get reads from the blockchain also in a very awesome and nice manner. And the biggest problem is that when you try to query a blockchain, you get a block like this. You just need the blue information, but you'll have to get through all the blocks, study a particular part of it, and then get that kind of an information, which is not just tough, rigorous, but also makes blockchains really tough to get information from. So blockchain, I'm sure, is a security-first technology, and they have been built only to have security, decentralization, censorship resistance, and stuff like that we all stand for. But to make blockchain really implementable, we'll have to not just get the rights in a right manner with scaling, but also do the reads from the blockchain in a decentralized fashion and also in the right manner so that our code does not look like this. This is so, I would not use the words if I'm not allowed to, right? This is for any developer, this is a very big nightmare. Just scanning every block, finding every information, getting all the information, and then querying it. Oh my God. No wonder why blockchain engineers are so highly paid, right? Okay, cool. That's all a joke on me. But anyways, so that's how you actually get the information if you don't use the graph, because people query it directly from the blockchain. It's like a user interface that exists that writes inside the blockchain, and we have awesome L2 solutions to do that with scaling. But how do you read that information? Either you query every block, find every place, and then get the information, or the second way, which is even more shittier and not Web3 centric, is using servers. You store the information in server and get that information. That's not at all Web3, right? Remember, decentralization does not matter until it does, right? There are only black swan events when you come to know that decentralization is something we stand for. And we have seen that in the past few months with CFI going abrupt and stuff like that. And that's why we need to build for future with the graph, all right? So the graph is the query layer between your blockchain and the user interface. You write every information, using the blockchain, Starkware maybe, Ben, you told me to say that. So yeah, Starknet tokens. Just kidding. So you get that information and you want to get that information to your user interface. For that, you need to use something like a middleware, which is the graph protocol. And that's where the infrastructure comes in. I'm sure it's highly sophisticated, but because we are in a builders conference, I would like to go through it in a very, very quick manner, all right? So basically, what happens is your dApp first does a transaction, right, and writes inside a smart contract, which has events triggering on it. Every smart contract in Solidity as of now has events, right? And those events are what are caught by GraphNode. They actually listen to those kind of events. Those events then are stored via the graph protocol in a storage and made such that you can query them via the GraphQL API. So we go through it once again, little sophisticated, but let's understand it. Basically, you have a smart contract, there are events, some event is triggered, that is inside a graph node. That graph node actually gets the information, stores it, and it's in such a manner that you can query it via the GraphQL API. That's how simple and awesome this is. And I would say GraphNode is open sourced, and I would say one of those awesome public goods that people can use to query information. Right now, I would say most of the Web3 world, including Uniswap, SushiSwap, all the awesome DeFi, NFT protocols either use the graph or use the graph locally, running their graph nodes locally. So, you know, our biggest competitors is us only. Again, so that's how, like, you know, it's industry standards we are making with the graph. This is one such Uniswap subgraph, and basically why don't you see it in the forefront is because it is powering this. The API, if you're a developer, you go on the network end and you find out how do you get this kind of information in Uniswap, you'll be able to find out it uses the api.thegraph.com/Uniswap v2, and that's how the graph actually empowers the infrastructure of Web3. So this is how it works, right? When you are creating a smart contract, make sure you have certain events which can be fired via subgraphs so that you can get the information to your UI. That's how a Web3 stack is built. You cannot run servers on Ethereum and call it dApp. No. That's just an application running on Ethereum, and maybe you want to launch a token to have money grab for. That's not how Web3 will be built. If you really want to stand for Web3, really want to stand for decentralization, you will have to use the Web3 stack. You cannot use AWS servers and call it decentralized, because I'm sure Amazon, as of what I know today, is not decentralized. The stock price is still up, right? That's why. No, again. So I'll keep cracking these. One of these will work, believe me. So basically, that's why you need to use the Web3 stack. And if you don't understand how Web3 stack works, again, I would suggest you to check Cammy's workshop yesterday, in which she explained that when you're building a dApp, you need certain middlewares so that that blockchain that you're querying from is usable. And one such middleware to use is the graph. Right? We are right now live on 39 chains. As of now, sorry, Ben, not on Starknet, but soon. Right? Similarly, we are live on 39 chains. Most of the EVM chains, as well as Near, which is a non-EVM chain, and we just announced being live on Cosmos. So if you're building such an important critical piece of infrastructure, and I'm lecturing you guys on why decentralization matters and giving you certain quotes like Steve Jobs levels, like almost. how do I call, like, you know, if I'm working on a middleware that is decentralized? Just imagine you are doing something as important as querying information from the blockchain to the dashboard. And from that queried information, people will be taking, let's say, some arbitrage trades. If that information is rugged or is, like, you know, censored by a particular database, then I would say we are not there yet. We are still building a middleware which is centralized, and again, it has points of failure and stuff like that. And that's why, boom, we launched the Graph Network. Not today, 1 year ago, okay? So basically, we launched the Graph Network. The Graph Network is the way you decentralize querying in blockchains. if you are querying a decentralized blockchain, it has to be in a decentralized manner, right? So basically, back in 2019, we launched the hosted service, which was an MVP, just to make sure that what we are building and the architecture that we have is good enough to actually query the Web3 world and make sure it works. We got the MVP, we got most amount of adoption, most of the DeFis of the world, most of the NFTs of the world do use the Graph hosted service at that point in time. And then we were like, no, this is not it. Then we launch a token, then we realized that's not how it works. You have to make the decentralization keep on happening, right? And that's when we launched the Graph network. It's like the decentralized version of the hosted service. In the hosted service, there is one particular entity indexing your information, putting the data, and putting it out to the GraphQL information. But in the graph, there are different participants which actually make this whole sophisticated querying model come to truth. Just imagine you have to query something as sophisticated and decentralized as Ethereum, right? And you have to do it in a decentralized manner. I'm sure it is tough, and that's why there are certain things I would like to explain you about this. Basically, the graph participants, again, I touched a brief about them in my Biddle talk, but again, I would like to talk a little bit about them. The first one are the indexers. The indexers actually index the information that is required by you. There are thousands of subgraphs, right? And indexers pick a few of these subgraphs so that they can index that information from you. The second one are the curators. How do indexers come to know which particular subgraph to index, which particular place to go for to getting which particular information? And that's where curators signal. Curators signal the graph token on the graph network saying that this subgraph is very important. Something like cryptofees.info, such an important page. From that page, I think most of us come to know which particular protocol is doing great, how much query fees one is generating. And if that is querying api.thegraph.com, by the way, it does. How do you make sure that it is not censored, right? Curators make sure that they curate enough on such subgraph that most amount of indexing is done from them, right? So curators curate on a particular subgraph, and more the curation, more the indexers. More the indexers, more the decentralization, right? Then we have delegators, which are like, you can say, passive income earners on the graph network, and then there are consumers. Uniswap subgraph was created by the Uniswap team, but it is actually queried by many dashboards of the world, many applications of the world. There is Rotkey app and whatnot, which actually uses the Uniswap subgraph to get information in their front end, right? So basically, subgraphs are created by dApps, but are used by the world because we believe that APIs or information is again a public good. Simple example, Twitter launched their API back in 2015, I guess, or 16, and many people built businesses out of the Twitter API just to get information and things like that. And when the information or all this API model became successful, they were like, yeah, just F off, we are closing the API business. All the businesses that were created from the Twitter API were shut down, right? So that's why I believe that APIs that are built in the world have to be a public good. Anybody can query them, anybody can get them, and that too in a decentralized fashion. And that's where the graph comes in. You can say the graph is one of those public goods in which information on the blockchain is queryable in a decentralized fashion only if you use the graph network, right? So this is how it works. Again, just I was a very dumb kid growing up. I used to revise 100 times and then also get 2 out of 50. So I'm going to follow that again. Basically, there is a query market, right? Query market actually has all the subgraphs listed. For example, this is a query market, right, that the graph network has. There are different subgraphs that are deployed by different people, right? But the curators are the one which tell you which subgraph is the most important one. As of now, you can see Lido. The merge is happening, Lido is coming. It is one of the most important subgraph, might need most number of decentralization. By that we mean most number of indexers, and that's why it has 175K GRT curation in it, right? So more the curation, more indexers index the Lido subgraph. More the indexers index, more is the decentralization that happens. How do you consume the information from the Lido subgraph? You go on the subgraph, catch the API and start querying it. You pay per query. cost of service is pay per query, right? And right now we have 165 indexers, 10,000 delegators, 2,500 curators, and many subgraph. If you're a subgraph developer, go develop a subgraph on the network. I'll be around. If you are a dApp who wants to migrate and wants to taste the flavor of decentralization, please catch me up. I'm one of those who really like the decentralization ice cream, and that's why gelato is my favorite ice cream. Okay, cool. Anyways, curators, which are 2,500, then there are delegators, and basically, if you are somebody who understands the industry and knows which subgraph can be important, go curate on the graph network. If you are somebody who is who maximizes why decentralized querying is important, go ahead and delegate on the graph. If you are somebody very technical, right, somebody who can really write Cairo code, then please go and index on the graph. All right? So basically, I believe right now there is a lot of hype and a lot of real projects. And you really understand which protocol or project is doing good when the revenue or real people using the graph or that particular protocol are existing, right? I think there are many people who store information in the Arweave thing. And that's why, Arweave is one such which has real value accruing on it. People pay in Arweave tokens to store information in Arweave. But second one is the graph, right? If you want to get decentralized query, you pay in GRT token. And since we launched the network, we have like a 2,200 year-on-year increment in the number of subgraphs that have deployed and the kind of queries we are getting. So I would suggest you guys to check it out. So there are about, you're not the first one who would ever deploy to the graph network. If you are there, there are so many who already exist. It's just that you will be the one which will be tasting the flowers of decentralization right now. All right? So that's about it. Now talking a little bit about the Ethereum mission and how the graph is aligned on that. Some of you might have seen Vitalik's talk in which he told that there is a merge happening right now. All of us are excited about it. Yay. I hope it does, right? I know the timelines, but cool. Yeah, Ethereum has paid for this, so yeah, cool. So anyways, basically, there is merge happening right now, then there is purge happening, which is sharding and stuff, and then there is purge happening. Purge is basically in which Ethereum will get over all the historic data that exists in Ethereum. Right now, you want to get information, you have a full node running. If you don't want to use the graph, you start querying information from Ethereum. But as per Ethereum and many people who are working in Ethereum, including Vitalik, they think that it's not Ethereum's goal to read information from the blockchain. It is just there to write information from the blockchain and other L2s to write the information. But it does not want to get people to read that information. And that's why EIP 444 is coming, Purge is coming, and that's where the graph fits in. Ethereum in the Web3 world will be the one which will be storing the information or storing the final state, where Starkware will be the one which is doing all the query, all the computation. I hope. But if you want to get that blockchain information outside, right? How do you get that? I think you have to use the graph then. Right now, it's an option to be decentralized. In the future, it will be a compulsion to have decentralized querying. That's why I would suggest you all guys to start on the mission, build a subgraph, and I'm sure you're not going to regret it. And because, we are so much into decentralization and we believe we are solving this problem of Ethereum, of EIP 444 and the blockchain data, we have announced the sunset of the hosted service, which is the centralized product of the graph as well. There could have been an option to okay, the hosted service is working great. Maybe the graph network requires certain kind of participation and it's a little pain point. Let's just ask people to pay for this kind of service. But the graph protocol does not stand for that. The graph protocol stands for decentralization, and that was the reason it was created. And that is the reason we have told that we are gonna sunset the hosted service soon, right? We are gonna sunset the centralized infrastructure so that in the future, whoever queries information from the blockchain does not get censored. Whoever creates businesses, like people did on Twitter API, creates businesses on blockchain information, they never get censored, they have no problems in running their own businesses, and basically all the information and data of the world is decentralized. So this is the roadmap I would suggest you guys all to check, because there are so many things that we have to do. I would say, like Vitalik once said, that Ethereum is 40% complete, Bitcoin is 80% complete. I would say the graph is 20% complete. Don't quote me on that, but something like that, okay? Around 20% complete, and there is so much that we have to do. So join the mission, make subgraphs, index on the blockchain, curate on the network, query the graph network, and I'll see you around in the Web3 world. When is the graph going to be on Starknet? So basically, like, if you want to have the graph integrated with any chain, and we are multi-chain, we believe in the multi-chain world, right? You should actually make your blockchain firehose agnostic, right? As I told you, it's a little technical, but I would still go through it, right? So basically, if you want to get information from the blockchain, how tough it is, because the security-first model has blocks and has the information. If you want to get that information, what we have done with Near blockchain as well as Cosmos, is that convert that information to Firehose infrastructure. And that Firehose is integrated with the graph node to get all the information. So soon as Starkware is compatible with Firehose, we will get the information. I'm sure Starkware wants to do that, and yeah, we'll hear from them soon.
Thank you, Erica. I'm Tech. I represent a organization called Gnosis Builders, which is a newly funded ecosystem team from the Gnosis DAO to help grow the new Gnosis chain. And I'll talk about the Gnosis chain, which is a very new chain you may or may not have heard of. And also representing a fund, crypto fund called Factor. And previously I was at Binance running the venture arm. Today, I'm gonna give a presentation about what to build in crypto. I changed it to Web3 because that's the new kind of way we refer to crypto. I gave this talk at ECC Hack, and I'm going to recycle with some of the ideas here. Okay, so this is the agenda. We're going to talk about what to build, and I'll do a quick intro on the Gnosis chain. So this is how I think about the blockchain stack, or Web3 stack, if you will. There are various ways that people think about the stack. I kind of try to simplify it so that you guys can think about where in the stack you want to build. You have the base layer, which is some of the layer ones, or even I would classify layer twos, and the next level up, which is infrastructure, where there's rollups for scalability, the bridges, oracles, nodes, blockchain indexers, identity solutions, storage, and things of that nature that build greater functionality on top of just a decentralized ledger. And then above that, there are services that would help developers build applications, as well as help users use those applications. So on the developer side, you have developer tooling like IDEs, faucets that give out testnet coins, testing infrastructure, explorers, SDKs, things like that. And then on the user side, of course, you have wallets and different front ends, the different protocols, on-ramps, fiat on-ramps and off-ramps, and security services and things of that nature. And then, of course, above that is where most users would interact with these sort of verticals or types of applications that have gotten traction in the past few years. DeFi, obviously, NFTs, DAOs, GameFi stuff, and social. So this is how I kind of think about, especially in the context of a hackathon, what kinds of things that you might want to build to submit to a hackathon like this. So before I dive into each vertical, which I'll talk about like things that could be useful, there are a few things that I feel like all developers should be mindful about, which is often lost in the kind of hype and kind of excitement over the latest, greatest things. But there are some things that are kind of enduring in the space that we should all pay attention to. I call it invariant properties of Web3. Things that the very reasons why we're actually all in this industry, right? The properties we care about are things like censorship resistance, verifiability, independent verifiability, immutability, things that, once you get committed to blockchain, don't change. And then composability is a very important thing, where blockchains are open platforms, and by definition, they are composable, meaning that every single thing you build on it has an API, if you will, that other people can build on top of, by definition. So those four properties are kind of important to have in mind when you build a blockchain application. And then also one other thing that, especially when you're building something lower level, is the blockchain trilemma. I'm not going to get into it, but there are three kind of properties of blockchain: security, decentralization, and scalability. And you can't have all three properties at once. You have to give up two for the other one, or you have trade-offs between those three properties when you build a decentralized ledger or decentralized blockchain, or even decentralized app, right? So you just search for blockchain trilemma. I think Vitalik talked about, wrote, an article about it, and many people have since wrote about it as well. So I encourage you, if you haven't heard of it, to go understand what the blockchain trilemma is. And then this is related to some of the, reasons why we're doing this, because we want to have a trustless platform. So understanding what the trust assumptions in your application, in your, you know, in the platform you're building is important. What are you giving up in terms of trust? And then lastly, I think a lot of people have, in a space in the past few years, caught up in the hype. So a lot of the value that you see that have been injected into the industry is mostly speculation, but then there's definitely value being created. So understanding where is the speculation versus where true value is created, where there's product market fit, is important. So those are things, like the last point is, you know, where it's something that Web 2 is very concerned about. When you have a Web 2 company, you usually need to have product market fit, and you need to have revenues, and that's how you reflect values, where value is being created. But in Web 3, sometimes that is kind of lost, and the value is just coming from people buying tokens at a higher price. So I feel like these things, you know, are important to be reminded in a hackathon like this. So I'll go through, you know, from the previous diagram, all the layers and the verticals, and what, in the context of a hackathon like this, and things I've seen in previous hackathons, how you should approach and where your interests are. If your interests is in the base layer, I think it's really hard to kind of come up with a base layer or layer 1 new protocol at a hackathon with strangers. So when you're interested at that foundational layer, I think what you can do at hackathon is to maybe think about new standards you could propose to the community, or even like scour some of these forums that's outlined in this slide. Like Ethereum has the Ethereum improvement proposals. Look at some of the proposals that have been published. ETH Research is a good resource too. And of course, I represent Gnosis Chain. Gnosis has a forum that people post interesting ideas to. And then at a hackathon like this, if you have new ideas, you can expand on existing proposals or propose new ones, or just implement like a prototype of an existing EIP standard that's still under review or people are still discussing, and that's going to be a kind of productive thing to do at a hackathon. And then going up the stack at the infrastructure layer, there are a few things that, you know, I feel, you know, are interesting to build at this stage. They're missing, or they're not as well. There's, you know, people are not paying enough attention to it, or not enough innovation happening. So the first is bridges, right? Bridges. There are many, many bridges out there. I think in order to understand, and bridges, of course, connect different blockchains, or different from layer 1 to layer 2. And I think before, you know, start going down the bridge, building a bridge, or building something on top of a bridge, I think it's important to go read Vitalik's post on Reddit about, you know, cross-chain versus multi-chain. I think that's a link to a tweet as well. If you search cross-chain versus multi-chain and Vitalik's name, you find his tweet storm or the Reddit post. He basically argued that he feels like, you know, cross-chain has a lot of issues. So he thinks that multi-chain is going to stay, but cross-chain may or may not be realized because of inherent security issues. And even though, you know, I feel like it's going to be a multi-chain world. In a multi-chain world, bridges are still very important. So there are different forms of bridges, and it gets confusing really quickly. And different models of bridges, they use different consensus models and trust assumptions and things like that. So I feel like a bridge aggregator of sorts, and even a UX improvement on current bridges could be something very lavish to do, especially now that more and more chains are coming online, and even more and more layer 2s are coming online. Helping people, you know, from one UX, a UI, be able to understand what's going on to bridge the assets over could be interesting. And then next is simplifying sovereign node staking and validators. I think that is often lost in the discussion sometimes. I think having people run sovereign nodes either as a fully validating node or a node that actually has something at stake when they verify or when they validate is important. So, for example, Beacon Chain has about 400,000 validating nodes running right now. It's super decentralized. Bitcoin has like 14K full nodes running, right, validating the network, not necessarily mining, much less on the mining side, but there's I think 14,000 nodes verifying the Bitcoin network. And the Gnosis chain is about over 100,000, I think. That is a measure of decentralization, right? So helping individuals or independent entities or a person to run a sovereign node to validate or just to verify transactions on the chain, I think is very important. It's still pretty hard today, even for technical people. So making it easy is great. And then the third, privacy. I think that's often also overlooked. Privacy is a very elegant solution to censorship resistance. In fact, sometimes it's a necessary condition for censorship resistance. And there are different types of privacy, right? There's transactional privacy, where on the blockchain you shield the source and destination. But then above that, outside the blockchain, there's also transport privacy, where when you connect to an RPC node, you're leaking information there. And then on top of that, there's identity privacy, where addresses are linked to real-world identities. So there are different levels of privacy. I think there are very, very few solutions I've seen out there that protect all three, or even parts of like full stack privacy. And also, I mean, I moderate a panel at Build Asia about privacy with ZK stuff, but I think there could be more solutions out there. Of course, L2, lots of L2s are coming online. Optimistic rollups are not working in the way they're supposed to work yet. And of course, ZK rollups are very, very new. ZK AVM, we talked about that earlier. There's a lot of infra and tooling that are needed to help developers make use of L2s as well as users. Bridges are a part of that tool set that we should have more bridges between L2s and between L1 and L2s, and there should be more services that make, especially the optimistic model, the exit to L1 faster or much easier. On the dev tooling side, also, I feel like that's highly leveraged to do, because the easier you make it for developers to innovate, the more innovation will happen. And then on top of that, because things are composable, it compounds on innovation. So I haven't seen a lot of no code or low code tooling for whatever application, either for generic blockchain application or for vertical, like NFTs or DeFi or things of that nature. OpenZappelin and forking GitHub is the way to do it today, but they're still pretty low level. I think there should be, you still need to be pretty technical in order to build on top of OpenZappelin or fork OpenZappelin or fork other protocols, but I think there should be tooling on top of that to make it much easier. Next is like fair launch distribution models. Fair launch is a way of launching a project where it kind of follows the Bitcoin Genesis steps. But Bitcoin Genesis started, Bitcoin, of course, it's the first kind of cryptocurrency. But then with modern tooling, you could actually reenact what Bitcoin did with better coordination, better price discovery, better everything, with all the DeFi tools out there, as well as like Gitcoin. You can actually build a community much faster. You can incentivize core development way better, things like that.
And then relatedly, you know, like the next point is public good project management and bounty market. I think that is still you know, take any project, right? The core development is still not super transparent and is not very inclusive, if you will, because there's not a place where you can easily contribute, where you can see what's being needed. The bounty market is not very nuanced. So like people who are want to contribute but not yet fully ramped up on the project couldn't contribute little pieces here and there. So I think that could be, you know, a better framework for incentivizing development of any kind of public good. Yeah, so I think that's still kind of tooling is still pretty bad there. And of course, last one is like we need better and more abstraction so people can just build stuff quicker and easier. On the user side, that's the onboarding issue. Famously, you know, till today, people have been talking about it for 10 years, that crypto is really hard to use. I feel like wallets are still hard to use, even though we have a million wallets out there. You know, social recovery is you know, losing your seed phrase or just your password. You lose your, you know, if you use a non-custodial wallet, you lose your assets. There should be some recoverability there while not losing the property in non-custodialship. People talk about social recovery. Argent is one. Argent wallet is an example of that, on-chain wallet. But there could be more models out there that help users avoid mistakes and traps, right? I think there should be more faucets out there that's like essentially the quickest way to onboard onto a blockchain or to use an app on the blockchain instead of having to go to, you know, an exchange, buy a token before you can use an app. I think there's some solutions out there that could be more. And then on-ramps is still kind of frictionful, right? KYC is part of the friction, but then beyond that, I think there's still, for what they call normies, it's still kind of hard to get your first crypto to, beyond what they give out at a faucet, it's still kind of hard to buy crypto. Another thing is like, you know, we talk about decentralization, but then most of the time the UI UX is being hosted as centralized services, and those become choke points, and those become the single centralized, that just defeats the purpose of the entire stack. If the entire stack decentralized until the thing that, you know, users interact with is completely centralized, then that really defeats what you're trying to do. So I think there could be more unstoppable interfaces to protocols or smart contracts on the blockchain. Yeah. So liquidity is an example where they fully decentralize the front end. So anybody, the community can just run front ends on top of their smart contracts. So the stack that, the app stack is where users will interact with your, interact with the blockchain. Like people don't come to the blockchain to, people usually interact with the blockchain through apps, right? So I think it gets very confusing when you have like, you know, 25 different lending protocols and you have no idea which one is doing what. And usually it's just hard to pick out or understand what they're trying to do. So I think aggregators in general, regardless of whether it's for the purpose of optimizing a price or optimizing something, optimizing education, optimizing understanding, things like that, basic abstraction layer on top of all the protocols out there could be a good thing to build. It could guarantee something, right? So, and then that itself could be a smart contract where you can verify yourself that they're not doing anything fishy on top of the protocols they're aggregating. So that could be interesting. In DeFi, okay, this is specifically for DeFi, I guess. For DeFi, structured products are things that make it easy for you to express certain financial objectives on top of financial markets, on top of the primitives out there. I think there's not enough structured products in DeFi. Vaults are kind of the first ones that help you sometimes boost your yield and things like that. But if you want to like do certain types of hedging, it becomes multi-step process. It becomes really confusing really quickly. So making that easy in a decentralized way, I think I'm going to see some products out there, but there's not enough. And then MBV protection is a pretty active research area in crypto. MVB resistance or MVB protection when you go trade or go participate in DeFi, I think there could be more solutions like CowSwap, spun out of Gnosis project, and CowSwap is a aggregator of AMM pools out there that prevents MEV. Basically, they match orders offline in a decentralized network of solvers, if you will, basically an order book of sorts off chain, so that MBV is not possible. I think there could be other models where you can do, like, for example, encrypted trading, encrypted trade, or encrypted orders could be one way to prevent MEV. Potentially other solutions too. So, and then that's a good area to focus on. Lastly, DeFi, you've seen multiple rug pulls and things like that. And because blockchains are fully transparent, the risks should be known and fully analyzed at any point in time. So you should be able to understand the risk of a particular financial instrument, but there's not enough, one, risk controls, and second, people putting out scores, risk scores, or charts, or things like that to inform people participating in DeFi what's going on. So I think those things could be interesting to build at a hackathon. NFTs, today there's no fully decentralized marketplace. Everything has a centralized component. You've seen some complaints even today about people's NFTs getting blacklisted or marked as stolen or whatever. And there's a exploit, I think, where your NFT can be marked as stolen on OpenSea, and that's a centralized activity, right? OpenSea, uses its own judgment to determine whether this NFT is stolen or somehow illegally obtained. I think we need fully decentralized marketplaces where the marketplace itself is in a smart contract, and I don't think there's any today, and that'd be interesting to build one. Better NFT minting and dropping is equivalent to fair drops. Fair drops is still unsolved and somewhat related to the problem of proof of humanity because of Sybil attacks. There can be multiple models in the NFT world that is slightly different from the fair drop problem on the fungible token world, because there could be generative PFP projects where you want to do certain models of fair drop, whatever fairness you want to define as. So that could be interesting. And then lastly, I think maybe even Vitalik talked about it in the first talk at ETH Seoul, is NFTs dominated by PFP, art, flexing use cases, right? People buy expensive NFTs to put on their profile pic. But I think NFTs could represent, like Uniswap v3, staking positions or a bonding curve for AMM swaps. It could represent ticketing. ECC sold, ECC, the conference in Paris, sold their tickets as NFTs, soul-bound NFTs, which prevents scalping. And then, of course, NFTs for public goods funding, which Vitalik talked about, could be interesting. At the DAO, Gnosis chain is famously known as the DAO chain. I think DAOs, the way I see DAOs is like all crypto projects are DAOs, even Bitcoin. It's just a DAO with crappy tooling, right, with a forum and trolling on Reddit. But there should be, and then in every kind of democracy, if you will, the participation is pretty low. I think there should be more innovation around the UI UX to increase participation and increase engagement. And that's part of it is like helping participants or token holders understand what they're voting on and why they should be voting, why it's important. That's related to like, you know, even more informative, actionable DAO metrics, like what's happening in this project in a simple manner, so you don't have to like go to the forums and read through every single proposal. And also, you know, DAOs, you know, people think of DAOs as just a mechanism to vote on proposals, but I think like, you know, outside of just voting, there's a lot of social coordination that goes on before the vote actually happens, which is like lobbying, discussions, and things like that. People usually just use a forum, but that could be more, you know, there's real time, and then there's like asynchronous forums. That could be more like integration of those social coordination tools with the tooling that actually enacts affects the action, right? So that integration should be tighter. Right now, it's like you use disparate tools to discuss, and then you go to snapshot to vote, and then maybe use Gnosis Safe to some Moloch DAO contracts to kind of affect the action or compound contracts. But I think there should be more off-chain tooling integrated in those tooling. Of course, you know, on the blockchain, you're free to experiment with different governance models without a revolution. So I think there should be more different way, you know, in that like, you know, just experiment with different voting mechanisms and different governance models. And, you know, right now, I think the most innovative ones have seen all about delegation and things like that. And there could be more better or more innovative ways to govern a project. GameFi. In GameFi, I think, you know, a lot of people just issue an NFT. They're basically replacing their digital goods in a traditional game and minting an NFT instead of a digital good that is, you know, in your centralized database. I think that's less interesting than building a game from scratch that's only made possible by a blockchain. So things that have emergent mechanics and storylines coming from the community instead of top down. And then of course, because you're building a game that is on the blockchain, they're composable. So you're gonna be games building on top of games. That could be interesting. Game economics tooling in the Web 2 world in games, I think there are tools that help you manage your game economy. I haven't seen that in Web 3. A lot of the games in Web 3 have like bad token economics or bad game economics where, you know, you need more players in order to sustain the entire economy, whereas very, very little value is being created within a game. You've seen some of that. Even Axie has a little bit of bad game economy going there. So I think that could be tooling to help people design better game economy. ZK Games is very interesting. On Gnosis Chain, the 0x Park team has deployed the first zero-knowledge powered game called Dark Forest. It's a MMO game. Basically, hidden information games without a centralized server. You don't need a centralized server to hide information from the players using ZK Snarks. I think that is a, you know, area that is very, very interesting. You can build games on top of that. So those are the ideas, some of the areas that could be interesting, but let me do a quick intro to Gnosis Chain. Gnosis Chain is a very new chain. Essentially, it's a result of a merger of XDAI and Gnosis in about 7 months ago, 8 months ago. And we kind of, XDAI has been around for 4 or 5 years, and it's proof of authority chain, but since then, we've re-architected the chain to kind of follow the ETH 2.0 roadmap. So we have a Gnosis beacon chain and a execution chain, which is the original XDAI chain. And our kind of goal, if you will, narrative is to kind of accelerate Ethereum. And one of the unique aspects of Gnosis Chain is that it uses DAI, a bridge DAI, as the native gas token. so you know exactly what you're paying in USD terms. It's also the third most decentralized chain after Bitcoin and Ethereum. As I mentioned before, it has about 100,000 validators on the Beacon chain. And some highlights of the ecosystem, it's the home of the DAOs. Most DAO tooling default to Gnosis chain. And it's the home of POAPs. POAPs are proof of attendance protocol. And then, of course, Dark Forest, the first ZK game, is on Gnosis chain. To learn more about ecosystem, you can go to gnosischain.world, which lists all the apps on the chain. And then if you want to build a Gnosis chain, these are the resources, the RPC endpoints. There's a faucet that just got launched a few weeks ago where there's a mainnet faucet, so you don't have to buy XDAI. You can just grab enough XDAI from the Gnosis faucet for free to kind of, run transactions on mainnet. There's Explorer, Discord, and Telegram. So check out Gnosis Chain, and I think good luck at your hackathon. And yeah, that's it, guys.
Hello, hello. Alrighty, guys. So yeah, thanks for the wonderful intro, Erica. She's like a godmother in the Korean community. So if you need any support, any caring, you should actually come to Erica, right? So I'm John, CEO at Bliss Labs, and we are the research-backed advisory firm that is focusing on setting up the go-to-market corporate strategy for the companies that want to penetrate the Korean market. Well, to the Asian market overall. And I'll explain why I started with Korean market first, then about the APAC market overall. So I'm with my team. They're really great team in Korea that you should talk to in terms of the setting up the strategy, product, and in terms of the execution as well. So if you're going around, staying here, you can actually say hi to them as well. They're all back there with me. So yeah, hit them up. So the topic is about market shift in the Korean cryptocurrency market from retail to enterprise. So history, I'm gonna start with the history of how this Korean market started and why many people are so interested about Korea and fanatic about it. So first of all, it used to be just retail-driven market. Think about 17 when kimchi premium was there. So why many people were interested in? Because kimchi premium, K premium, it used to be 50%. 50%, guys. If you just send the token, let's say Bitcoin, to Hong Kong account, and then when you get it back, you can just easily get 50% arbitrage for that. So that's why trading volume by exchange in 2018, Upbit was the first, Bitham was the third. And also the other exchanges like Coin1, Corbit, these major forward exchanges other than these two were actually on the top 10 list. It's because of the retails were interested in getting their money out from Korea. That's why there was a huge kimchi premium there. But also at the same time, around that time, many projects thereby wanted to join in. So to illustrate more about this, it's a little bit hard to actually get Korean won or foreign currency out from Korea. And thereby, it's like a siloed market. It used to be, still now. So thereby, when these foreign projects want to penetrate the Korean market, A, obviously it's because of this huge retail volume, but B, they always needed to be listed on CEX. So that's why this trading volume happened like this. And second, so it used to be like this, but as you guys know, Axie, these kind of GameFi projects, and before that, DeFi started since 20 April. And starting from this compound minting governance token, everything has changed. That's why we are all here now with this fancy place. And it became enterprise-driven market. Why? Because they saw how this X to earn thing happened. So okay, this incentive model quite works well. What should we do? Well, usually bigger companies are well acquainted with this kind of like money move. So obviously they are interested in, but what's their kind of like barrier? Is obviously the legal, right? So when I was in Coin One, I had a hard time to actually implement any kind of like DeFi and CeFi driven services. So I made a partnership with Compound, but unlike Coinbase, when they made 3 to 4% yield per year service with Compound, we couldn't do it. Why? Because of the legal structure there. It was slow. But now, as the new legislation came in, well, a new regime came in, suddenly the overall kind of like tailwind changed. So thereby, this current cryptocurrency market is become more like an enterprise-driven market, which is pretty similar with the US market. So if you see, Binance has penetrated with all these game and entertainment companies already. They wanted to lock in the companies. That's why some of the big top three, like game publishers or entertainment companies already made a partnership. SM Entertainment, YG Entertainment, and Netmarble. Dunamu, of its parent company, they are working on NFT platform with Hive, BTS. Quite obvious reason, with their own chain. Third, so Dunamu is like a tech company. Binance is like an exchange, but from the foreign, overseas. And what about Hashed? It's a VC. And as a crypto VC, it used to be just investing in token deals. But now they made the venture funds to invest in the equity deals. What this means is just like Sweatcoin. It used to be just the retail-focused product on Web 2, but now they're interested in moving on to Web 3. That, in Korea, what they're doing now with the bigger corporates, bigger companies. Naver, SK, LG, they're some of the LPs to their venture funds to invest in equity. Why? Well, there are some back history that I might able be to share if you're interested in. But anyways, they should be, they are listed on the stock exchange. So thereby, they always need to go through heavy audits and the vehicles that properly works. That where Hashed supported a lot. So for example, why I actually made this another slide for illustrating about how Hashed is penetrating the Web 2, it's because now Korean market, it used to be just retail driven, but now it can be A, enterprise driven, and B, it is also about how these Web 2 startups can be Web 3. So they're leading it with, starting from the top down. So to illustrate more on this infographics, so in Web 2, they invest in non-crypto markets. So that can be actually transited from Web 2 to Web 3, where incentive model could work. And also, obviously, they invest in the crypto market, but that is just like the existing model that's been around since their beginning. And from Web 2, they raise joint funds, but also at the same time, they may help, they help indirectly entering the Web 3 market. So that's why I made this slide, because it is actually the, one of the tipping points where the Korean market has changed their stance. Also, as I told you about these Korean companies, they're just like sniffing the smell of money pretty well. So both large and medium to even small-sized enterprises or companies are expanding into crypto. There are two types in terms of size. Conglomerates who are listed on stock exchanges, they're already penetrating the crypto market. So especially SK, tipped to be the Korea's first group to issue digital coins. It was supposed to be Clayton, but they haven't actually shown us any updates yet. But we should see. But at least they actually PR'd. So obviously you have the certain reason why they actually PR'd as a conglomerate. What about the mid-sized and small-sized ones? There's a Seoul Seoul exchange, which helps out making these stocks unlisted to be tokenized. It's slowly starting. Obviously, they are working with the legal part, with the government. It's slowly starting, but it's already happening. Just like FTX, already does with it. They already tested out 2 years ago, 1.5 years ago. But in Korea, it's just starting. Yeah, so as I told you, after DeFi, GameFi, obviously, and it is easy to actually break into all these retail, retail market because, DeFi, it is mostly about whales. Games, it is for retails. Why? Time and money. DeFi was just about money, just like MEV. But what about this? Well, tech as well, but besides of that. But games, you should actually invest your time. That's what made all this difference. And you know that before League of Legends came into Korea in 12, these three big publishers, Nexon, then Marvel, NCSoft, used to make a lot of game titles. They actually acquired a lot of companies in the States, just like Jam City from Netmarble. But, things have changed. League of Legends just the top, right? But still, now they actually made the right move. Why? Think about IBM. Think about Microsoft. IBM didn't think about software. And thereby, Microsoft won over in the second phase. Now, it's different. Apple, Facebook, all these app-driven businesses they're doing. What about this? Now they got the point. Okay, this phase, we shouldn't lose. That's why we should do the token. Come to us. It is the game by Come to Us, Summoner's War, Lost Centuria. Game fan card sales by Come to Us broke records. DAU, 200% within 4 weeks. What about raised? 1.3 million from the retails, sold out in 3 hours. Simple. Why? Retail market now knows how this token market works. Well, at least a few percent up. But another point is, Mir 4, MMORPG with P2E mechanics developed by Remade. We invested in Snack Club, which is holding Loud GG, all these kind of like game publisher-driven like vehicles. And they're telling us that Mir 4 is crazy. It's so hyped up in Brazil. Why? Obvious reason. But because of that, they broke the records as well. Remix total trade volume and wallets after mid 4, it went up crazy. So concurrent users is 1 million and launched in 170 countries already. And NFT transaction volume is 130K on the launch date. I know this is a little bit bearish market right now, but they already had a pick. Well, I would say, at least in the short term, they already showed the breaking records. So obviously, when after this bearish market in the bullish run, you can already expect how these projects can work out. Just like the projects survived in the winter, and this season made them go. But so Korean GameFi market, in a nutshell, I would say, following the success of Come to Us and Remade, these are the companies that actually are working on token projects. Kakao Games, NeoWiz, Marvel, Krafton, NCSoft, even Nexon, obviously. Because Nexon actually has Bitstamp, and they already acquired stock from Corbett, which company you will see in the Republic and Corbett party maybe in the 2 days later. But anyways, they already most of them already issued, but others they're still testing the water. But obviously, they're already working on it. That's why many layer ones and game companies, from the overseas are interested to meet them. So why Korea? Korea is the only market where you can both build and sell, and these components sufficiently present. I would compare with some of the other countries in the APAC market. And first of all, in Taiwan, it divides into three aspects: smaller retail market, risk-averse population, and geopolitics. Two things actually make Korea more kind of like highlighted. It's because retail market, you saw the volume. Risk-averse population. Well, Koreans are relatively not risk-averse. They're quite interested in investing in crypto. That actually aligns with why retail market volume was huge. But another good point is geopolitics. So expats from Chinese market, well, some of them are already getting into Taiwan to actually do their business, or already many Taiwanese players are out there. So it's like a haven for Chinese crypto, we can actually say, as a, being like a Asian here. But also at the same time, cultural similarity with West, like Japanese culture, Western culture, it is quite well acculturated there. So it's good market to sell, but not to build. What about Japan? I know many Japanese friends, and I actually have him here as well, but they're really, really, really good at building. Just like Animoca, why they made the subsidiary in Japan? It's because they're really good builders. They're really focusing on one product. But that means it might be relatively hard to sell. So first of all, limited retail. It's because of the whitelist, right? And the second reason actually goes along with the first aspect as well. About limited retail, it's because of the rigid regulation. That's why liquid exchange was sold to FTX. Now FTX could do something out in the Japanese market. And also there's a rumor that FTX wanted to buy out Bitham. Huobi tried to do, Binance tried to do, but I don't know, maybe this time it could be different. But anyways, due to this difficulty to whitelist the tokens on Japanese exchange, total listed coins are only 40, compared to Coinbase, more than 100. What about Korea? More than that, all these pairs. And thereby, total trading volume is relatively lower, and tokens leading the spot trading volumes are different. XRP, XYM, XLM. These are the not trend that we are following up. But still though, as I told you, active development. So that's why many companies are interested in builders there. So that's why Korean market is only equal with both arms. One to build, one to sell. Then why not China, Hong Kong, and Singapore? I briefly kind of illustrated there. Of course, there are different dynamics and different vectors that we should consider in, but at least in a nutshell, I'm just presenting it right now. China, the NFT is even banned. Chain use, they're good friends, they're legit, but they have to shut down because of the obvious reason. And that's why it's really hard to do something out about crypto in China. What about Hong Kong? Financial center, yes. Also, legal entities, yes. But what about builders? Yeah, we could have some people from Hong Kong, but based in Hong Kong doing something, making as a crypto center, it's a little bit hard. What about Singapore? Yeah, it used to be one of the old, really financial centers, but also equipped with all these crypto companies, yes. But also, but lack of viable builders, and also 3 AC blowout, it actually made a huge consequences. Aftermath is still hitting us hard. Well, overall, Celsius, after meltdown, Luna meltdown, right? So that's why, compared to Korea, all these kind of countries in APAC region are relatively hard to do something out as region-driven. Opportunities in the Korean market. So in recap, it's more like this: strong retail interest, massive potential user base, strong enterprise interests, And lastly, favorable regulatory climate, especially after the new regime. So it's good market to build and sell, because think about this. As a founder, always it's hard to do both things, product play and crypto play. It's really hard to follow these both aspects. Unless you have really experienced it in different angles, you cannot really imagine what to do, how to do. So that's why Korean market, it can be sort of the, scouter for any kind of like projects, companies in crypto space. If they want to see APAC region overall, starting from it, the easiest path will be the Korean market. Starting from there, then trying to decide what to do next. It's like a geopolitics, as I said. So let's fly back to Ethereum. So why I wanted to be here in ETH Seoul is because Ethereum became the ultimate ledger for each and every one of the layer 1s, layer 2s, whatever. Here are the whys. Real euro usage, battle-tested security, and EVM compatibility. That third aspect actually came from these previous two aspects. I'll explain. TVL, DAU, monthly active developers. Look at that yellow. Totally different. It's almost 50%. Oh, it's more than that, 65%. Think about all this consensus mechanism. If it is more than 51%, it's a 51% attack. What about that? 65%. So these developers, they are kind of like adding value to that TVL. And it's because of these battle-tested security. Think about the recent hacks. Are you be able to have your 1 trillion, let's say 1 billion USD as a company to have it on other chains? I wouldn't do it. That's why this battle-tested security makes, obvious reason for them to choose Ethereum first. Or later on, at least having their state secured in Ethereum. Extremely resilient security, long history, decentralized, and thereby, if we think about gas fee, we can think of it as a trust premium. Many projects, many layer 1s, they're saying that these gas fee is low, that's why it is good. I know, but think about the trilemma that we are always talking about. Obvious reason, fee can be thought as trust premium, although currently like Deng Sharding, whatever, is actually focusing on lowering it down. But ultimately, it's like we are fighting against Fed. Think about that. If they're loading down the gas fee, what will be their advantages? And third is, it's actually the, good epitome of why how these two aspects affected the layer 1 ecosystem. All these chains, they didn't start as EVM. Well, some of them. They started as Ethereum killer. But why they become the EVM compatible chains? Because of these obvious reasons. And also, that's why Ethereum as the go-to chain for the big corps, because of this. Facebook, Polygon, and see about that? No other blockchain network has been better tested as Ethereum. And we are all liking about flipping the thesis, right? So Bitcoin and Ethereum comparison here. Bitcoin market cap, it used to be that huge gap between Ethereum, but now maybe flipping can happen. And security as the minimum requirement. So DApp and DeFi projects will return to Ethereum as a safe haven. So many of the projects were building on other layer 1s. After some, technical issues and also some, exploits, they actually decided to, go back to Ethereum and then decide on what to do next. Some of the Clayton-based dApps are also doing that. So if you can see, TVL, it increased 10% since May. So with the implosion of these alternative layer 1 chains, Ethereum has emerged as the biggest winner absorbing all this huge amount of TVL. That's why I told you it's become the ultimate ledger. So fundamental market shift from the retail to enterprise. Past, it used to be just mass adoption for retail. So when Ethereum developers projects, they make the killer the apps, retail consumers, mass adoption. That's what we had in mind. That's what we had as a theory. But it didn't work out. What about now? Mass adoption for builders and enterprises. Ethereum developers projects going to the app services, onboarding enterprises, then it goes, it trickles down. So this trickling down effect is quite important. And that actually attracting these builders, and that's why we can have many dev days or dev shops, including the Ethereum Seoul, obviously. So we can expect all this massive boom of crypto in Korea. So private blockchain, we had this hyperledger theory, thesis, and all this kind of like private blockchain, right? Enterprise blockchain, but it didn't work out. And it doesn't work out because of these obvious reasons. Why would we use blockchain for that? So it became the public blockchain plus privacy solutions. That's why privacy became a thing. That's why we had a ZK Seoul meetup, and these privacy is getting important and important. And now this like, what's it called? Like verifiable delayed like BDF or these kind of like technologies were there, but now it became like VDE, which is verifiable delayed encryption. So now we are even like, talking about these technologies. And obviously, these privacy can be soon to be applied to how we actually transact and how we can actually store the data. So this is the current market map of layer ones competing each other in Korea. Ethereum obviously there in terms of x-axis, number of dApps and developers, and y-axis, retail interest and attention. So yeah, like there are some notes down there, so I'll explain like there. So like firstly, Luna Meltdown, hashed portfolio companies, many of them actually moved to Polygon. That's why they recently announced a partnership. So obvious reason, Polygon went up. What about Clayton? It started from gas fee policy. It used to be free. But with the validators having some issues, technical issues, but also NFT projects having minting issues. But at the same time, recent rug pulls actually made their ranking go down. Third, Flow. After Sportium, the Korean NBA Top Shot, they tried to penetrate more and more in the Korean market, let's say working with the sports and entertainment industry players. What about fourth? Cosmos. So Coin1 is the first exchange that ICO'd Cosmos Atom. And thereby, many J is Korean, so like thereby many Korean retails bought out Atom at the cheap price, good price, and they held it, and thereby you can see a lot of good validators here in Korea, mainly focusing on Cosmos ecosystem. I brought in my head of tech, who is also from Coin1. He's a Digeneer of mine, Degen plus engineer. So if you want to say hi, you can actually ask him. He's right over there. And that actually, when I fly back to the privacy side, so that's why Starkware and Alio came to the Korean market as well to promote because of this reason. Because now, yeah, it's going to be about privacy, especially with the enterprises that will be interested in different stuff with privacy. Traditional Korean companies expanding into Web3. Two cases. First is LG, second is SK. So like SK, one of the subsidiaries of SK actually bought out Corbett. They not bought out, but they have some shares, majority shares in Corbett. And they already have setup wallet and all these kind of services that could be transited to Web3. So that's why I had this as one of the case studies. They even thinking of metaverse platform Ifland, with the plans to integrate the native cryptocurrency. What about LG? added objectives, blockchain-based software development and sales, and also cryptocurrency asset trading and brokerage, which means something for the conglomerate. And second is established a R&D center called iLab, and also Drop Gallery, which is also about the blockchain, especially about NFT, just like Samsung TV also decided to integrate NFTs. And lastly, Seoul Auction Blue, to push the NFT business, they actually partnered with. And also, many other big players are currently interested or at least testing the water now on the Web3. Even many other cases that I can explain, but that we could actually later on talk about it other than this pitch. One thing yet to be answered. So what do we need for this shift? Okay, now we have in mind, market is changing like this. There are plays like this. Okay, I sorted out whatever in ways. Then what we should do? How should we utilize this? Then we came in. Research, corporate strategy, that's our two main arms that we are doing. But not only the strategy, but also backed by research. But based on that, we do the execution together. When in 19, we built Kepler Wallet. I built Kepler Wallet with Kepler Wallet team currently, Chainapsis. And that was when we won 2 hackathons, one in Seoul and one in San Francisco. And that's when we met all these, huge players in the Cosmos ecosystem. And also, then we realized that, okay, product market fit is important. Product zeitgeist fit is important. So afterwards, when we built, Everett protocol, which is the liquid staking model for Cosmos, what we thought is we should do more of the research so that we can actually run the business properly in Web3. Not just idea-driven, but also equipped with actual good execution so that we can actually make it as a business. This is all it matters for now. Think about layer ones. Protocol fee is not enough. So that's why we need this kind of different approaches regarding the corporate strategy, but at the same time, in terms of the branding. Because, let's say Dgraph or all these other good Ethereum players like Starkware, Alio, they're really, really huge. But it's really hard to translate the language, not English, but more about their, thoughts, narrative to be sharply in a should way to the Korean market. That's what we found as a pain point. That's why we are doing this based on our continuous research, setting up the corporate strategy, then do the actual execution. So some of the portfolio companies of ours are DYDX, Human Protocol, Ocean Protocol, like zkLAN, Kledos, and etc. So we are mainly focusing on working with the infrastructure itself or infrastructure role players, because as I said, this is what Ethereum is all about. And that's the core of this crypto market for now. So we're bridging Web 2 startups to Web 3. We're starting from the bottom up. From the experience, what I felt, building Kepler Wallet with the great team and doing all the liquid staking protocol, what we felt is it's really hard to start from the bottom. 0 to 1 is hard, really hard. It's not only about your vision, but also how to implement it, but also how to operate the company. There are so many things to consider. Even me as a founder, it's hard. So that, what I experienced fully with my heart, wholeheartedly, I want to help, I wanted to personally help out these companies, founders, coming up from bottom up. That's what we do as a company. Web 2 to Web 3 expansion. So Web 2, we do the networking obviously, and to Web 3, based on all these business intelligence and market intelligence that we could have, we're setting up the corporate strategy, doing the BD, and later on, execution side, like PR, branding, even crypto marketing, because we need to target the different demographics altogether if we want to expand properly. So, yeah, this is pretty much about the overall Korean market's current situation, how it moved, what's the history of it, and what these kind of like key players are doing in the market. So if you have any questions, just ask me personally, or ask Erika or whom, yeah, so that we can actually have a talk and give you a clearer vision of how this Korean, including the APAC market, works. Thank you.
Oh. Hello, Korea. Hello. And thank you to our Korean godmother for hosting such a great event. This is my 7th trip to Korea, and it's always great to be back. The enthusiasm here is so energizing to see. The strength of the Origin community and the broader Ethereum and crypto community here is really, really cool to see. Today, I'm going to be talking about our journey in decentralizing our governance and handing over control of our smart contracts to our community. And so this is a really big and bold step for us. I'm going to talk a little bit about our process there. In particular, we're going to go into the VE token model that was pioneered by Curve. We're going to talk about what it is, why it's awesome, and how we can make it better. So many of you are saying Origin. I know you guys as the NFT people, right? We've done all these record-breaking NFT sales. You may know us for the sale we did with Blau in February of last year. Did $11.7 million, and it was in the height of COVID when most artists and creators were stuck at home not making anything, and that really opened the floodgates. And you can actually, looking back, you can sort of look at that moment and that sale is really the point in time when NFTs entered the mainstream consciousness. Up until that time, really only people who knew what NFTs were people at events like this. But thanks to that sale, we started seeing all of these mainstream artists and creators start getting into NFTs, but then telling their audiences about crypto. One of the most surreal moments for me was watching Paris Hilton go on a Jimmy Kimmel show and talk about Origin and NFTs. Crypto has taken me to some very strange and unexpected places. But it's really cool to see how these people can help educate and bring awareness of crypto. For me, I would have bet that DeFi would be the first killer application for mainstream people, but turns out it's actually JPEGs. So we actually have 2 products at Origin. We have Origin Story, which is the NFT platform we talked about, and Origin Dollar, which is our yield-bearing stablecoin. And so we're going to spend most of our time on the latter one. But just a quick summary for those of you who are into NFTs or interested in NFT marketplaces. Our product's called Origin Story. This is where a lot of top creators have launched their NFTs. We have a marketplace where you can sell your own NFTs on your own website, on your own domain name, using your own branding. You can control the entire experience. One of the things we just launched is the ability to do marketplaces. And so if you have an existing collection, you can actually create your own domain name and just have your NFTs and your collections of NFTs there for sale. And this solves a problem on OpenSea. If you go and you type in ape on OpenSea and you have dozens and dozens of different collections, it's really hard to tell which one is real and which one you're actually looking for. So this solves that problem. We also give the platform fee that we collect, we actually split it with the creator. So you actually make more money by driving sales for your own platform as well. And then lastly, for OGN holders, you can actually stake your OGN to earn a portion of the fees that are generated by the platform. And so we think this is a really cool innovation. It's a great way for people to be able to participate and actually do something useful with their OGN you're holding. So that's all I'm going to say about Origin Story for right now, but if you want to learn more, you can go to story.xyz or come talk to me afterwards to learn more about that. What we're talking about today is Origin Dollar, which is the first stablecoin that earns a yield while it's sitting in your wallet. And so today, more value is transferred using stablecoins than Bitcoin. And the reason for this is pretty obvious. You get all of the benefits of cryptocurrency, but without having to worry about the volatility. And so this is a great way to do international remittances or all sorts of anything you would use a dollar for, but in a digital form. But one of the problems is that when you're holding stablecoins in your wallet, you're not earning anything. And for me, that really bothers me. I want to always have my money put to work and earning a yield for me. And so what Origin Dollar does is backed one-to-one by other stablecoins, Tether, USDC, and DAI. And then those funds are deployed into some of the most battle-tested protocols in DeFi, Compound, Aave, Curve. But what's novel here is that as the protocol earns new yield, it distributes that directly to your wallet in the form of more units of Origin Dollar. So you don't have to do anything else. You just buy and hold it and watch your balance go up. The token rebases right in your wallet. For those of you who are yield farmers or have done yield farming, you're probably familiar with this common flow, where you stake your stablecoins in a farm. You come back, you harvest your reward tokens. You take those reward tokens, you go to Uniswap, you swap them. Then you come back, you redeplosit them into the farm again, and you repeat the cycle as often as you can because you want compound interest. Of course, this costs a fortune in gas, and it really eats into your earnings. And so what Origin Dollar does, takes away all of that complexity. All you need to do is buy and hold it, watch your balance go up, and you get all of the yields that are available in DeFi without any of the hassles. And this code has been audited by Trail of Bits and Open Zeppelins. There's tens of millions of dollars in it, so it's very safe and secure. We recently just launched a new governance token for Origin Dollar. We've been around since 2017. We have OGN, which is listed on Coinbase, Binance, Upbit, a lot of Bitfum, a lot of these big exchanges. But it's confusing having two tokens or one token for two different products. It was really hard to get the tokenomics right and explain to people the value proposition and why you might want to buy and hold one of our tokens and how the value accrual would work. And so we launched OGV, we airdropped it to OGN holders. So if anyone here has OGN and you haven't claimed your OGV yet, go and do that. Go find that claim page. You can claim that, or if you've held OUSD, you'll be eligible as well. But this is, as I said, the governance token for Origin Dollar. And you can actually stake your OGV for a portion of all of the fees that are generated by the protocol. So 10% of the yield that's generated by OUSD goes back to the people who are staking their OGV. And what's really important here is we have all these questions that come up on decisions that impact the funds and the security of the smart contracts. Questions like, which strategies should we be deploying? What is the right risk profile? Should we be totally degen and chasing the highest yield no matter what? Or should we be continuing on the path we've taken today, which is being very, very safe and conservative and taking all the efforts we can to make sure that things are, no matter what, we don't lose funds? Well, the people who should be making that decision are people whose funds are at risk. It should be the community. It should be those people who are making these decisions. And so this is a really important shift for us of actually handing over control to our community to actually implement and actually vote on these types of really critical decisions. As we were looking for how we wanted to structure our governance system, first thing we looked at was Curve. And for those who are not familiar, they came up with this really great model. It's now known as VE token model, but it's really started with Curve, where they said you can take your CRV, you lock it up for anywhere between 1 week and 4 years, and then you get VE CRV in return, and that's your voting token for participating on their protocol. And what's really, really great about this model is that it transfers power to the people who are most committed to the long-term success of a protocol. Because what it does is the longer you lock up for, the greater your economic and governance power. And so this is a really, really great characteristic. The more the more CRV you lock up, the more VECRV you get. More VECRV you get, the more rewards you get, is also voting power. And as a kind of an illustration of just how successful this model is, it's been copied by dozens and dozens of other projects in crypto. You can see some of the names here: Frax, Balancer, DYDX, Yearn Finance, Platypus Finance, StakeDAO. In fact, there's even a VEMarketCap.com that has a list of all of the projects that are using this VE token model. And there's almost $10 billion that's being secured by this governance model that they have pioneered. But one thing that people haven't really asked is, how can we make this model better? It's great, but how can we make it better? When you look at every one on that list, almost all of them are copy-paste. They've just used the exact contracts that Curve wrote. And to be fair, that's actually a pretty good instinct. It's always a good idea to reuse battle-tested code whenever you can. And if something's working well, there's no shame in copying it. We have seen a few attempts to make it better. Frax required a whitelist for smart contracts to be able to participate. And for those of you who are following the Curve Wars, you know why. Right? Convex came along and added a wrapper to Curve's non-transferable VECRV tokens to make them liquid. And then they were able to capture an enormous amount of the voting power for Curve. And today, the majority of the voting power on Curve is controlled by Convex. Interestingly now, Frax have partnered with Convex, so they've now gone in complete opposite direction with that. Yearn also offered an option to exit early before the lockup expires, but for a fee. But again, other than these couple small tweaks, we haven't seen a whole lot of changes to these contracts. And so as we started working on it, we came up with a little bit of a wish list of how, in an ideal world, what would these contracts look like. One thing we thought would be nice would be to have it written in Solidity instead of Viper. Our development stack is just Solidity. Nothing against Viper, but that's just how we have everything else set up, and so it'd be convenient to have these contracts in Solidity. And when we looked at the code, we said it's kind of complex. There's like a lot of things here that we could improve, and by removing complexity, we could probably improve some of the gas costs. And if we can lower our gas costs, maybe that will help encourage higher participation in decentralized governance. One of the weird quirks with Curve's model is that your voting power decays over time. And that means that the amount of voting power you have is different from the amount of tokens that are transferred to you when you do your initial stake. And so if you sum up all your transfer events, you come up with a number, but it's not actually representative of what your current voting power is. And this means that if you're building like a Zapper type integration, you have to actually go and check the smart contract to know what the voting balance is. There's no way to just like look at how many tokens are in your wallet and know what your current voting balance is. Kind of a convenience thing, but you can only have on Curve, you can only have a single lock per wallet. So unlike Convex, where you can create multiple locks, one wallet, one lock. And so, it's very convenient to be able to say, hey, I want to lock half my tokens for 1 year and half my tokens for 4 years. On Curve, you have to split them up between multiple wallets, and it's kind of a pain to do that. But probably the most important feature we wanted, and it turned out to be the hardest one to implement on Curve's contracts, was voter delegation. And there were really two reasons we wanted this. First, we see this problem all through DeFi and crypto where there's low participation in governance overall. Not a whole lot of people are taking the time, especially paying gas, to go and vote on these important issues. And it's not actually reasonable to ask everyone to be paying attention to every single proposal that is going through. But a great thing you can do here is actually ask people instead to delegate their votes to the people they trust in the community. People they know are going to be paying attention, they know are going to watch their back and be making smart decisions. So representative government is a great model here and something we wanted to support. And then the second use case is one we have personally of like where we want to separate where we store our funds and where we do our voting. So you might want to hold your, if you're holding a lot of a governance token, you probably want to do that in a multi-sig wallet or cold storage of some form. But if you're doing weekly voting, it's a lot more convenient if you can do that from a MetaMask wallet. And so a voter delegation system lets you do that. You can have your multi-sig delegate to your MetaMask wallet, and then it's really fast and easy to do that. So as we started trying to implement voter delegation, we ran into this problem. And the challenge is that the decay function, your voting power decays over time on Curve. And the reason for this is actually makes a lot of sense, and that is they don't want someone to be able to vote in the very last second of our lockup for something that would be harmful for the whole protocol. So you could vote in something terrible and then get all your money and get out and leave everyone else behind with a problem. And so the solution is you start off with a lot of voting power because you're committed for 4 years, and then and by the time you get to the end of your lockup, you go down to no power, and then you're out, right? And you have to recommit in order to get that power again. But the problem is, when you're trying to do voter delegation, the slope of these lines, how much voting power you have, changes depending on the length of the lockup. So here you can see, imagine these being two different users, one in blue and one in orange, and they both want to delegate their voting power to someone awesome like Erica and say, hey, we trust Erica to make good decisions on our behalf. And so here is the combined formula of how much voting power is. It's not very simple math to combine these two voting powers and express that. Common use case, of course, we want to be able to know what percentage of the total voting power you have, right? So we've got the two users delegating it to Erica. How much combined voting power do they have in the network? I could probably dust off some high school geometry and figure out a formula to do that, but it doesn't look particularly easy or ideal to represent. But that's just 2 users. What if we try 4? So again, 4 users, all delegating their voting power, different times, lockup durations. This is not, I don't know how you represent that in math, and certainly not in a Solidity contract. This is a real challenge. How do you do this? And then one of the brilliant engineers at Origin, Daniel von Fange, and well-known security expert in this space, asked a really important question. He said, what if we used an exponential decay instead of a linear decay? He called it radioactive decay. It's like the half-life of plutonium, right? We know that the half-life of plutonium is 24,000 years. We know that it's going to decay at a set rate no matter the slope here. So here we can look at what this would look like. So here again, we have our first user, this time with exponential decay. We add in a second one, okay? And now, because they're decaying at the same rate, combining the voting power from these 2 users is a lot simpler. It only changes, notably, the slope only changes when someone's staking. So when someone new stakes, it changes, that's it. And so it means we have way less writes on chain, and it means we don't have to iterate through these checkpoints and all these different times to calculate what people's voting power is. And so now when we look at it as a percentage of how much you have per user, it's much, much simpler than what we had before. We can do it again with 4 users here and see what it looks like. That's a lot easier. Again, you can see We only have to worry about it when someone's staking or unstaking. And so that means that when someone else stakes, your relative staking power goes down, and when someone unstakes, your relative voting power goes up. Kind of simple. So let's compare. Well, we have linear, the VECRV model requires weekly checkpoints. So you have 208 checkpoints across 4 years, and you have to check in each of these checkpoints what everyone's balances are. You've got expensive for loops iterating through those, and you've got lots of on-chain writes. You've got to store the time, the block, the bias, the slope, and you've got to think about both past and future slope changes to these different lines. On the exponential model, the VEOGV model, no checkpoints, no for loops, and we only need to write 3 things: the time, the block, and the points, because we know the decay function is always going to be exactly the same. The second thing we did, we realized there's another innovation here that can make things a lot simpler. And we were inspired by the way that you handle equity, right? So if you raise funding for your company and you issue a bunch of stocks to your seed investors, and then Andreessen Horowitz comes along and says, we want to give you $10 million, you don't go back to your existing investors and say, hey, give us some of your stock back because we need some to give to Andreessen Horowitz. No, you don't do that. You just print a bunch more, right? And then you give it to Andreessen Horowitz, and then everyone else is diluted. But what's cool about that is everyone gets to keep the shares that they have. And so this is the similar model we used here. We realized we don't actually need to decay anyone's voting power. We don't need to take it away from them. We'll give you your votes. You get to keep the votes. But over time, we'll just give out increasingly more to other people to dilute you. Right? Does that make sense? So this means that new stakers are getting increasingly more tokens over time. And then you get to keep the same number of votes, but as a percentage of your total voting power is decreasing over time. And that's how we implemented it. So here we have the VECRV model. You've got linear voting decay, number of votes decreases over time, and you need to go to the smart contract, the curve smart contract, to find out what the current weight is of your voting power. For VOGV model, we have the exponential decay. The decay happens via dilution. Number of votes you get stays the same. So this solves the problem we had of the integrations of all the different wallets and dashboards, not knowing how many votes you have. Now, you just look. You just look at how many tokens in your wallet. That's how many votes you have. And the only other thing you need to care about is how many total votes are in existence, and then that is how you determine your percentage voting power. And then one of the really cool things here is that also makes it compatible with OpenZeppelin's ERC20 snapshot. So that gives us a really, really cheap and efficient way to know exactly what anyone's balance is at any particular block. And so this is incredibly important for voting on different proposals, because you want to know this proposal was issued at this time, who had voting power at that block, and you can see all of that just by using the ERC20 snapshot plugin. So when we finally got done with this code, we were really happy. Not only with all of these features, we were able to knock out every single thing on our wish list that we wanted as far as improvements, and we were able to do it at a huge gas reduction. For a lock, 20% savings on gas. For an extension I want to extend my lock, 34% savings on gas. Unlocking or claiming, 51% savings on gas. Again, you have lower gas costs. It's less friction to get people to participate in governance. And finally, the delegation, which isn't even possible to implement on Curve's Viper contracts, we were able to get it done for only 102,000 GUI. And the reason for that is just it's so simple. We're just adding up the balances of how many tokens everyone has. So you're able to do voter delegation really, really cheaply and cost effectively. So there are a few quirks and trade-offs you should be aware of. One is that at the end of it, because it's exponential curve, it never gets all the way to 0. And so it gets down to close to 0, but doesn't get quite there. And then there's some residual voting power at the end that they still have until they actually claim their tokens. And we decided we were okay with that trade-off. This probably makes sense, but you're getting exponentially more tokens because it's an exponential curve, right? So in the curves model, you lock up 100 CRV. For 4 years, you get 100 CRV. In the VEOGV model, you lock up 100 OGV, and you'll get something like 1,000 VEOGV back in return. So it's more of an exponential curve. This means there's a greater difference between the people who are locking up for the long term versus the short term. But that is quite in line with our intended goals anyway, so we're okay with that as well. This is another thing. The voting power is, because we're only changing the voting power when people stake or unstake, if you're not having pre-active participation in your governance and people staking and unstaking, you're not going to have, people's voting power will stay the same until someone else comes along and dilutes everyone else. So you have to be okay with that. Obviously, you want to have active governance going on. Easy enough for you to come along and be that person to, to stake if no one else is doing it. So many of you are probably familiar with Uniswap's formula. The X times Y equals K. That's the magic formula that powers all of Uniswap. The magic behind this is every bit as easy. So the way you compute what VEOGV, amount of VEOGV you get, is based on how many tokens you have, times this constant K, raised to the power of Y, where Y is the end of your staking period. And so you can see here some different K values, and then how those different values impact the relative boost in voting power for locking for the maximum amount of time versus the shortest amount of time. And so we decided to go kind of extreme with it. We started at 1.8, which means you're getting about 10 times more power for locking up for 4 years than for the minimum of 1 month. But you can choose, so whatever K value you want for this. So if you want to use this, it's 100% open source. It's only 175 lines of code, and it has, uses standard Open Zeppelin libraries. It also has MasterChef style rewards distribution built right in. So you've all seen MasterChef style rewards, I'm sure, where you can add extra rewards for people who are staking, and that's something we're doing for people who are staking on our platform as well. All of it has been audited by Open Zeppelin. We have the audits out there, and it's live. So VEOGV.eth if you want to go check out the smart contract for yourself. We also have this cool dashboard, governance.ousd.com. You can actually play with this. You can go buy some OGV on an exchange or a DEX. You can lock it up. You can see how this works. As you can see right now, very generous staking rewards for people who are participating in this, as we really want to encourage people to check it out and help, help in this experiment of handing over control to our community. So I think I'm out of time, but I just want to remind you again, if you're interested in NFTs, you can go to story.xyz. If you want to learn more about Origin Dollar or play around with the decentralized governance we have there, OUSD.com is your best starting point for that. And finally, I would just say, none of this would be possible without the great work that Curve did. We truly are standing on the shoulders of giants, not only Curve, but also just everyone in this community. So thank you all. I'm Josh Fraser. Have a great night.
Thank you, Erica, and thank you for the comment. As a speaker, it's I know how it feels to start to get drowned out by the background. Well, to say the least. Anyway, thank you all for having me. It's awesome to be back in Korea again for Korea Blockchain Week. I haven't been here since 2019, which was one of the formative trips out of the U.S. and seeing the international space in the crypto world. So today, I'm going to talk a little bit about Web3, the next era of growth tools, what this actually means, and what I'm going to cover is really where I think we're going over the next 2 years. And given that, how I think we can maybe focus on some specific areas to speed up that adoption and ultimately better position this industry. For those that were here earlier or watched the live stream, Mike Brock from Polygon actually gave a fantastic presentation earlier today, kind of covering a macro view of this overall, how is the evolutionary cycle going? And he brought up some good points that I'll reference through this. For those watching the live stream, definitely recommend watching his talk. Him and I see eye to eye, and I would say he's giving the big picture. I'm zooming in on, I think, the next couple of years before whenever the next cycle kicks off. So just a little bit about me, from New York City originally, based in Hong Kong now, although pretty much nomadic at the moment. My background in the space is I was a early core team member of Blockstack, or Stacks. Joined in 2017, helped them scale their developer communities. More recently, I started my own company on top of the network in 2020. We do a bunch of funding, partnerships, things like that. And then I have a new startup with a number of co-founders, all from Hong Kong, all folks that have been in the space for probably 3-4+ years. And what we're doing is we're creating the kind of Web3 growth and marketing tool suite, not just for crypto native projects, but also for those who are starting to play with crypto assets on more traditional platforms. So I'll go into a little bit more detail on both of those at the end, but for now, let's kind of kick it off. So I just want to have this slide to level set for the talk. This is, for the purposes of this talk, how I kind of think of the building blocks of Web3, both in terms of concepts and capabilities. There's a million different ways I think you can present this and highlight this, so this is definitely not canonical, but I really think this concept and what we're driving towards with this technology starts at this basic concept of open, permissionless digital ownership. Anything we're doing in this space starts with that. On top of that, once you actually have the ability for an individual to prove and actually have in a concrete way digital permissionless ownership, you can now start to enable them to do things with that ownership, buy it, sell it, buy other ownership, put a price on it, and you start to create digital end-to-end economies which are made up of these incentive structures. The digital end-to-end economies are a big second part of the innovation here, because for the first time we have global 24/7 markets for this digital ownership. And the incentive structures in each of these markets is kind of how that behavior is directed. Lastly, and kind of finally, you have the atomic units of this ownership, or the incentives, which is really how I think of fungible tokens and NFTs, they're tools. But so if this is kind of the Web3 stack, and if these are the concepts and really what this enables, you know, I think one of the themes we've seen is that we all feel like we should be a little further by this point. There seems to be a general sentiment there. You know, there's still a lot of the UX is terrible in the space. There's still a ton of friction. You know, Mike Brock brought up great points that we're still, you know, pushing out descriptions of this space and marketing of this space to the masses in ways where we're describing the technology. We're not explaining the value to them. And I think it's all really valid, but, you know, if we do have this capability, why have we not gotten there yet? I think there's a lot of reasons. I think one reason, though, and one issue I've seen over the last few years, and I get why this problem has existed, is, you know, for the most part, everyone has been focused on launching tokens for the last 5-6 years, you know, whatever the exact time frame is. And I get why. You know, the ability to do permissionless global fundraising at the click of a button and, you know, raise a hell of a lot of money in some cases is a huge innovation. Now, as with many huge innovations, I think, you know, it was used in very inappropriate ways at different times throughout this, but that's part of the natural maturation cycle of a technology. That being said, I do think we need to increasingly get the focus off launching tokens. And kind of why is that? Well, there's a lot of text here, but the kind of overarching point that Benedict Evans is making, and for those unfamiliar, he's kind of a tech commentator and a VC going way back, and he hasn't really gotten Web3 historically, but to his credit, he's kept kind of working through it, and he's actually starting to get it, and I actually think some of what he brings in terms of his skepticism is well worth it for this space, because it's really asking the question, what is this for? What are these innovations best at? What are these tools for? And I think one of the problems with the focus being just on launching tokens, or predominantly over the past few years, is the fact that in a ton of cases, and increasingly as we create more and more different types of applications with these tools, the tokens and the incentive models on the Web3 part is really just the monetization method, the bootstrapping method, or the distribution method. It's not the product. Now, in a case of something like MakerDAO, that's fundamentally financial, yes, that incentive structure, that token structure is the product. That's why that works and has, you know, some sticky amount of user base. But something else, something like, let's say, STEPN, and I actually am not going to hate on STEPN at all. I'll come back to that in a second. But, you know, that I think was a great example of a pretty novel and interesting incentive and monetization mechanism, but without a fundamental product underneath it. And in addition to, you know, these things in many cases not being the product, one of the other consequences with that is it brings up a really interesting question of, so when do we launch it? You know, how do we launch it? And there's a lot more experimentation to do there. Again, I'm not really trying to hate on anything that's happened. It's not really how I see it. I kind of look at it as, you know, in some cases you wish certain things didn't happen, but this is the typical adoption curve of any sufficiently innovative technology that has ever existed in human history. I know there's a lot of people, especially right now, that are looking at the crypto space and kind of saying specifically, why are these guys so bad? And yeah, there's a lot of unfortunate examples in our space. You go back to any time with sufficient innovation like this, and you're going to see the same thing. I think we're somewhere, you know, especially at the phase between early adopter, early majority, whatever that means. I'm not going to put a year on it, because I think at these conferences I've heard that we're in 1995 or 1996 6 or 7 times. But, you know, if that is the case, if this is very innovative tools, and they do have some very interesting uses, but maybe we need to focus on some different ways of using them around some different types of products. You know, how can we just generally speed the adoption up from where we are today to where we're going? Well, I think to start, we need to begin to really focus on what the real innovations and value adds are here, and start looking at these things in many ways as tools, and being a little more honest with ourselves about what they're good at and what they're not. Just to define the real innovation, what I really see as the real innovation here is the fact that, you know, if the internet enabled anyone to publish a bit of information and distribute it globally instantly at the click of a button, then what Web3 enables is it enables an individual to prove ownership over that bit of information, and then a market to be created to put a price on it and globally trade it 24/7. That's huge. But so given that, one thing that I think is interesting is for looser ecosystems, communities that may already exist online, or certainly some of the newer Web3 ones, one interesting fact of this is it kind of changes the way you have to think about the monetization structure of that community. It's much less like company revenue. And it's much more analogous to something like an open economy GDP. Because again, for the first time, we're able to create fully end-to-end digital economies that do not have to be tethered to the fiat world at all, potentially. More importantly as well, given that, one of the things I think this technology is great for as tools is bootstrapping the supply side of a market. A few people have talked about this in the space, but my favorite example of this is a cell tower. network. When there's certainly demand for, let's say, a brilliant new cell tower network that is better than anything that exists. But what is the incentive for someone to go and build one tower? That has no value to the demand side. 2 towers has no value to the demand side. The only way to satisfy the demand side is basically to get, thousands of towers up, because then you actually have a network that's usable and satisfies that demand. But how do you incentivize that critical mass to be built in order to meet that demand? Well, the way we've done it in the past is basically governments give companies a bunch of money and contracts and mandate they do it. We now have open incentive structures that allow us to incentivize people to fill the supply side of a market when there is not yet demand. It also allows, and I think we're seeing a ton of this right now, and I think this is one of my favorite parts of the space, the ability to monetize digital commons, and also the ability to monetize community access, activity, and culture. Those are kind of 2 sides of the same coin. Examples there are, to me, one of the most interesting things about Bitcoin, and forgive me, I know this is ETH Seoul, but for a moment, I don't think of it as digital gold or as a store of value. Rather, what it is it's the first global commons we've had that, rather than falling into the tragedy of the commons, actually uses the things that create the tragedy of the commons within the system to create the desired outcome. And then obviously monetizing community access, activity, and culture. We're seeing a ton of this happen with NFTs at the moment, both in Web3 and more in Web 2.5. Just quickly, I won't spend too much time on this, but just unpacking kind of the main pieces here. Fungible tokens, in this kind of vein, I really think of as the blood cells of the digital economy, atomic units of incentivization. NFTs are much more the atomic unit of digital ownership. And NFTs, I really think if you zoom out and you think about how flexible and all-encompassing analog NFTs are to the real world, house keys, credit cards, I mean, the list goes on. Pretty much almost everything we use is an analog form of an NFT. The fact that we can now create that digitally is, yeah, it's going to revolutionize everything. But in a lot of ways, I think not necessarily in the way that we are thinking about it now is, just these digital collectibles. And then lastly, tying this all together is tokenomics, which this, I think, is a very latent science. In my opinion, 0 tokenomics experts exist in the world. It's too new a field. There are people who have done some amazing experimentation and learning who are certainly the furthest toward the expert side of the spectrum and are climbing that learning curve the fastest. But this is an incredibly disciplinary area of expertise where, again, with the focus on launching tokens, we just haven't experimented with it enough at all. When do tokenomic structures make sense to implement around a product? What types of tokenomic structures? Can you have a tokenomic structure that stays the same for the whole lifetime of a product, or does that need to evolve as the product evolves? It's a complete blue ocean of experimentation that we still have to do. I find that really exciting, personally. And to circle back a little bit, we're starting to see this happen in some very nascent ways. I think we're all familiar with this. The amount of, despite the market crashing, despite a lot of unfortunate events in the past 6 months happening in the space, this is only accelerating. And this is, in my opinion, the much more important thing to put your eye on than the market price is, where is this technology actually spreading to? How are people actually starting to use it? And this is where I think the mass adoption comes from over the next 2 years once we hit the next cycle. We spent the last 2 years getting a little too far over our skis in terms of the innovation that we've created and what we've been pushing. In that, we've created more and more different types of assets, layers for these assets to interact with each other. We've gone really deep down this crypto native rabbit hole, and I think that's great. All of those ideas are going to be extremely valuable, and I think the nexus of innovation in this space will always be the kind of core crypto community that really is playing on the fringes with what you can do with this stuff. But what I think happens over the next 2 years, And by the time we get to the next market condition being right for a run, whenever that is, one of the reasons that will happen is that everyone, almost everyone, whether they know it or not, will have an NFT or will have access to tokens, because all of these traditional platforms are already adopting these as just usable on their networks, whether it's Reddit, adopting NFTs for a number of uses, Twitter, Nike, I mean, the list goes on. There's probably a longer list of people doing this that happens every week than what's on this slide. And once that critical mass builds up more and more, well, now you have a whole different type of user base to start innovating on top of once the next kind of cycle hits the upswing. And so I think that's kind of where I think the next 2 years are. A lot of time is spent with these assets infiltrating traditional platforms. I think if you're any sort of digital platform, or in many cases real world platform, that already has a thriving community, but there's a lot of community activity that's adjacent to your brand that you don't get to capture and monetize. Community culture kind of being an interesting example in some cases, then these are very interesting tools, and you're seeing people kind of go down that rabbit hole. And so I think once we get there, then I think we can start on the evolution of some of these Web 2 networks become more decentralized protocols. Maybe we, let's see what happens with Twitter. But I think there needs to be a seeding of a critical mass of people with these assets through traditional platforms before that happens, and I think we're seeing that happen today. These are just some other points of, I think, where we kind of go once we have more and more of that critical seeding, but we'll see. And then briefly, kind of how I'm involved. So again, I still kind of work a lot on the Stacks project, run my own company there. For those that don't know Stacks, Web3, where it settles down to Bitcoin, we will have EVM compatibility by the end of the year, I believe, which will be very exciting for kind of a number of reasons. Essentially, smart contracts on Stacks allow you to natively control Bitcoin taproot addresses. So you can do things like mint, buy, sell NFTs, all with Bitcoin, things like that. And then Conductive, again, the user insights and acquisition platform for Web3. We have an engine that pulls in all Web2 and Web3 data we call the Conductive layer. And using that, we can enable a company to get an end-to-end understanding of their community, their users, and whether their strategies for making those users stickier and acquiring more users is actually working or not. Because from experience, I will say we've been flying pretty blind in terms of data in this space, a la the way Web 2 has, at least. But yeah. Hope you all enjoyed that. And if you would like to talk to me any more about any of these ideas, because there's a lot of ideas here, and each of them, I think, is quite a big rabbit hole to go down. You can either shoot me an email or follow me on Twitter. My DMs are open. And yeah. Thanks, everyone, for listening, and hope you enjoy your rest of your time in Seoul.
Thank you very much. Yeah, I just want to take the opportunity to thank Erica and the rest of the Crypto Seoul team for putting on such a great event. I think it's really important for the Asian ecosystem to start getting more opportunities for such high quality speakers and candidates to come in and participate in these events. So just anecdotally, I've been to the first ETH Berlin, the first ETH Denver, the first ECC, and just seeing the amount of quality of candidates that kind of come out there, the value they create for the ecosystem over the next few years is amazing. And I'm excited to see what you guys have created over the past few days and will over the next few months and so forth. So today I wanted to kind of provide a little bit insight to what's been happening on the upgrades related to Ethereum, what that means from the staking perspective, and what it really means when the merge is coming. There's a lot of misconceptions that people really can't wrap their heads around. So it's not going to be too technical. The purpose of the talk is not to dive deep into the technical nuances of this technology, but to just clarify all the misconceptions that do exist and that we usually come across on a daily basis. So as mentioned, my name is Akil with the Ethereum Foundation, also lead some product and design projects for the leading client teams like Status Nodes and Lighthouse and so forth, trying to make Ethereum staking and node operators tooling a lot more easier and accessible for the rest of the community. If you do need to reach me, you can easily find me on Twitter at QNOU, scan that QR code, or just simply talk to me after the event. Also, if you do have more informational needs around these topics, please do check out the Ethereum website. The team has been doing a great job making this information very accessible, easy to understand, and there's a large team of volunteer translators that come in and translate this information as well. So if you do have Korean skills and are able to translate some of this information, that would be amazing for you to get involved. All right, so as mentioned, over the past few years, there's been a lot of talk about the move to proof of stake. Since I've been involved in the ecosystem for over 6 years, we've been talking about Serenity. The names have changed. It's gone from ETH to now the merge. But at the end of the day, the core issues and the technology that we've been working on has been a part of the core Ethereum roadmap for the longest time. So when people talk about like the merge is delayed, in the context of the longer term, these delays are very small blips. This technology, these problems have been looked at and been tackled for a very long time. And it's very important that we get these right rather than rushing into something just because there's external pressure coming in. So from today on forward, if anyone that kind of asks you what's going on with Ethereum, what ETH2 is, what the merge is, you basically tell them that Ethereum is moving to a more sustainable and a secure home. So even though there's a lot of changes that are happening on the back end, the front end, the users are not really going to see any impact. Additionally, the only impact will happen is for individuals that are using our validators or running nodes, etc. So from your perspective, or if you're a normal user, please don't fall for any scams telling you to update your wallets or anything that related to that. So I think it'd be important to kind of highlight why we are moving to proof of stake in the first place, what that means, and what are the benefits of actually moving to proof of stake. As we're all aware, there's a relative energy consumption when it comes per transaction. So for instance, the Bitcoin energy consumption is quite high in relation to the Ethereum proof of stake consumption. Proof of work consumption. But when we move to proof of stake, that decreases exponentially even lower to the point that running a node or a validator is equivalent of running a personal PC. So one of the biggest benefits is that reduction in energy consumption, which leads to us actually requiring less Ether issuance to incentivize participation in the network. We'll talk a little bit more about the ETH issuance and what impact it has with other factors as well. On top of that, there's lower barriers to entry and increased accessibility for participation. So this means that an individual with a normal home computer, a laptop, maybe a Raspberry Pi can now actually create blocks on the blockchain. And hopefully, at some point, mobile phones can come into the ecosystem with some line clients and other properties as well. Additionally, because of that lower barrier of entry, this also improves the security and decentralization of the ecosystem. So more individuals come in, there's more validators, there's more nodes running. That means that we have more distribution, more decentralization in the ecosystem. And on top of that, it also causes us to have much cheaper security for the same price. So there's actually like a 5 to 20% gain for the cost per security when you move to proof of stake. In addition to that, the 51% attacks become a lot more expensive for individuals to try to execute on. And that if someone does actually succeed, we have better recovery mechanisms. So the community can actually choose to adopt a chain that was truthful and not choose the 51% attack. This was not possible with proof of work. and will be coming in as well. Additionally, this does not bring in scalability, but it allows us to have better secure implementations of scaling solutions like sharding. You'll have more opportunities, obviously, to learn about sharding implementations related to Ethereum over the next few years, but it's just a clarification that scaling is not coming with the merge, but it does provide opportunities for us to start implementing some of that stuff later on. So some of the common misconceptions are, is ETH2 coming soon? The answer is no, but the merge is, and we'll talk about what that actually means a little bit further. Is Ethereum moving to proof of stake from proof of work as a consensus mechanism? Yes, very soon. Will there be a new Ethereum mainnet coming? No, the execution layer will remain the same. So the network that you're used to using right now, the transaction history, everything stays consistent. You don't have to worry about anything, and you continue as you were. Will there be a new E2 token for stake Ether? No, it's the same token that's been locked up in the beacon chain, and it will continue to be so. Will there be a proof of work consensus layer that will stick around after the merge? No. Will there be a fork in the Ethereum after the merge and maybe a proof of work chain emerges? You've been seeing a lot of noise about this on Twitter. Realistically, there's no incentives. There's also some technical issues around chain IDs not changing. So the likelihood of someone actually trying to sustain a fork is very highly unlikely, but you never know. So I'm guessing a lot of you are still asking, but really, when E2? And the fact of the matter is what you guys really thought about as ETH1 or ETH2 is really the execution layer and the consensus layer coming together. And what we get at the end of the day is just Ethereum once again. Just a small inside joke. That little dog was something we saw on the street that looked like a little panda. We can't take it back into Canada. If anyone from here wants to adopt it, please do so. It would be amazing. So as mentioned, the merge is coming, and you can scan that QR code to kind of read the blog post about why the naming happened around calling it the merge, what complications it's trying to address, and so forth. But internally, as an organization, we kind of frame this narrative around the merge as an upgrade that we're doing to an engine mid-flight. So the spacecraft has to continue flying and operating, and this change has to actually happen simultaneously. So there's no downtime, and that even the network doesn't really need to know that the change has happened, and all this needs to be automated. So that's one of the biggest complications with the merge, is that all of this needs to happen automatically, and that it needs to happen in tandem where nothing causes some sort of catastrophic downtime to the network. So as long as we are going through the process of the testnets, et cetera, is to ensure that the quality and the security of the network is in complete. So this diagram actually kind of shows you the Ethereum roadmap in relation to the merge and where we are in relation to the merge. So basically, we're currently at the bottom of the stack where the Ethereum state and the execution layer is paired with the proof of work consensus mechanism. So the transaction, dApp, contracts, accounts are on the execution layer, and then moving in tandem with the proof of work consensus. But in December 2020, the beacon chain launched and started running in tandem with the rest of the chain. But the consensus layer for beacon chain is drastically different, that the beacon chain does not have the transactions or the contracts or the accounts baked into the beacon chain. So it's just only there to serve the purpose of the consensus mechanism. And when the merge, when the Bellatrix upgrade and the Perispark upgrade happened to kind of allow the cross communication between execution layer and the consensus layer, that will trigger the TTD to start the merge. And when that happens, we'll basically just cut off proof of work and continue with the proof of stake. And what actually happens in that case is, as you can see currently with proof of work Ethereum today, the execution layer kind of is housed with the transactions, base fees, all that information within the proof of work mechanism, and we just basically pick that up and put it into the consensus layer as so. So essentially, the network that you're used to is still operating. It's just now wrapped in a different consensus mechanism, and you really don't have to worry about any of the network being different. So some of the biggest misconceptions, as I mentioned earlier, were, will these upgrades actually reduce transaction fees? No. So there will be no direct impact on network activity fees, but there is more work being done in this regard related to MEV and so forth at the protocol level. And then will this increase scalability and throughput of the blockchain? So no, scaling on Ethereum will actually come through a roll-up-centric roadmap, and then layer 2s will address scalability issues without compromising decentralization, and then also rely on the security models of Ethereum on the layer 1. Will Ethereum continue working on sharding? Yes, it will come post-merge, and you can learn about that more as necessary. Will ETH issuance decrease after the merge? So yes, it will decrease by approximately 90%. And then if you couple that with the burn of the gas fees, this actually means that ETH inflation will be net zero or negative. So Ethereum basically becomes a deflationary asset at that point. So people have an issue about why we don't really have clear dates around the merge and when it's happening. And one of the reasons is, unlike other forks or upgrades, we're not really relying on block numbers as a timing mechanism, but rather a terminal total difficulty, which actually allows for better risk assurances. There's no risk of actually uncovering another chain. The cost of actually spending that hash power is similar to on mainnet, so there's really no incentives for people to try to game the system. So in this situation, clients listen for the total terminal difficulty, and when the client sees a block that has a higher difficulty, it initiates the process. And once that block is seen with the total terminal difficulty that's higher than the TTD, it will be deemed the final POW block. That means that any future blocks that are created will be on the beacon chain. And then the transition is complete once the TTD block has finalized on the beacon chain, and then the clients stop gossiping POW blocks altogether. So in the concept of like the merge roadmap, where we are is very close. So essentially in the next 4 or 5 days, the TTD for Goerli testnet will be initiated, and that's the last testnet right before the merge. And after that, we'll hopefully get to the mainnet, perhaps before DEF CON, but there would really have to be a catastrophic issue if we didn't go past December. So it's hopefully within the next few months and before New Year's, essentially. So some more common misconceptions is, do I need expensive hardware to become a validator? So technically, no, validator clients can actually be run on smaller devices such as Raspberry Pis with like their right client and software hardware pairing, and are quite energy efficient, as mentioned, to a computer device. Do I need to actively participate in Ethereum staking? Yes, so Ethereum is actually not a delegated proof of stake ecosystem, and requires you to actively validate and make attestations on the network to earn your stake Ether, but there's also other solutions like pool staking services or staking services that allow you to kind of get that experience. Do I need to have 32 Ether to stake on Ethereum? Yes, currently as an independent staker you do. As mentioned, there's other services that allow you to pool your Ether to kind of get those opportunities. And there's also work being done on distributed validator technologies that will obviously be a boon for the Asian ecosystem to be able to afford these staking machines, because that's not a small amount of change. Will withdrawals become available at the merge? No. So withdrawals will become available in the next update, which is probably 6 to 12 months post the merge at that point. Will transaction rewards be available at the merge? So yes, the rewards from transaction fees will be provided to the validators immediately, given that you've provided the proper fee recipient address to the client software. So if I stake and my validator goes down, will I get slashed? So this is one of the things that people are most afraid of when they're trying to think about validating or staking on Ethereum. The answer is no. Slashing is actually a mechanism designed to punish bad actors, and usually occurs in very rare cases, maybe like 0.2% or something has occurred in the past. Usually is because they try to run redundant systems, and it's encouraged for individual and solo stakers to not really try to do that. Do I need 100% uptime to remain profitable? Again, this is a misconception. You really don't, but it is important that you do try to keep a healthy node, and then your proportion leak is quite in line with the revenue generation. So if you go down for a few days, or a few weeks, or in the year, you're really not going to be impacted too drastically. Should I be running a minority consensus layer client? Yes, not only for the health of the network, but if you're with the majority client and something goes wrong, you actually get penalized more than you would if you had something go wrong with the minority client. So that's something you need to be aware of as well. And then I need to run an execution layer client? Yes. So with the merge, everyone that was running a node also needs to run an execution layer client. And then it's just as important from a decentralized perspective to choose a client that isn't Get or a majority client. And we're actually at a position in the ecosystem to kind of like change that narrative and then have an equal opportunity to use some of the other clients with the merge. So getting started with Ethereum staking, there's a few options for you. You can have solo home staking, individuals just running their own nodes. This is the dream for decentralized networks. Basically, it's the most impactful, it gives you full control, full rewards, and you operate in a fully trustless manner. On top of that, there's staking as a service, so they use your 32 Ether in a whole. They utilize your validator keys, but then you entrust your node operations to these services to take care of, and they take fees on top of that. In addition, there's pooled staking, so services like Lido, a Rocket Pool, where you can stake any amount, earn rewards. It's pretty simple, and these are quite popular, and we'll see how much of the ecosystem is kind of relying on these technologies versus actually taking the ownership of their nodes at this point. And then the least impactful is actually centralized exchanges, and it's not really recommended that you rely on those for staking. So as far as the different Ethereum consensus clients, there's 5 top clients at this point. The community has actually done very amazing work to make sure that none of the clients are majority over 33%. We're getting better and better health over the network there. But as mentioned, at the execution layer, we still have issues with Get having most of the majority close to 80%. And this is where some of the focus needs to be. If you want to learn a little bit more about how to stake or get involved with staking from the Launchpad, you can visit that website or scan that QR code. So this is one of the main reasons I came to Seoul, and I really appreciate the work that Erica and Crypto Seoul are doing with bringing more events and more coverage to Asia, because most of the validator nodes are currently being operated within Europe and North America, and as you can see, South America, the MENA region, and Asia has very little coverage. And we talk a lot about decentralization and what we wish to accomplish as far as this ecosystem being accessible to everyone, but the consequences of our actions are that we might be making the same mistakes that existed in past systems. So Seoul or South Korea is only represented by 0.7% nearly of validators, similar to Japan and so forth. So it's really important that you guys that have opportunities to educate individuals about the nuances of decentralization and the purpose of why we're even in this ecosystem and what we're trying to accomplish. It's really important that we try to look at it from a macro perspective and how we can do a better job of educating people. So as mentioned, staking deposits by category, majority of individuals are still using staking pools and exchanges because of the complications around UX and the resources that are required and the education that is required for people to actually start running nodes or validating on the network. So if you do have the skills or the interest, there's a lot of opportunity for you to get involved in creating tools and resources for people to actually understand some of this technology a little bit better. So as I was mentioning, we talk a lot about decentralization in the ecosystem, but the reality is the majority of key ownership is controlled by centralized exchanges. Node infrastructure is happening on cloud, Amazon AWS. Data availability is all coming from Infura. Staking is being controlled by centralized exchanges, staking pools. Network security is at risk through majority clients. And then dApps are even seeing centralization effects with certain things such as like OpenSea taking control. So we have to be really mindful when we're focusing on projects to work on, technologies that we're trying to create to really keep decentralization at the heart. and try to incentivize and educate individuals that are coming new to the ecosystem to make sure that they understand this is the core value and these are the core issues that we should also be looking at when looking at the value proposition that we bring to the ecosystem. So another misconception is that you need to stake to be a node operator in the Ethereum ecosystem. That's not true. You can actually run a node, and this is a great resource for you to kind of learn and get started. The first thing that I did when I got into the Ethereum ecosystem was try to run a node, and I encourage everyone to kind of learn about the privacy, security, start relying less on third-party servers, especially if you're developing dApps, resources, et cetera. It's really important for you to see the core of the censorship resistance, improve the health of the network, and then kind of take ownership and participate in the network more intimately. On top of that, what do you really need to get ready for the merge? So as a staker or validator of the network, you need to be following updates that are coming from the foundation on the blog regularly. You should be testing and participating in testnets to make sure you're ready for the switch. Make sure that you are now running the execution client as mentioned earlier. But as a regular user, you should not have to do much. Just be aware of scams and make sure you're not falling for any traps. And then as a developer, if you're using any block numbers as a proxy for time, so going from like 30 seconds and some variance, you'll actually have to change that to always be a multiple of 12, and that will be more true after the merge. In addition, if you want to learn about becoming a validator or staking or running a node, join the Validator Academy. It's going to be a very easy, explain it to me like I'm 5 resource where we provide information about how to understand some of these complications around how to run this stuff, provide some UIs and so forth, and hopefully this will be coming in time and along with the merge. Also on top of that, if you have the opportunity, please do come to DevCon Bogota. I know tickets are quite difficult to grab, but there's a lot of amazing events happening post and pre-event. And there's a lot of opportunities for you to really ingrain yourself in like a third world economy, learn the impact, and we're trying to really get a lot of encouragement around Asia and other regions as well. So it would be great to have more representation from these regions participating in the event. And also, if you have the opportunities, please do attend ETH Ho Chi Minh. It's amazing that we're getting more representation in these regions, and we'd hope to see more and more individuals come to that. Thank you very much, and that's it.